of Coding Bootcamp 2022. This session is on time to work with date and time. I am Kevin Bond, author of the textbook How to Program Effectively in Delphi for AS A-Level Computer Science. The book covers a wide range from fundamentals to web-based applications and the Arduino. It is suitable for anyone wishing to become familiar with Delphi from beginner to advanced developer. What this talk is not about directly is the arrow of time, but it is about using counters built into the hardware on which Delphi runs. A counter is used to count clock pulses or ticks, and a time interval is obtained by multiplying the number of ticks by the tick frequency. Physicists use the concept of entropy to distinguish the past from the future. Delphi programmers can use TTimer or getTickCount or tStopWatch to do this. The presentation covers how to use a timing component, TTimer, from the VCL.external controls unit and the fmx.types unit to create an event that can be responded to. How to obtain a measurement of a time interval using getTickCount and getTickCount64 from the WinAPI.Windows unit, tStopWatch from the System Diagnostics unit. How to obtain the current date and time using the tDateTime data type from the System unit. Working with dates and times in Delphi using date and time routines found in the system.sysutils and system.dateutils unit. Let's get started with the first demonstration. I've created a VCL application and added three components from the component palette: a TTimer component, a TImage component, and a TMedia player component. I've set the TImageAlign property to AL client so that it fills the form. I've double clicked the timer component to create an event handler that is run when the application receives the WM_timer message from the operating system, because the TTimer unit is using a timer stroke counter built into the hardware of the machine on which Delphi is running. Now Delphi converts this to an on-timer event. I've then added code to play jungle sounds and to load the next image, and I construct the file name of the next image by appending number string to the string imgp, and I've got a counter here that is counting up from 0, so that the number string will the first time through will be 0 plus 16, which will be the string 16, and that will be added to the literal string 0, 0. The next time through, counter will be 1, so it's 17 that will be added to 0, 0 to form the string 0017, and then the next file to load will be imgp 0017. The timer component on the form is set to trigger an on-timer event every 200 milliseconds. So we've set the interval here to 200 because the timer counts in milliseconds, although it is only capable of resolving 10 milliseconds. So it will increment the timer in 10 millisecond increments. Okay, let's now run this and see what we get. We can discover which page of the component palette the TTimer component comes from. We can type in TTimer and see that it comes from the system page. Similarly, for the TImage component, if we type in TImage, you see it comes from the additional page, and the TMedia player comes from the system page. Timers are often used to assess how long a particular algorithm will take to solve a problem compared to a different algorithm that solves the same problem. But an algorithm must exist in the first place. If an algorithm exists, we say that the problem is computable. If no algorithm exists to solve the problem, we say that the problem is non-computable. Here is an example of a non-computable problem: the 8 puzzle problem. The puzzle has an initial state I. The objective is to reach the goal state G from the given initial state I by sliding the numbered tiles where this is possible. Unfortunately, there is no sequence of steps that will achieve this. Therefore, any algorithm that attempts to solve this problem will not terminate for the given initial and goal states. The problem is not solvable, and therefore the problem is non-computable. To see why, consider the number of transposition or exchanges required to turn 238,614,75 into 123,456,78, ignoring this blank here. And we see that the number of transitions counted here, so it's 8 just replaced to 6, swap with 6, and then 1, and then 4, and then 7, then 5. That's 5 transpositions. 7 is 1 transposition. 6 is 3 transpositions, so it's 6 to 1, and then to 4, and then to 5, and so on. And if we add these up, 5, 6, 9, 10, 11, it's an odd number of excuse me, of exchanges. Now, if we look at this, the number of transpositions required to turn 1, 2, 3, 4, 5, 6, 7, 8 into 1, 2, 3, 4, 5, 6, 7, 8 is 0, an even number. Now, it turns out that odd to even is not possible. Odd means that after any number of exchanges, there will always be at least one tile out of sequence. There is a computable solution, i.e. an algorithm that does exist, if the initial state is 834,651,27. Now, if we look at the number of transpositions required to turn 834,651,27, ignoring the blank here on the end, into 1, 2, 3, 4, 5, 6, 7, 8, it's 16. And I've done them here, so that you can check them for yourself if you obtain a copy of the slides. And as we said before, there are 0 exchanges to go from the goal state to the goal state. So that's an even number. So this means it's an even to even, which is computable. If a problem is computable, it is said to be tractable. If it is non-computable, it is said to be intractable. I have created a cross-platform app for the tractable solution and a cross-platform app for the intractable solution. Both may be downloaded in source form from the download link or from learndelphi.org. The URL for the download link will be supplied later in the presentation. So it is possible to solve this problem. I won't go all the way to the end, but it's impossible to solve this problem. And here is the tractable solution running on my Samsung SH mobile phone. Even if the problem is an algorithmic problem, i.e. a tractable problem, and it is computable, whether a solution can be produced may still depend on the size of the input and the amount of work that the computer may need to do. So we look at the time efficiency of an algorithm. It's a theoretical time measured by hand in computational steps, arrived at by counting the number of steps the algorithm makes to complete a task. More steps means the algorithm will take longer than another algorithm requiring fewer steps to complete the task. So more steps means more time consumed. So if we had to climb to the top of the building, that would involve more steps than if we took the lift. And the total time would equal the number of steps times the step time. Now, by divorcing the time it takes to solve a problem from the actual implementation on the computer, we can compare one algorithm with another, because we're not dependent upon how quickly one computer works compared with another. If we ran two slightly different different algorithms which solve the same problem on two different computers. For example, suppose we are tasked with calculating the sum of the first n natural numbers, i.e. 1 plus 2 plus 3 plus 4 all the way up to n. The first algorithm involves a number of steps. The first algorithm, which varies with n as follows. There are 3 assignment steps here, an input step here, an output step here, a comparison step here, 2 assignment steps here repeated n times within the while loop, 2 addition steps repeated n times within the while loop. Now let's consider the second algorithm, which involves 7 steps, whatever the value of n. There are 2 assignment steps, this one here, an input step, user input, an output step here, an addition step here, a multiplication step here, and a division step here. Setting aside whether or not each of the different types of steps, assignment, addition, etc., are worth different amounts of time, algorithm 1 takes more steps than algorithm 2 to do the same task. So let's now implement these 2 algorithms and see if we can time how long one takes on the same input as the other. Here I've created a console application and I've saved it as sum to n looping algorithm 1. So this will implement the first algorithm. I've added system.diagnostics to the users clause because I want to use tStopwatch. So first of all, I create a stopwatch and assign it to the stopwatch variable. Then I'm going to test to see if this is a high resolution timer, and we'll write out appropriately high resolution timer or not high resolution timer. I'm going to collect the input n, and then I'm going to start the stopwatch. So I'm only going to count the, if you like, the business part of algorithm when I'm going to ignore this, because this could take a variable amount of time depending on how quick or how slow I am at typing in a number for n. So the algorithm initializes count, initializes sum, and it performs this while loop, incrementing count, adding to sum. So the first time through, count will be 1 and added to sum 0, so that will be 1. Next time through, sum will be 1 and count will be 2, so that will be adding 2, and so on. And then when this loop exits, we'll stop the stopwatch, and then we'll write out how many milliseconds have elapsed. Then I've actually included algorithms too in the same program. I'll reset the stopwatch back to 0. I'll start it, and now we'll perform this method of counting the number of integers from 1 to n. And then we'll stop the stopwatch, and we'll again right line the stopwatch.elapsed milliseconds value out to the screen. So we can actually repeat this, because we're going to invite the user to type no to stop executing the program, or any other key to continue. So let's run this and see what we get. So this is a high resolution timer. I'm going to input 10 million. So if I've got that right, 1, 2, 3, 4, 5, 6, 10 million. Okay, so if I run this, I get 25 seconds. Let's have another go. And now I'm going to input 100 million. And we get 259 seconds. Sorry, I didn't mention that the second output is the second algorithm. And you can see that the time it takes to execute isn't even within the resolution of the timer. So now let's try 1,000 million. And it takes 2562 milliseconds, whereas the other one still is at 0. So you can see, if I increase the input by 10 each time, the output, the time it takes to execute algorithm 1 implemented in Delphi in the manner in which I've shown you goes up by a factor of 10, roughly. So you can see that the this particular algorithm is linear in time. So I'm going to stop this now. Just to recap, the first algorithm, algorithm 1, on an input of 10 million, took 25 seconds. Algorithm 2, the time it took could not be resolved. The first algorithm on input 100 million took 254 milliseconds, and again this could not be resolved. And then on 1000 million, the first algorithm took 2548 milliseconds, and the second one again could not be resolved. So as you can see, this goes up roughly by a factor of 10. Now, T-stopwatch provides a high resolution timer, as we've seen. The accuracy of high resolution timers is around a few hundred nanoseconds. A nanosecond is a unit of time representing 0.000000001 seconds, or a billionth of a second. Function getTickCount and function getTickCount64 return the number of milliseconds since the operating system started. GetTickCount returns a 32-bit D word which wraps every 49.7 days. Therefore, it is better to use getTickCount64, which has been available since Windows Vista, which uses 64 bits. Unfortunately, the resolution of the system timer, which getTickCount and getTickCount64 rely upon, is typically in the range of 10 milliseconds to 16 milliseconds, very much like the TTimer component. So I've got two demonstration programs here. The first one uses getTickCount, and we need to include the WinAPI.Windows library or unit to gain access to getTickCount. We're going to create an unsigned 64-bit integer variable called ticks, and getTickCount will return the current number of ticks since the operating system started. We're then going to use the sleep procedure to sleep for 1 second. That's basically 1,000 milliseconds, because the sleep timer counts in milliseconds. The program execution will be paused therefore for 1,000 milliseconds, and then we're going to write out getTickCount. So we're going to access getTickCount for a second time. So it will actually be a greater number than, or greater count than it was at this point. So we're going to take away the value that we stored in ticks. So we should get the processing time for sleep 1000. And then we're going to convert this uint64 value to toString, and we'll report this using WriteLine to the console window in milliseconds. And we're also going to repeat this with getTickCount64, and we're going to try sleep 10 and sleep 15. Let's now run the actual program. It's as described in the previous slide. So if we compile and run, we get for sleep 1000 milliseconds, 1015 milliseconds as the processing time. Well, the resolution, as I said, was around somewhere between 10 and 16 milliseconds. We'll run it again to see if there's some reproducibility. Oh, this time we managed to get 1000 seconds. Let's run it again for a third time. And this time it's 1016 seconds. Let's change this to 10. So we're going to sleep for 10 milliseconds. And let's run this. And it's recorded as 15 milliseconds, which, as I said, is the resolution of getTickCount. So let's check for reproducibility. Let's run it again. And again, it's 15 milliseconds. Of course, it's not going to be precise because you don't know also what's going on in the background that might interfere with this program. But it gives you an idea of what getTickCount is capable of doing. So if we change this to 15, and let's see what we get. Sleep for 15 milliseconds. Oh dear. And it's 31 milliseconds. Let's check for reproducibility. Oh, 16 milliseconds. And this time it's 31 milliseconds. So it's not advisable to be working down at this number of milliseconds because of what's going on in the background that one is not in control of, and plus the fact the resolution is 10 to 16 milliseconds at best anyway. Okay, so let's have a look at the Count64 and run it. Beg pardon. We're not actually running the getCount64. We're still running getTickCount. So now we'll run this, and we get 1000 milliseconds. So if we run it again, check for reproducibility. Oh, sorry, I did something wrong there. So It's 1016 seconds. So I suspect very much again that the resolution is at around about 16 milliseconds. If I try 10, 32 milliseconds, as in the case of get tick count, and if I try 15, 32 milliseconds. So that's get tick count and get tick count 64. Let's now take a look at time and dates. Values may be dates, for example, the 28th of the 5th, 2016, or a time of the day, 15:35:16. Internally, these are just bit patterns. For these bit patterns to have the meaning date or the meaning time of day, the bit patterns must be data typed. This requires a data type date and a data type time, or a combination of the two, a data type date time. Delphi uses the latter and names this data type T-date time. So T-date time is a data type double with the date as the integral part and time as a fractional part. The date is stored as the number of days since the 30th of December 1899, and this date is historical and it's associated with a bug in Lotus 123, the world's first spreadsheet, and so a correction had to be made from the 1st of January 1900 to the 30th of December 1899, and that's all I know. But you can look it up on in Google if you search for it. But it does seem a bit bizarre to be such an odd year and date. T-date represents a special type of T-date time value that has no decimal part. A T-date value represents the number of days that have elapsed since this 30th of December 1899. T-time, on the other hand, represents a special type of T-date time that has only a fractional part and no integral part. A T-time value represents the fraction of a 24-hour day. For example, 0.25 represents 6 hours. 0.25 represents 6 hours, 0.5 represents 12 hours, 0.75 represents 1800 hours. In actual fact, T-date time is its own special type defined in the type unit as T-date time equals type double. So it uses the keyword type in front of double as opposed to just saying T-date time equals double. This form of type definition forces the compiler to create a new distinct type called T-date time. Now let's drill down and look at some useful utilities for working with time and dates. Now returns the current date and time as a value of type double. For example, 43707.45404. So it is to 5 decimal places usually. Date returns only the date as a value of type double, as shown in the example. Time returns only the time as a value of type double. So it's the fractional part to 5 decimal places. Date time to string, or str, converts a date and time value into a string. And there's the example. Date to string converts a date value into a string, and time to string converts a time value into a string. So the above routines are functions. So let's have a look at program date time routine now. So program using T-date time basic is loaded into the IDE of Delphi 10.4.2. We seem to have 2 string utils here for some reason, so I'm going to remove that. Now we've got a write line that calls now, and it allots 5 decimal places for the fractional part and 10 display positions. Similarly, date 5 decimal places and time 5 decimal places. We're going to convert now to a string,
and we're going to convert now the date part to string, and now the time part to string. So now we'll return a data type value t date time, so we'll have both the date and the time combined into one double value. So let's have a look now at the running of this program, and let me just enlarge this a bit, properties. So I'm going to change the font to, let's say, 24. Okay, so if we just line this up, this is now, so this is the date part, this is the time of day part, this is date, this is just the integral part of this t date time value, time is the fractional part of this t date time value, and then we're going to convert date time to a string, and the string is set up to format as shown there. You can alter this layout format, and I'll show you how to do that in a subsequent program that I will be demonstrating today. This is just the date part, and this is just the time part. Let's now look at how we can format dates and times using a global variable of called format settings of type T format settings. We can use this function format date time to set up the particular format that we want. We call now to get a T date time value for the current date and time, and we apply these the default format settings. Now we're actually going to change the format settings. With respect to the date separator, we're going to make it a space, and the time separator we're going to make colon, and then we're going to format date time with this particular format, and we'll call now to get the current date and time and apply the format settings. Then we'll stick with the space for the date separator, but we're going to change the time separator to a dash, and then we're going to use this format, but this actually will override this, so I will change this in a moment to see what the effect of this is without that. Okay, so let's run this, and so if I try and move this over slightly, so we want that to be positioned like so, and I'll move this slightly, and we'll bring up this, and try and line this up. So this appears as Thursday, August 2022, and it is 3 minutes past 12 in the afternoon. So this is Thursday, month, year, hour, minutes, seconds, and fractions of a second, and AM or PM means that we take cognizance of this, and so it's PM. The next one uses date separator space and colon for the time, which it does indeed, and then this last one we've changed the time separator to a dash. Now this time I've taken a copy of this and placed it here, because if I have a space here, then that will override the forward slashes here. If I were to just comment this out, unfortunately I still have this, and so format settings, the global variable, will still override this. So what I'm going to do is, yes, I will take that out just for the moment, but by taking a copy of this, the format settings will be the default ones. Will work with format date time, which will literally output this forward slash and this forward slash to the console window. So let me show this. Oh, because I've already got this running, so I've already compiled it. Well, let me compile it again so that it is clear that we're working with the current program. So you can now see that this format date time has used the actual name of the day of the week, the actual name of the month, and it's included these literals here. Okay, now at this point here, the global variable will have its date separator set to a space. Actually, I think it's 2 spaces, but I don't think that will result in 2 spaces. I think it will result in 1 space. And now we are trying to use format date time to include this literal here and this literal here, but unfortunately format settings overrides format date time, and so we end up with a space separating Thursday, August in 2022. So what we would have to do is we would have to sorry, I'll stop this program running. I will actually have to physically go in and put in a forward slash. So now I'm updating format settings which had its date separator set to a space, and now we're resetting it to forward slash. So let's run this program, and indeed we have reinstated the forward slash. Just going back to this, I'll explain this in a little bit more detail, but this particular format, this one here, is the short form of the date, and so if I wanted to separate it by forward slashes, what I would have to do is I would have to put a forward slash in here. Okay, so let's do that, and we get our 2 forward slashes. Of course, the reason why I had to change the space to a forward slash here is because I have to reset the date separator. If I don't change it to space, then we will actually get the action of this format string here. So if I actually run the program, you'll see that we get the default 18//08/2022, which is the default format for C. It was because previously I'd overridden the date separator in the global variable format setting to set it to space, that format date time was forced to use a space separator here and here. So let's take a look at the format settings specifiers. C, which we have used, displays the date using the format given by the short date format global variable, followed by the time using the format given by the long time format global variable. The time is not displayed if the date time value indicates midnight precisely. Take a look at short date format and long time format global variables to see what you can do with them. So D displays the day as a number without a leading 0. DD displays that as a number with a leading 0, displays that as an abbreviation given by the short day names global variable, displays the day as a full name, which we have demonstrated using the strings given by the long day names global variable, and so on. M displays the month as a number without a leading 0, with a leading 0 as an abbreviation, the full name as I've demonstrated, and so on. Format settings can be used to override the format date time. Format settings is a global variable of to format setting record type in Delphi. So it has several record fields which you can alter to override the format date time formatting, and you can use it to get local information such as date, time, format, currency, format, decimal separator. This variable was introduced in Delphi XE. Now let's take a look at an application which combines the use of the TTimer component with tDate time and some of the functions or utilities which I haven't demonstrated to date, but will be necessary in this particular application because we will need to obtain the hour, the minute, the second, because we need to do some calculations in order to work out where these graphical elements need to be positioned to reflect the current time for the particular time zone. So I will demonstrate this analog clock in a moment. This is based on an idea from Harry Stell's book Cross-Platform Development with Delphi 10.2 and FireMonkey, because this is a FireMonkey application, a cross-platform application. And I developed this with Harry's permission, extending his cross-platform application by adding these time zones. Here is the application running on Windows, and this is showing Greenwich Mean Time. If I show the time zones, and let's see what it is, Australia, Sydney, this moment in time. So you can see it is 20, just gone past 20 to 11, and if we have a look at let's find South Africa. South Africa Standard Time. So it is just past 20 to 2 in South Africa. Here it is running on a Samsung S8 mobile phone. And here it is running on an Apple Mac alongside the tractable problem that I demonstrated earlier. Here we see that the timer component has been set to an interval of 1000 seconds, so it's going to generate an on timer event every second so that we can update the display every second. So we have a look at the code. So it's an FMX application, and I won't go into this detail, but this will be available to download so you can study it in conjunction with some of the other presentations which have explained how to use FMX layouts, etc, etc. Let's just change that indentation. So we're creating a clock face, and we're checking on the particular time zone and getting the information we need, and we're using a list view to display time zones, and of course at the heart of this is this event handler for the timer, as explained before. How to create the analog clock example with time zones is explained in chapter 42 of my book How to Program Effectively in Delphi for AS A-Level Computer Science.
There is also a noughts and crosses cross-platform example in the same chapter for you to try. The programs that I've demonstrated today are all available for download, and that information can be obtained by sending an email to drbond@educational-computing.co.uk or going to the learndelphi.org site. Thank you for listening. Hope you've enjoyed the presentation. Bye.
Okay, sorry about the quick delay there. Lots of things happening in the distance. And the studio squirrels are pressing buttons and making me disappear and not disappear. And someone's saying, who's doing the Q&A? The answer is it's Ian Barker. And I'm kind of glad because I should give a little disclaimer here. That was Dr. Kevin Bond who did the video. I appreciate he has a British accent, and so do I. Completely separate people. So that was Dr. Kevin Bond. We've had quite a few questions. I actually, for my day job, so to speak, I do actually write human resources and time and attendance programs, and so I spend a lot of time with date and time. Spend a lot of time with date and time routines. So some of the questions are actually very interesting. Let me just go to a couple of them that I've queued up. And by the way, thanks for everybody who said hi. And the studio squirrel said their internet went crazy. Oh, well, that happens. It's the poor producer. We're running her ragged. I want to say thanks to everybody who said hi. There are people from all over the world. A couple of people saying, where are we based? We actually use a distributed studio system, and this week we've had people from all over the place presenting from South Africa, joining us live, the UK, and despite my accent, I'm actually based in Dallas in Texas. And I can see there are visitors from all over. Those of you that are on the live stream obviously can join in the live chat. There is also a recorded replay of this. So everything you're seeing this week is going to be replayed. We'll probably cut up some chunks as well and play some of these sections again for other things as well. So let me deal with some of the questions. This one from Leo is a slightly strange one. He does sound a little bit like a pirate. Ahoy all! Ahoy to you, Leo. Shouldn't there be, for the first time on the on-timer event, this is in Kevin's example, a timer dot enabled equals false, and then a try and a dot and a timer enabled equals true on finally. That's kind of a little bit advanced from what we've been talking about this week, because a lot of the things we're introducing are kind of beginner's level 101 if you're American, or introductory course, I suppose we'd call it in the UK and other places. But it just depends on the code. Kevin was trying to show examples that were not overloaded with lots of extra stuff. But yes, of course, if you think there's likely to be an error, then you use a structure in Delphi called try and except. What happens is when you enter the try loop and you do the things you need to do, if there's a problem, the finally section will execute, and you won't get that section will always execute. So if you're trying to make a timer happen, then putting in the finally loop means that the timer will turn back on again, and then it will keep ticking away. But if there's a problem in the code and it's not wrapped by a try finally loop, you disable the timer, something horrible happens later down in the code, and then the whole thing crashes and your timer stops working. So yes, slightly bit advanced for what we're talking about here, but yes, that is exactly the right thing to do. So well done, Leo. You pointed that out correctly. What was the other question? This is a slight typo in the question, but processing the time of tick count could be connected to the time slice of the thread scheduler windows. Well, actually, there is an API called get tick count, which is it does literally get the time slice of the thread scheduler. Kevin showed tstopwatch, which is a similar thing. The thing to know about timers and timing is that Windows time and even mobile device time, if you're writing a FireMonkey app or something like that, time is an illusion when it comes to programming, because obviously on a multitasking system, things are happening, and there's preemptive task scheduling and there's reactive event processing and stuff like that. So when you are trying to time something, it's as close as it can get to certain timing. But as Kevin showed in his video, you know, getting down to the resolution of a few microseconds is almost impossible, just because of the way that the code has to be written and Windows works in the background. So yeah, you can't just get away with these things. Let me have a look. But yes, that's a good answer. Right. So tstopwatch is way more accurate. Yes, tstopwatch is very, very accurate. If you use that, it's much more accurate than saying get the time, store it in a variable, and then use it later on. It is, I think, millisecond accurate. Although I didn't actually check that, but I think it's millisecond accurate. It's very, very accurate. People use it when they're trying to see how long something takes. Quite often for debugging, you want to say, why is my program going slow in these sections? And you'll put a thing at the start that says get a tstopwatch value, and later on you'll come and look at that stopwatch value and compare it to the one you stored, and then you can say, oh, it took 15 hundredths of a second or something to execute, and you're expecting it to take 30 seconds. So it's not that particular part of the routine. But yes, it is much more accurate and is very, very useful for that. Again, slightly, I'll answer this question first, which is, can the format settings display the output in different languages like English, French, and Spanish? Okay, the answer to that is that's exactly what it's intended for. I write programs that go out to a very wide audience. Thousands of people use the programs that I write, and they go into different countries. So even though I'm based in the US, I tend to write programs for people in the United Kingdom, in England, and Wales and Scotland. And so the date format, the famous difference in the date format in the United States is that the month comes first and then the day, and the date format for the UK is the day comes first and then the month. But my programs are used in Denmark, for example. Copenhagen Hospital is one of the clients that use that. And Denmark, how can I put this politely about the Danish? Their date format is unusual, and so is their way of showing time, numbers like thousands and millions and decimal places. They use commas where almost the rest of us use full stops. So, you know, if you say $100 $100.65, they'll actually use a comma. And same with the date and time, they have some unusual ways of formatting it. Now, that is taken care of by the operating system, by Windows itself. And what format settings is doing is retrieving the settings for the regional settings of the date and time from Windows when your program starts. It actually retrieves that information. There's a Windows API called behind the scenes. And so if you use a date format like, let me see if I can pull up my computer screen and show you what I mean. Let me just share my screen for a second. If you have What was I going to say? Yes, if you have a date format like this, which is that means here this is the day in a long format, and then this is 2 for the month. Oops. And then the YYY means YYY means 4 digits for the year. Now, if I was on a French system, for example, or if I was on an English system, that DDD would actually return something that looked like this. So it would be Monday, and then it would say, what is it? The 8th of the 8th month, and then 2022. However, if I did the same thing in France, for example, is it lundi? Mardi, I think. Then it would say mar for mardi, which is the French word for Monday, and the rest of it would look the same like that. So the answer there is, can the format settings display the output in different languages? Yes, it actually retrieves that information from the operating system, and it will show you the localized version of the days of the week, the months of the year. So if I did it where I had the month format like that, then in UK or British English, that is going to be something like January, and in French, then it's going to be janvier, like that. So yes, it definitely translates. That's exactly what the format settings is intended for. Now, if I just move my mouse, because it's a little bit confusing. So that's what format settings for. Now, one thing you have to be, oh, what is that? Oh dear. Yeah. Sorry about that. You know, the thing about YouTube is you get spammers come up and do crazy things, and there's not much we can do. We have filters set up, and we've got a time delay, and sometimes these things still appear. So I apologize. Occasionally you're going to see spam, and luckily it's not too unpleasant, but don't click on any links that they put up there. So what was I saying? Yes, format settings. The only thing about format settings is when you get a bit more advanced into coding, you'll start looking at things like multi-threading. And multi-threading is where your program is doing multiple things at the same time. And format settings is not thread safe. So the idea is that you read that value. In theory, you can use format settings to set the date and time format. So if you're on a US computer where the date, the month and the day are around in different ways, it will be able for you to force the program to show in UK format. And in fact, I do that in one of my own programs. You can have a UK and US setting, and it forces the internal representation of the dates and date formatting to be something different. So we asked that, and then there was another question as well, which was to do with ISO 8601 date and time format. That's quite tricky stuff. The best thing I can do is go back to here, and what I'll do is I'll put it in the message so that it shows up on the replay as well. But if you go to here, and there's a whole section that talks about the date and time format, I don't have time to answer that question because we're about to go to the next video. But ISO dates, there's an explanation in there. Personally, for James, who asked that question, I actually did what you did. I store it in a long integer using format date time and do it that way. Okay, so the next video is going to be Introduction to Object-Oriented Programming. OOP Part 1. I think Jim will be taking the live Q&A after that, and I will see you later on in the series. Thank you.
Good day, everyone. Welcome to our session, Introduction to Object-Oriented Programming, as part of the LearnDelphi.org bootcamp. My name is Bertie Buitendag, and I am super excited to be your host and your instructor for this session. I've been a lecturer at the Department of Computer Science at the Tshwane University of Technology in South Africa for the past 22 years. I am very passionate about Delphi since born Delphi version 2, when I was first exposed to the wonderful development environment. So today we are talking about a very important concept that is taught in part or as part of many courses, the concept of object orientation, and it's really the cornerstone on which Embarcadero Delphi is built, the language itself. It's a very important concept to know when you go out into industry or if you want to pursue further studies. We're going to have a look at the step-by-step example where we implement and create our own user-defined class. But before we do that, we're going to cover the core concepts of Delphi. Then we're going to look at another example. And in the same breath, we are focusing on the content made by Dr. Kevin Bond. His book, How to Program Effectively in Delphi for AS level computer science, chapters 18 to 20. So let's just start off. We need to, before we start with any detailed presentation, look at some of the definitions that's provided. Over here is two technical definitions from various textbooks, but what I would like to highlight is that OOP is a programming methodology, all right, which incorporates the different procedural elements that we were used to, but with some enhancements. And then the lady states, OOP, however, requires a different way of thinking when we do the development of our programs. OOP allows programmers to reuse and modify existing objects, that's true, resulting in faster program creation, and that is what makes Delphi so powerful. OOP languages are often event-driven, that's also true where events and actions are linked to how a program responds. And that is also true when we develop simple basic VCL applications. We create and work in an event-driven environment where we write code that respond to what the user does or what the system triggers and so forth. All right, so object orientation. Let's have a look at a particular concept. Object orientation tries to model real-world objects in a software format in terms of its actions and its attributes. One of the nice components that's available for us to use is the calendar picker component. And if you have a look, the calendar picker component simulates and models a calendar, something that we are all used to, and it provides us with certain bits of functionality. We can, for example, move the months over, select a particular date, determine on which day a particular day falls. We can see over here that September 2022, the 4th is on a Sunday, so we can derive certain information and read certain data from it, and it is presented for us in a way that we can relate to. So the calendar is simulated, but we know how the calendar is presented, and it makes sense in the way that we use a calendar every day. In other words, OOP aims to create software that models or simulate real-world objects. OOPs aim to simulate the objects in terms of its attributes. That means we're talking about an object pertaining to its characteristics. All right, so it also tries to model real-world objects when we create normal VCL applications. So it's been stated that many event-driven programming languages support and are based on object orientation. So on the right-hand side, just a simple application where we create a fridge repair bill, and that is a model of a real-world application. So what does this mean? It means that we interface and we interact with the particular application in a way that makes sense. The program interface are composed of various components. We can see that, and the user can interact with it. Like, for example, we can print the customer's file, load a bill, add a customer detail, close the form, etc. So the core principles of object orientation, when you look at many textbooks, is that they present you with that 4 notions or 4 features that a programming language must have in order to be considered a true object-oriented programming language. And those 4 concepts are encapsulation, abstraction, polymorphism, and inheritance. And for this particular session, we're going to focus on the concept of encapsulation and abstraction. So, abstraction and classes, obviously there is a relationship between the concept of abstraction and class. And abstraction, according to Dr. Bond in his book, is the ability to engage with a concept while ignoring some of the details. So with abstraction, only the required details are shown and all unnecessary details are hidden. If you have a look at the smartwatch, for example, or a fitness tracker watch, we've got a user kind of interface, some kind of communication, and that's the device. But hidden away from us is the inner parts of the particular watch that we cannot see. So that all the unnecessary details are hidden and only the required details are shown. So there's a relationship between the concept of an abstraction and abstract. There's 2 basic definitions of the terms that I want to highlight. Abstraction is the process of taking away or removing the characteristics from something in order to reduce it to a set of essential characteristics. The idea of abstract, the word itself in English, it states that it can be difficult to understand, or through a part of any particular instances, it's not concrete. All right, so abstraction in a class has a relationship, and we'll delve into it in a little bit more detail just now. In this example, before we continue, I want you to think about the particular data type for each of the following variable names that I'm going to give. Surname, obviously surname, if you think about the surname, we can assign or use the string data type for it. If I talk about height, we can use integer or real. Page count, integer, page count for a book. A teacher salary, teacher salary can be real or currency. Actually, I mean, in some countries, we can also maybe use the data type byte to store the teacher salary. Now I'm talking and say game rectangle. Now you will ask yourself, what kind of a data type can I use to represent the idea of a game rectangle? And then it becomes difficult. It's not something that is concrete, not something that you can think of directly. So that creates a bit of a confusion, or creates a bit of a conundrum for us. What is the correct data type for a game rectangle? The same goes if I say, let's talk about the product. Now, product with relating to something that you can buy in a store. What data type will we use to talk about the product? That's difficult. So the idea of abstraction also relates to the fact that we are not able to specifically put our finger on a particular data type to describe an object in very simple terms. Let's have a look. If we think about our game rectangle, the game rectangle is an abstraction, but we can define our game rectangle in terms of maybe the height, where we can assign the data type real to it, the width, where we can assign the data type real, use the data type real as well, and the color, which we can set to a particular string. So if we think about the rectangle or a game rectangle in terms of the height, the width, and the color, then it's not as abstract anymore, but it can make sense and we can conceptualize the particular picture. We can describe and define abstract concepts using concrete data types. And that is a very, very important concept that we need to know. So what is an abstract data type? An abstract data type is therefore seen as a user-defined data type being described by several simple data types. So what do we mean by that? If I say think about a brick, it's difficult, but if I say think about a brick in terms of its length, its width, and its height, then it starts to make sense. The same for a date. A date is also a kind of an abstraction, but we can describe it in simple terms by saying a date comprises of a year, a month, and a day. Time, the same thing, and we can describe time in terms of hours, minutes, and seconds. So an abstract data type is used to define objects that cannot be defined by using concrete or simple data types. A class is a template from which actual objects may be created. The class definition lists the characteristics of the object that are to be recorded. All right, the characteristics of the object that are to be recorded. So if we think about the time idea that we talked about, the time abstraction, if we talk about time, we can list it. What is its characteristics? Its characteristics can be in terms of the hours, the minutes, and the seconds. And if we describe it by that, we can then later go on and create an object. So we always get the following definition. Objects is an instance of a class. What does it mean? A class is nothing more than the design plans or the blueprint for something. All right? So if we've got the plan to build a particular house, a builder can go and create many houses based on that particular plan. In itself, the building plan is the class, but it's not the object. The object is something that is made out of the specifications as supplied within the particular class definition. And in real terms, we can also say that the building plans for a house is an abstraction, because it's difficult for us to comprehend it as something concrete. We must describe it in terms of many concrete attributes. For example, the number of rooms of the house, the height of the walls, the specifications of each room. So if we have that and we've got that specified in our building plans, the builder will be able to instantiate the object from our particular class, and he may be able to instantiate several objects from that particular class. So when we work within Delphi, we often use, or either can use the VCL or the FireMonkey frameworks, but the VCL, as you know, is an acronym for the Visual Component Library. It's a set of visual components for the rapid application development of Windows applications, and that we know. VCL contains, and this is from the Embarcadero help file, a wide variety of visual, non-visual, and utility classes for tasks such as Windows application building, web applications, database applications, and so forth. Now, every component that we place on our particular form comes, if it's a VCL applications, come from the VCL library. And if we place, for example, a T-edit on our form, you can place several T-edits, and they are all created from the class called T-edit. Our old Borland convention was to define all class names and include a T in front of it. And that T actually just represents the particular type. If we have a look at the 3 edit boxes that's been placed on our snippet over here, all 3 are different, but they all have something in common. They are all 3 T-edit objects. But I can change each one of them, change their attributes, change how they look, and by changing each one, it doesn't affect the other one that has been created. So let's just recap on abstraction and classes. A class can be used to define an ADT. What is an ADT? An abstract data type. An abstract data type is used to describe something where we cannot typically use a concrete data type. Let's think back about our brick class. To define a brick is difficult, but if we think about a brick in terms of the height, the width, and the length of the brick, then we can start to create a concrete picture in our minds. The same with time, thinking about hours, minutes, and seconds. So an object is a ready-to-use representation of a class. I always use the following analogy. My grandmother used to make some cookies over Christmas, and she had a cookie gun or a cookie press similar to this one. And for the cookie gun and cookie press to work, there's little discs that you insert in the beginning, in the front end, and then you fill the gun with dough, and as you press it down, a cookie is created on the baking plate. So we can regard that particular plate or that small template that we put in front of the cookie gun as the class, and we use that class in order to instantiate cookies. And you will see that depending on the various classes, if you look on the right-hand side, creates different cookies. And the nice type of thing about that is I can instantiate many cookies based on the particular template that I use. And the template is nothing more than the class. So a class in object-oriented programming is also an abstraction of the generalization type. And that is a very important definition that Dr. Bond is giving. So there's a relationship between a class and the object. The class describes how the object is going to function, what it contains, and what its behavior are. But the class is not the object in itself. All right, so abstraction and encapsulation. All right, encapsulation is a very, very important concept, and it relates to the way in which we define and work with our class. Encapsulation is a way of hiding the precise implementation details of a class and binds together the data, that means it's the attributes, and the methods of the particular class. If you think back about our time, abstraction is the hours, the minutes, and the seconds, and we can all define that, for example, using the integer data type. But we can also add some methods to that particular class. For example, we can set the hours, set the minutes, set the seconds. We can read the time that's being stored within the particular class. So the goal of encapsulation is to create objects that can be reused whenever they are appropriate. That's very important. We're doing it frequently when we use the VCL or the FireMonkey approach and we create some kind of visual interface. Every time that we create an application and we place, for example, a T-edit box on our form or on our frame, whatever the case may be, all of those components come from classes, and we can reuse that particular T-edit class many times in many applications. The reuse should occur without you having to be concerned about the special requirements, nor about having to manage the undesirable side effects. So a class or encapsulation defines what an object looks like in terms of its attributes and its behavior. An object is a ready-to-use representation of a class, and frequently we'll get a little diagram thinking about the word encapsulation, analogy to a normal capsule. So the capsule itself contains two parts. There's attributes and fields of the particular thing that we're trying to describe, and the methods and the operations that can be applied to it. So the class in itself contains descriptions pertaining to the fields, as well as to the methods and the operations that's applied. And all of that is encapsulated to create the class for us. So let's just have a look. We're going to start now by creating a step-by-step example for a class that I called TMyTime. And the TMyTime class is going to comprise of only 3 data members or 3 fields or 3 attributes. And those 3 fields are the hours, the time separator, the character that we use between the hours and the minutes, and then finally the minutes. So those are my 3 attributes that I'm going to describe my particular MyTime class object with. And we're going to now go into Delphi and we're going to create this particular TMyTime class and use it in a VCL application. All right, so let's just quickly have a look. We said we are going to create our own TMyTime class, ADT type, abstract data type. Our MyTime class is going to comprise and contain 1, 2, 3 attributes or 3 fields. If you think about our capsule again, the red part contains or refers to our attributes and fields, and the blue parts to the methods or the operations that we can have, and that is all encapsulated within a class. So firstly, we're going to have a field or an attribute with the F in front of it stating that it is our hours, which is of the integer data type, the time separator, which refers to the character between the hours and the minutes, and then finally the F minutes attribute, which is then also an integer. So if we refer back to our capsule, we're going to encapsulate the 3 fields as part of our class, and the name of our class is TMyTime, and the T indicates for us that it is a abstract data type. All right, so what do we have? I've opened Delphi. I've created a new VCL Forms application. This is my form. I've added a button and a list box. And then I've gone and I've saved the form and the unit and a project associated with it. And then I said File, New, and I said Unit. Then it created an empty unit for me like that, and I saved this particular unit with the name CLS My Time Unit. Now, remembering and getting back to our previous our little diagram that we created with the capsule, we are going to define and create our own data type. So we're going to use the keyword type, TMyTime is a class, and I like to inherit from TObject. Now, by default, if you do not inherit from TObject, it's going to do it for you in any case. But I just like to place it there. That just means that this class is built upon the foundations of an existing object, TObject, which is the ancestor class of all Delphi objects and all Delphi classes. All right, now, as you remember and look back at our capsule, we said that we're going to add 3 field attributes. So we're going to define it over here. F hours is of the type integer. F separator is going to be of the type char. And F minutes is also going to be an integer. All right, so now we've got, and we said, let's have a look at the piece of code over here. Interface type, I'm defining my own user-defined type called TMyTime, and that is a class, and I'm using it and building it upon an existing class called TObject. I'm adding 3 attributes or 3 field members. That's why we add the F in front to indicate it's a field, and the T indicates the type. It's 2 old Borland conventions, but it's good to use. And I've defined my 3 attributes as is. So going back to my form, we want to use this particular unit. So I just like to do the following. I like to say add to project. I add my class. All right. Then I copy the name of my unit, and we need to include it as part of our users clause. So this means we're going to use this class within our VCL form application. And as you can see, there's nothing in it. It's just as is. So what are we going to do? We are going to go and we are going to define 2 objects. We're going to say my time 1, my time 2, 2 object variables is of the class T my time. So what are we doing? We're just defining 2 variables. In these 2 variables, the addresses of where 2 time objects are going to be created in memory will be stored. Okay, so we have it like this. So let's say when we start off, when I click on my button, for example, these 2 objects must be created. And now we need to really do a differentiation between instantiation and definition. What have I done here? I've just defined 2 variables. But those 2 variables still need to refer to my time objects. And those objects must first be built in memory before I can use it. And it makes sense. I'm just putting in an order, if we can use that analogy. I'm ordering a my time 1 object and a my time 2 object. But before I can use those 2 particular objects within my application, I need to go and I need to instantiate it. I need to build it in memory. When it's built in memory, it's going to be created at a particular address. And that address is going to be assigned to the variable. So let us go about, let's create and instantiate the my time object. So my time 1 colon equals T, we're using the class name T, mytime.create. You will see when I pressed Control and Spacebar, it shows me various functions and methods that is available for us to invoke already. Why is that? That is because we've built this class of ours on an existing class, TObject, and these methods are provided for us via the TObject platform that we've built our new object on. So if we say constructor create, that will create the object for us in memory. All right, so now we can say my time 1 after it's been created, and now I can say f hours colon equals to, let's say, 10, my time 1 dot separator colon equals to, let's use a colon, and my time 1 dot f minutes equals, let's say, 35. All right, so now we've created it, and what can we do? We can now list that particular time in the list box. List box 1, items, dot add, and we can say something like time 1 equals, and now obviously I'm assigning it, time 1 equals that, plus we're going to concatenate into string my time 1 dot f hours plus my time 1 dot separator plus, and then lastly the minutes. Okay, so let's save, let's run, let's see. I've got 2 errors here. It's complaining, saying incompatible types char and integer, and that's my typical copy, paste, and paraphrase error that we have now. Wonderful. So now if I click, it says time 1 is 10:35. But now I want to do something else. Let's say I want to repeat this whole process. But now do it for time 2 and change that to time 2. So we make this all time 2, time 2, time 2, and all, at every other position we change it to time 2. And let's just make a different time for that. Let's make it 11, and let's make it 11:15. All right, so let's save it again. Let's run it. And now we're going to encounter, it's still running. It's a typical error of myself. Let's just run it again. If I now click the compiler, it gives me an error. And this is a fantastic kind of an error to get, especially, and one that you're going to get quite frequently if you are a novice programmer and it's your first time developing, is that you forget to instantiate that particular object. Remember, we said that when we create and instantiate the object using the create keyword, a particular object is created in memory. That object has a memory address, and what actually happens with the equal to sign is that address of where that object is created in memory is assigned to the object. So if we go back to our code over here, let's just quickly examine. This object is created in memory. That object, because it is created in memory, contains an address. That address is then assigned to my time 1. So now whenever I work with my time 1, it will know where to refer to get the particular values and the attributes. For time 2, unfortunately, the object wasn't created. So now the compiler tells us it doesn't know where to read and write where that address is. So that's a typical error that newbie programmers get. So very important, before we can use an object, we must always instantiate it first. So if we do that and we instantiate the particular object as well, we create my time 1 as well as my time 2. And we run it. Then we know the 2 objects both has been created and we can then display it. All right, so that brings us into the first part. But now you will ask the question, what benefit does it have if I can just access it? What about our picture where we say when we look at our capsule, we want to encapsulate time. We want to certainly hide some of the things away. We don't want the user always to have access to what we are working with over here. And then for that, we need to specify that these field attributes are private. And that is exactly what we're going to do now. So by default, if we look at our class again, I said type my time is a class of the object. I added my attributes over here, but by default, the compiler is going to present this as public attributes. And we want to keep these attributes hidden away from the user of the object. We want to keep that particularly away because we want to encapsulate it and we want to hide that type of details. So what are we going to do? We can provide a private specifier which tells us this is private, and we're going to add public. Now if we save our program and I want to run it again, I get a lot of errors. And the errors that I get, if you have a look at the bottom here, cannot access private symbol T my time hours. So now we're getting to what object orientation is about. We're taking some fields and some attributes, we hide it away from the user, and then we add some methods or functionality and ability for the user to interact with the field and the attributes that is available for us in the class. And that is what we're going to have a look at. So let's just quickly have a look. We're going to create our own user-defined class, as we've done, with 3 attributes: the hours attribute, the time separator, and minutes. And then we stated that our class is our abstract data type, and from that we are going to instantiate an object or various objects that can contain different times. All right. So in order to communicate, and in order to allow us access to the private parts of the particular class, we implement various functions and procedures. So let us say we have the value 2 and we want to assign the value 2 to our F hours attribute. We've seen that in our program that we ran, because we made it private, because it's part of the red part of the capsule, we do not have access to that. So in order to overcome that, we add particular methods that gives us some operational functionality with regard to our class. So we want to take the value 2 to assign to the F hours attribute. Therefore, we are going to implement what is called a mutator method. And the mutator method is going to be used to set the values of the F hours attribute. So the set hours procedure is what we're going to use to set the hours. The HH parameter is passed, and we're obviously going to assign the value that is passed by the user via the HH parameter to the F hours attribute. All right. Now let's say we want to obtain a value. We're going to follow the same kind of logic, but in order to do so, we're going to use a get method. And a get method is often referred to as an accessor method, and that accessor method accesses one of the attributes of my class, and then it returns that particular value for us to use in an application. And in order to do so, we typically implement a function where you can see the function called getHours is our accessor method, and it returns an integer, the 2 that has been stored within the fHours attribute. All right. So in the blue parts that is accessible in our capsule, that's part of our class that the user has access to, we are now going to incorporate a function and a procedure, the procedure taking on the method of a mutator, where we're going to mutate a value to set it, and a getHours accessor method to access the value and in order to return it to the user. That is what we're going to implement. So let's go and let's have a look at our code on how we're going to implement that within our class. So here we are back at our code, and what I've done, I've just commented out those 2 parts that has given us the error because we made it the attributes private. So let's go back to our class definition now, and now we said we're going to add an accessor and a mutator method. So let's add our procedure, and our procedure to set the hours, and I'm going to pass the hours as a parameter, as an integer. All right, and then we're also going to add the header for our if I say complete class at cursor, it will complete it for me over here. But I'm old school, so I'm just going to go copy it over there, and in the implementation part of our unit, write out the name of our function and the procedure, and then just tie that particular method to the name of my class. And in order to do so, we put the name of the class in front, and we use the dot operator. All right, and then obviously we can add our own begin and end. And end. All right, so what's set hours going to do? Set hours, we're taking a value from the outside that we're going to assign to my field attribute. So we're going to say f hours colon equals to HH. So the value that I am passing, I am assigning to my f hours attribute. The same here for get hours. So we're going to say result colon equals f hours. Result colon equals f hours. Now obviously you will agree with me that we're going to follow this exact same principle in doing the other method. So let's write a mutator and an accessor for the two other fields that we've incorporated within our class as well. That will mean an f separator and an f minutes accessor and mutator, a get and a set. So I'm also going to add these to the end. Add the name of my class in front, and then write the implementation code for each of these methods. So these are the methods and the operations that can then be applied to our particular class and to our particular object. That is what the developer will have access to interact with when he or she goes and use our class within their application. So let's just get it completely correct. I'm passing the minutes there, and I want to assign that to the f minutes field or the f minutes attribute. And the same is that I want to return that particular value. I'm passing the separator as a character. So f separator, and I'm going to assign that s attribute. And over here, the result that I'm going to do is that I am going to send that back. So now what do we have? We've got the set hours mutator. That means to change what? Change one of the private fields. And we've got the get hours accessor. The get hours accessor that we can invoke to retrieve a value. So now we've got all of these methods that is available for us. They are as part of the public part. And if you go back to our capsule, it means it's the blue part, the part that the user has access to, or the developer has access to, that we can now call and invoke. So if we go to our program, back to our little application over here, we can now go and apply the various methods and call the various methods. So now I can say my time 1 dot set hours, and I can set the hours with a practical value of 10. I can also set the separator, and you will see all of these is the methods or not if I do it like that, all of these functions are provided as the operations that's now available for me to use within my class. So we've got a set separator, and let's say the separator that I want to pass is a colon. And then finally, let's do the minutes. And let's say the minutes that I want to pass is 35. All right, so let's not use the time2 object over there. I don't have the comment anymore. I can remove that. My time1.set minutes, I need my semicolon over there. So now listbox1.items.add. Now I can, to retrieve the values that's part of my object, I am going to invoke and call. The word invoke means to call. I'm going to call that particular get hours method that will return it for us. We're also going to call the get separator. And then finally, we're going to call the get minutes. Okay, so if we save this, if we run our application, hopefully without any errors. Now if I click on button 1, my time is set using mutator methods to set the value, set hours 10, the separator, set minutes to 35. And I'm calling my accessor methods here, get hours, get separator, and get minutes to return the values of my fields for me to use. Now you will basically ask, what does it help us if we have a class or an ADT type where we add some fields and we don't really do something? A class needs to be able to provide or some functionality for the user to make it worthwhile. So we've learned about an accessor method. The accessor method gives us access and returns the value of a private attribute, and a mutator method which we use to supply an outside value for assignment to one of our private attributes as well, to mutate it or to change it. But then we get a fourth type of method, because we actually did cover and look at one already, and that particular method is called a constructor. Remember, the constructor of a class is the method that is called when that object is to be made in memory. Let's say by default, I want my constructor to go, and I want my constructor to set the time to quarter past 12. Every default time starts at that. So let's write the code to get that implemented. Create is the default name that we use to define a constructor, but we can also give it another name. In Dr. Kevin's book, he calls it build object or make object, which is quite suitable and quite fine, but constructor create. And this constructor doesn't get any parameters. So when we have it over here, we say constructor create. Remember, we're tying the method to the class name by using the dot operator. And then we just say begin and end. F hours equals 12, F separator equals the colon, and F minutes equals 15. So now if we go back to our class again when we create it, but now I'm going to go, and in my list box, I'm going to add the data of the second object as well. So we're going to say time2. So if we save this and if we run our application, you will see time 1 is set as 10:35 and time 2 has been set as 12:15. That's because the moment the constructor was invoked, the values were set to, for both of them, for both of these objects that was created, the value was set to 12:15, but then I changed one of them, and then it affected it. And that's a very important concept to realize. So let's have it like that. That's the way it's been created. And let's add another line to our list box, just an empty one. So now, initially both objects, the constructor was created, and for both objects, the time was set to 12:15. Then I changed one of the objects. I changed some data for that particular object. I set the hours to 10 and the separator and the minutes. And what I want you to note is that both objects was created, but changing one did not affect the other. And that is what we say. From a class definition or from an ADT type, we can go and we can instantiate many objects. So we talked about the constructor, we talked about an accessor, we talked about a mutator. So the final type of method that we normally add to a class is called a auxiliary method. Now, if we think about the word auxiliary, it's a method that's going to provide us with some kind of nice functionality. And we're going to do and incorporate exactly such a method as well. So let's go back to our class. And let's say we want to incorporate an auxiliary method, and we call that auxiliary method toString. It must return a nice string for us. Function toString. And it must return a string. Okay? And that must basically, it's an auxiliary method. So the auxiliary method is going to return the time for us in that particular format. The hours with the separator and then the minutes. It's not used to set a value, it's not used to get a value. So let's add the implementation code. And again, we're going to copy the name of our function over there. We can paste it in here. We add the name of the class of the dot operator. We put begin and end. And now just we do the following. We're going to add some logic in order to return a nice string. So that if there's a, if the value is less than 10, for example, for the minutes, then it must return a 0 in it as well. So we can, and just like we could do with any function, we can declare a temporary variable. Colon equals into string. And now you will recognize that the compiler tells me that it doesn't recognize what into string is. That is because we are completely in a different unit. And now we must tell the compiler to also include that. So in order to use into string, we must know first in what unit it is contained. So if I press Control F1 brings up the topic, I stood with my cursor within the particular place where I wanted to obtain help. So if I click on OK, it tells us that that into string is part of system.sysutil. You can say users, with the users clause to also incorporate sysutils. So the moment we do that, into string is no longer foreign, or it knows about the function and where to find it. So we said stemp equals into string f hours plus. Now we need to incorporate a little bit of an if statement. If minutes, if it's less than 10, then we're going to say stemp equals 0. We need to obviously concatenate it, take the previous value, else we do exactly the same, but we are not concatenating the 0. And then we can return stemp. So let's just save that. And let's go back to our program. So now what we can do is we can call, instead of doing all of this logical coding over here, we can now go and call our auxiliary method. So we can say myTime object 2.get toString, and it will call it fast. Obviously, it may be concatenated because it returns a string. So let us do with the minutes. Let's make the hours 10, but let's make the minutes, in our example, let's make it 7 and see if it's going to concatenate and add that particular 0 in front when we run it. So let us just save it. I always like to save. Let's run. So if I click over here, then you can see my little was not added. So let us just see where my mistake is. The mistake that I made was quite a boo-boo. I am calling myTime2.toString, but I'm setting myTime1 the minutes to 7. So that's not correct. So let's do that. Let's keep that one original. Let's keep it. Let's say it was 35 if I can remember. And now let's take that before I add it. Let's change myTimes to minutes only. So we can invoke a particular method at any time. myTime2.setMinutes, and let's call it and make it 7. And now let's save our application and run it. And now you will see the time for the minutes was set to 7, and then a 0 was appended. So the toString method is called an auxiliary method, and that auxiliary method provides us for one or other kind of nice functionality that we can incorporate within our class. All right, so what have we covered? We've covered that we can create a constructor. The constructor can be used to set some default values to my object. Then I also have a accessor method. An accessor method is typically a get method. That get types of method returns the value of one of my private field attributes. Then we also have what's called a mutator. The mutators are typically set methods. And then finally we get some methods that provide us with some functionality, and that types of nifty functionality that we add to our class is called an auxiliary method. All right, so the next concept I want to cover is the idea of creating an overloaded constructor, or what we call a parameterized constructor. So let's say we want to also create a constructor, create, but whereas the first one sets default values to 12, 15 with a colon, in this one we want to add and supply some specific values via parameters. So we can say HH integer that we pass, S or separator as a char, and the minutes again as an integer. And then over there, just a semicolon like that. All right, now we need to specify that there's two versions of the same thing with the same name. So we use the overload keyword over there. All right, so let's copy that particular constructor. Let's add it over here. And let's write the implementation code for that particular one as well, just like that. And let's add our begin and end. And let us set the values. And we will set the values typically to the values that's been passed as parameters. HH, sep for separator, and the minutes for the minutes. All right, so let us save it. Let's go back to our implementation. So now for my time, let's remove my time 1, the set hours over there. And now if we go back to my time 1, you will see that our overloaded constructor is available there. It tells us we've got 3 parameters, hours, a separator of the type character, and minutes. So now if I go and I say, all right, let us say create. I am passing, let's say 10 o'clock in the morning, and with a colon, as a separator. Let's make it something different. Let's put the piping sign, and let's say the minutes is to be set at, let's make it 10:05. So now we're going to replace that particular one over there. Say my time 1 is time 1.toString. We're calling our auxiliary method. If we run it, then I get an error. The error over here is that I forgot my semicolon. Save it again, always save. If you run it, if you press the button, then you will see the separator has been set to the piping sign over there, 10:05, but we call the set method toString. That's going to check whether there is a 0 and then present it to us like that. So we've got our two objects that has been created, and one, the default values is set using the default constructor, and the other one, the values are set using a parameterized constructor. And the parameterized one, as the word says, gets values, and we pass the default values via parameters. Just very important, the name of the constructor can be any name, but if we present two different versions of the same function with the same name, then we use the overload keyword. So viewers, you may have noticed that we ran out of time. But before I end off the session, I quickly just want to do a quick recap of what we have covered. We looked at the core principles pertaining to object-oriented programming. The concepts that we have covered pertains to abstraction, encapsulation, using a class or understanding the concept of a class as an abstract data type, and creating and implementing a user-defined class in a Delphi application. Together with that, we looked at the different types of methods that we get in object orientation and when we define our own class, which includes the constructor, accessors, mutators, and auxiliary methods. Before we finally wrap up, I would like to show you some wonderful resources that you can also peruse for further studies and for further investigation. Firstly, I've promised that we will do an additional example as part of the session, but this I've covered within a set of accompanying notes that will be provided as part of the GitHub repository for the bootcamp. In addition, we used some of the content of Dr. Bond, of his book that we have already introduced in the beginning of the session. If it's at all possible, I would like to encourage you to get a copy of his book. Furthermore, there are some wonderful Delphi resources available, especially for newbie programmers on YouTube. I list some of the nice channels that I came across that's also been made by teachers and other experts in their field. Two other websites that you will potentially know about is learndelphi.org and learndelphi.tv, made by Alistair Christie. He's a fantastic presenter and covers some of the core concepts of Delphi. For questions and additional answers, we are having a Discord session, and I presented my username over there for questions pertaining to this session and this video. So all that's left to say is thank you for your participation, thank you for sitting through the hour with me, and I wish you all the best in your programming endeavors and your journey in becoming a true Delphi developer. Thank you for
All right. Hello. Thank you, Bertie, for that session. You're just talking about Dr. Kevin Bond, and I got my brain confused. So, Bertie, if you want to join me now, we'll do some Q&A here on fundamentals of object-oriented programming.
Hello.
Hello. So this is great. Jamie just said after, oh wait, I clicked the wrong one. Richard said, after 20 years, I finally understand the power of object-oriented programming. That is great.
I'm happy.
So there's a question here from Mustafa asking, what is the difference between an interface and an abstraction?
I saw the question being posted while watching the video. The interface part of a unit in Delphi is what actually provides us with the opportunity to present an abstraction. So our class is a type actually that we define. It's a data type, and our data type in itself, as I explained, is an abstraction. And we separate that into two parts, the interface and the implementation. With the interface, if you think about it, we added various methods to my class, but the implementation tells us how is that particular method going to operate? What kind of business logic or what kind of procedural logic are we going to include to have that run? So within a unit, the interface part also separates our unit to say that it presents the abstract on the top, what is visible, what can be displayed, and then within the interface, we define what's going to happen. And the class itself is an abstract data type. So it is an abstraction of something. Like my class, time was an abstraction of a time. The way that you can think about it in different words. I always tell my students, when you think about an abstract data type, it's something that you cannot describe concretely. I use the example of a salary. If I tell you, think of a data type for salary, easy. You can say real currency or byte if you are a teacher. But if you think about something like time, it becomes more abstract. So you need to think about concrete data types to define what the particular data thing is going to represent within your class. I hope I answered this question.
I think so. So one thing about it also is that those keywords are overloaded as well. Is that there are interface. There's the interface section of the unit, and there's also interfaces, and then there's your abstract you define, but then there's also abstract classes. So yeah, it is. But yeah, that I think that explained it well. So Jamie asked an interesting question here. He goes, is there a rule of thumb for choosing a struct, which is called a record in Delphi, over a class?
I think it all pertains to the purpose. I mean, with a class, you can add methods. Now, that's the big difference, that you can add certain functionality to encompass and be created and included within your class. That is not the same with a record type that we used to have in Delphi. A record type just presents a particular record with some attributes and fields, and that cannot be made hidden from a user. So there's a big difference from a struct or a record type than that of a class, where with a class, we can typically add methods. And that gives us also the opportunity to inherit. It also gives opportunity to do some aggregation where we include other class variables as part of a new class. So with object orientation that relates to a class that we use, there's much more functionality that is embedded and that is provided for than a normal struct type won't do.
And actually, the newer records in the later versions of Delphi do have procedures and functions, but the inheritance is the big difference. Generally, I see that the biggest differentiator is records are good for small data types, whereas if you have a lot of data, you definitely use a class, or inheritance, interfaces, things like that. So classes are much more robust. There's a question here. If I already know OOP paradigm from Java, it will be easier for me to translate my programming knowledge to Delphi.
Yeah, that's a obvious answer. Yes. The nice thing about what I like about Delphi, and specifically the Object Pascal language, is the fact that the interface and the implementation are separated. So when you define your class, you've got your class data type where you just have your method headers, and the implementation is done at the bottom. If you've created Java class, it's all nested. Your main class with all your methods are placed in between, and that in itself is nothing wrong with, but it's just from a design perspective, it's easy to read the way that we do it in Delphi and in Object Pascal.
All right, well, we are out of time, but we do have another session on OOP coming up here. The next one is OOP Part 2, Arrays of Objects and Inheritance. Fantastic. It's good that they have this. I mean, as was commented, people are now finally understanding OOP, even though they've been programming for a while. It's always a great place to start as we continue to build on that with our next session. Thank you so much, Birdie, for putting this together and for being part of the boot camp.
Thanks.
Really appreciate it. Yep. All right, we'll see everybody in the next Q&A session.
Good day, Jarklo speaking here. Welcome to this Delphi bootcamp that we'll be working on. Let me quickly tell you, this session is session 15. We will be continuing with the object orientation part of this. And this focus will be basically inheritance, firstly array of objects and then inheritance. So let me quickly tell you who I am. I am a educator at heart. Been teaching for the past 8-9 years. Previous 2 year and a half, I've been the senior subject advisor for IT in the Western Cape, South Africa. So that in that job, I go around to different schools and I support the teachers and make sure all the work gets done and support learners where needed. I'm passionate about helping teachers and learners, working through problem solving, learning new techniques, how to do that. I live in Paarl, South Africa, and my hobbies will be camping and to braai. And if you don't know what a braai is, please go take a look on Google or search about that. That's the way we in South Africa love to do things. So, outline of this session, as said previously, we will be working with array of objects and then inheritance. And you can reference the textbook, How to Program Efficiently in Delphi, chapters 22, 23, 24. I will be between those chapters in this session and also the next one. So let's go take a look at the coding part. So now I'm heading over to my IDE. For this I will be using Delphi 11. So let's quickly take a look. Sorry, I forgot to tell you the resources. If there's anything you need, it will be uploaded for you and you'll find it under extra presentations, and then there's 2 sample applications that we will be working on. So I'm going to start with the first one, the array of objects one. Can go there at the moment, then I'm going to use Delphi, open my projects, navigate to where I want to get I'm in the right directory over here, and then I'm going to open my project that I'll be working on. As while Delphi is loading, all programs are addicted to some sort of caffeine. My one is coffee. So excuse me every now and again if I take a sip of my coffee. So let me quickly give you a rundown of this program. I've included a class diagram. So the idea of this will be our object. We will have the private attributes for a character that we'll be creating. We'll have a name, we'll have a type of character, we'll have the health, and these are all private attributes. And if we talk quickly about encapsulation entails where you hide certain properties of a object from the main class, all the main units that can access that. I'll talk about that a bit later when we get to the coding part of that. Then we will have the following methods that we will create for that. We'll have a create one, we'll have a set name, a set type, a set health. We'll have our, that's all our mutators. Our accessors will be the get name, get type, get health, and a toString method, which is an auxiliary method, specific auxiliary one. The create one is our constructor, and those are basically all different types of methods. You can have any list of other methods that you like to do there. So taking a look at this program specifically, I already did the interface. So we have a create characters where we will get the name and the type of character and the health. And then we've got our create button. The modify will use that if you want to change any properties of that. And the idea of this will be once you created a character, it will populate into this radio group on the right hand side, and you can go to the modify, click your character name, and then you can work through each one of these, modify when needed. I already prepped my class as well. On the right hand side we will see our class, and we can work through this. I'm just quickly going to add the code to this. If I pull up my class diagram, I can see I have a name, type, and health, which will be my private attributes, string, integer. So going to my class that was being prepped for me, I will do my f name of my character. Data type will be a string, was f type of character, also a string, and then f health, which is an integer. So the idea of encapsulation when working with private, these private properties, class attributes, are only accessible inside the scope of this specific class. You can even go further to do a strict private, where you can force them not to be seen by any other classes, because what Delphi does, it creates invisible links between the different units that they might communicate with one another. So if you do a strictly private, it will only be accessible inside this one. If talking about the abstraction of a object is the first part you go through. If you get anything you'd like to emulate as an object, you'll first try to make it as abstract as possible, so you can reuse that specific object for as many cases as you'd like to. So this character object that we will be creating here, the idea is that we can create any type of character using these properties, and then in the next class in the next project we'll work with inheritance, where you can actually inherit specific items from the one class and use it there. So these are our specific attributes of our character that we'll be emulating as the object here. So those are the first ones, and now the next thing I'd like to do is I go to my public. The idea of the public is I can access that in my different classes, and it will be, for example, this unit. I do an import here. I go to my code side under uses. You will see there's a lot of items added there. I just want to see where it is added. I already did prep this before the time. System util implementation. This is that demo daemon that always creeps in. Just want to see. If we don't find it, we just add that here, form unit character. No, that's this forms one. Oh, over there. I just missed it every time. This class, we use that class character for the import of this whole class to gain access to all the properties we have in there. And then we can see all the public methods that we'll be creating here. So the first one will be our constructor, create character, and we will have a s name, s type, data type string, and then we'll have our I health, data type integer, and shortcut Control Shift C. It creates the method header for me inside here, and inside here what I'm doing, I'm assigning my class attributes, my f name. I can just type correctly. F name, assigning that to this parameter I pass to that, which will be s name. The second one will be f type, assigning that to the parameter s type, and make sure you do this the correct way around, otherwise you won't be populating your private attributes, your class attributes, but you'll be overwriting the parameters you received here with null values or null values. And then my last one, iHealth, I will set that to I just spoke about this, now I try to do that to iHealth. So that's the way we do our constructor. And then we do our gets and sets. Get name, we will be accessing it, so we'll be having a return, and if we have a return, we'll use a function get name return string with the result. I'm going to do all of them. Function get type data type, say string as well, and the next function will be get health, and the result of that will be an integer. Okay, so there we created all this, and if you have a problem remembering which one is a procedure and which one is a function, if I can quickly show you, if you can go to any button click, specifically let's say this create button, you will see that is a procedure, and the reason it's a procedure is that it does a specific piece of code. It doesn't have a result value to it. It just executes the code that's listed underneath there. Easy way to remember the difference between a procedure and a function. That's something you can study as well. And if I have a function, it's expecting a result to populate it into that specific data type I set the method to. Control-Shift-C creates all my headers over here for me, and then I can simply say result, set that to, this is my get health, it will be my f health, which is an integer data type. Next one will be my get name, so I'll set my result to my f name, and the last one is my result of the type will be f type, which is also a string that returns the results for me. Now my procedures, do my sets, set name, I will receive a parameter, a s new name, data type string, procedure, next one is set type, and will be s new type, data type string, and the last procedure, always use control space for autocomplete, but this one tries to give me all my everything there, to my set health, and it will be an I new health, and the data type will be integer. Control-Shift-C creates those procedures for me, and for this one I'm actually assigning this is the health, my f health, setting that to my parameter I'm receiving over here, and will be I new health. Same with my my name, my f name, setting that to this is new name. The last one will be my f type, and I'll be setting that to my s new type. And then the last piece of code I'd like to add here will also be a function, and this is going back to my class diagram. I did my create, my constructor, I did my set methods, I did my get methods, and the last one that's left is my toString method. ToString, idea of a toString is to return a string value that contains all the Control-Shift-C, that contains all the properties of the specific character that I'm creating. I'm just going to do easy one. The result, set that to, let's make it name plus F control space F name plus adding a hash 13 for a new line, and then I'm going to add a second one is the type. My type will be F type, adding a hash 13 again for a new line, return line, and then I'm going to do the last one, health, and as my toString will only return a string as indicated, I need to cast my health into string, and it's F health. And if you have problems with accessing some of these normal methods or built-in methods that we use in Delphi all the time, just remember in this class to add the uses, the sysutils uses, and that will give you access to all the normal system utilities that you use in Delphi. I think that's it for this character class at this moment. Those of you new to Delphi, you see this yellow line over here. That means all your progress has not been saved yet. Control S, shorthand for save. Then you'll see that turns into green, knowing that wherever you worked, it changed that. Let's go to our GUI class, our accessor class. So in here, we are actually going to create the object. So you probably just learned how to create the object. So the one way you can do it, it can be a object character data type string. But let's say we are working in a program now where we want to create about 400 different characters at once. This is where the power of object orientation actually comes into play, because you can use the one class, this class, your object class, to create a vast array amount of objects with the same properties. Just think about a character property. This one is a very simple one with the three attributes name, type, and health. So from that is the starting point, the abstraction of whatever we would like to emulate. We can use that and you can build on that, and you can actually extend on the specific character to access more characters and build more on that. So in this program, I've got two different, quickly run this so you can see. I've got two different characters that at this moment, you can expand it as you'd like to, that I decided on. And the one will be, is the type will be in the drop down, either mage or knight. So those are the two characters that I decided on for this program. But you can add, I don't know, paladin, or if you go, I don't know, anything. You can even add a night walker or whatever inside this. You can then extend that with inheritance to a different class, and giving it the specific properties that you need to use for that. So that then it becomes really unpractical to create all the different characters as an object, each one of them, because then your code will be bulky and you will have a lot of different lines of items you need to do. Luckily, we have learned, I hope you've learned how to create an array. And to do an array, we say a object characters of data type array. And let's just for this example go from 1 to 5, and it will be of, and now here's where the nice part of this is, of the data type, and this characters is the type is a character object. So now my array that I'd like to create will be an array of the type T, and using control space I can, where's my, of my type class T character, and this is a user defined class that we created. So there we can actually create that. Now let's try to create a specific character using that. We've got 5 lines in my array, or 5 items. You can increase that as you would like to. Then we can say my object, control space, character. I will set that to my class. The way we create is a object T character, why is this, let me consult my notes. I don't know why this daemon does this to me in this moment. Just supposed to be array of my T character, and now it should be of the data type T character dot, I don't know why I didn't pick up that, dot my constructor, the create character, and then it expects my 3 parameters, and now I can access that from my GUI components. This one's name is edit name, that one is combo box type, and spin edit health. So let's quickly populate this character. First it's expecting the name, and you'll know this order, it appears here, is the same order that you created your constructor in your class. So I'm going to access my name, edit name dot text. The next one is looking for the type. It's combo box type dot text, and the last one is my spin edit health.value. Oh, I know what my problem was. This character is an array, so I actually need to reference to my specific index of the array I'm working with. And if I want to create my first character, it's in the first value of my array, item 1, and it creates the character with the properties I have there. And then let's, just to make sure that my character actually was created, I can do the following. I'm just going to, the start of this procedure, I'm going to clear my rich edit, clear that, and then after that I'm going to use my rich edit output.lines.add, and then I'm going to add from the object character 1, reference the first one dot to string. Now I'm going to access my toString method by doing that. So let's quickly run this and see how that looks and how that works. So I'm going to type in my character's name. It will be, let's make it Alan. Of a type, let's make it a knight. And I'm going to make the health 10. So then character, there it adds my name Alan, knight 10. And these properties, you can see I use the toString that accesses my class over there to populate my rich edit over here. Now the next thing I want to do, I actually want to let's just generalize the code a bit more so that we don't need to access this for everyone every time. I'm going to create a variable, a global variable. Let's make it iCounter of data type integer and set it to 1, and then I can replace where I used my 1 over here. I can replace that with a counter, and after I use that I can use the inc function that increments it for me. Increments is a fancy word for adding 1 to the value every time you use it. So if the value was 1, the next time it will be 2, the next time it will be 3, 4, 5, all the way like that. So then we can do that. That's the 5 items, working through that. And now I need to add this to my, let's add the name of this to my radio group on the right hand side. If you can recall, on the right hand side I've got my characters, and I'd like to populate that with the names of my characters. So let's do this. I can do my radio group characters dot items dot add, and what I want to add there, I want to add my object dot get name. Now I'm accessing this method from my class to display the name there. And let's just test this and see if this works correctly. Okay, Alan. Type will be made, just make a half 100 and create. And there I've got my Alan populated there for me, and there's my toString. I can do you can add code to actually clear all of this for you. It's good, gonna make this one Peter. You can make Peter a knight, and let's make his house 150. Create my character, and then there's the 2 of them. You can also add some code validation to make sure that you don't go over 5, because our array is only have 5 items in it. I'm not going to go into that detail now, but that's something you can do. Now let's quickly take a look at the next part of this program, where we can modify this part. If we click on the character over here, we want to populate these edits. This is edit ename, edit etype, edit ehealth, and then there's all the modified, this new name, the new type, and the new health. So if I'm going to press on the character's name, I'm going to populate those 3 first, add my action event to my character radio group, and then I'm going to say the first one is edt ename.text. I'd like to set that to my object character. We'll get to index in a moment. I'm going to say get name. So the way I can populate this index, I can take a look at my combo box. My combo box, we know, works with item indexes. So combo box, it will be, so not combo box, radio group characters dot item index. the one that was selected, and the item index in the radio group actually starts at 0, 1, 2, 3, 4, and our array starts at 1, 2, 3, 4, 5. So there's two ways we can work with this problem. We can either change the scope of our array starting from 0 to 4, or we can change the item index here just by adding 1 to it. So if it was 1, if it was 0, the item index was selected, we'll go to 1, selecting the first index in our array. Remember, this is an array of objects, giving us access to all the properties of them there. Next one will be my edit type dot text. I'm going to set that. I'm going to use the same line of code over here. I don't know why that jumped around like that. Use the same line of code. I'm going to copy that, paste that, and now I want to dot get the type, and my edit health dot text. I want to set that to the same item, and I want to get health, but that's integer, and this is an edit, so I need to change this int to string, otherwise you're going to get a incompatible data types error. Let me quickly run this and see if this part helps. Now I first need to populate my array with a few items. So my name, Alan, no, I'm working at the wrong place here. My name is Alan. My type is a mage. Your health will be 50. Create character. There we've got Alan. Then we've got Peter. That will be a knight. 150. And Maggie will be another knight. And 125. Create the fourth one. Kim will be our mage, and we'll have 50 there, and the last one we can make an Mikey, also a mage. Let's make this health 250 and create the character. Then we can go into the modify tab over here. If I click on Alan, you can see it populates all my items down there. Peter, Maggie, Kim, and Mickey. So that's the first step. Now we want to modify as our next step that we'll get to. Quickly go to that side. And I want to go to class. Now I click there. Let's go to this. And then on the modify button, if I double click on that, I will need to set my, that's the modify the new name. Then I'll need to set my object. And this is the same one that was selected now. So I think I still have that in memory, so I can paste that. Dot set name to my edit. I think that's edit new name. That's as easy as the procedure works. And then my next one, I'm going to dot. No, this is actually not supposed to be in this one. What we can do here after we set the name, we can say red output dot clear, and then we can say red output dot lines dot add, and what we want to add is in the object characters. And that's the whole long line from a radio group again. Then write one over there dot to string. And that will set the new one. What is the problem over here? Oh, I need the dot text there, and that works. And also good practice will be to set your the edit new name text of that. We can set that to the object of the character dot get name. So what we did now, we replaced the name of the object, we set that, we cleared our rich edit, we accessed our toString, printed that, and set the new name there. And we can actually want to be really diligent. And this should only be just be name. We should set our edit new name dot, we can clear that. Quickly test this one. Alan is a mage, 100 health. There's our Alan. I'm not going to add all 5 of them now. Now if I click on Alan, we populate the first one, modify the name. We can make it Alan the mage. And we can modify the name, and you can see that one didn't. Let's see what's the problem there now. I think, yeah, we changed it over there. Instead of changed it that one. You can see that one changed. We can also add code to change that one as well. Let's just change the, it should be e text over there. Character get name. I'm not going to change the radio group at that moment, but you can do that as well. We have the item index. You can just set that to the correct one. Alan is a mage, 100, create character, modify, click on Alan and make it Alan the mage, modify, changes there, does the toString for me and clears that one. So that's the idea of this. We can do the same now for the other 2 buttons. I'm not going to go through the whole process again. I'm going to do a simple way. I'm going to copy and paste this, and then I'm going to hope I find all the correct properties to change. Then I want to set the name, I want to set the type, and the edit new type, probably a radio group, not radio group, combo box, yes, combo box. I can going to display that, and the edit e type, set that to get type, and then I'm going to clear my edit new. No, this is the combo box. It's that one. Clear that, and then we can quickly do the same for the last health. Want to change the health, and then I'm going to set my health to my spin edit new health dot value integer, clear, do the toString. I'm going to set my, that one correct, that the edits, quickly want to check, Yes, it's edit health. EDT. Health.text. Set that, and this is a int to string, and get health, and then my spin edit new health, going to set that to 0. Okay, so let's quickly test that. Dot value probably. Okay, let's quickly test this. Hopefully I copied and pasted correctly everywhere. That tends to be a problem if you do that, go that route. Alan, no, wrong place. Alan type is a knight 100, create character. Let's make this Mike a mage, also 100. And if we modify, if I click on Alan, let's make Alan a mage, and then Alan changed to a mage over here. We can change Alan. Oh, I cleared that. That wasn't a good idea. Change him to a knight, and then that works over there. And we can modify the health, change that to 1, and it changed Alan's health there. The same with this one, we can change the health to 0, and there we go. So this was an array, or class of an array of objects, populating all of that. So that was the first one I wanted to show you. The second one I want to show you, if I quickly close this one, is actually the concept of inheritance. And if I go to File, if I go Open Project, I can go to my inheritance, and I actually created this project will also be supplied to you. If I can quickly just talk about the idea of inheritance. If you think about how you look, and you think about how your mom and your dad looks, then there's certain traits that you can directly see from your mom and dad into you. If your mom had blonde hair and your dad had blonde hair, you most likely also will have blonde hair. The same thing about length. If your mom was long and your dad was long, was tall, you will most likely also be tall. So that's some of the characteristics that you inherit from your parents. So that's the whole idea of inheritance. You'll have a main class, and then you'll have subclasses underneath it. And from the main class, the subclass can inherit certain traits, certain properties, certain items. And then later on in the next session, we'll most likely talk about how you can overwrite those traits that you had there. But for this one, I want to show you the idea of inheritance. So this is just an extension of that previous program that we worked on, where we have create character, then we've got a mage button, and then there's place for the knight one as well there. So the idea of inheritance, if I can quickly show you here, if you just think about the GUI components in this screen, you can see they are all in this font Consolas. But now if I click on my form, I select my form there, and I scroll down. Let's go to font. Go up to font, not down to font. If I go to font, and I open that, and I see here's the font name, and let's make that something different. Let's make it all something that, let's make it chiller. You can see all the fonts on this form inherited, all the components on this form inherited the font property from the parent. The form is the parent. You can see over here, here's the structure. The form is the parent, and all the properties on it inherited those traits, which was the font in this case. So I'm going to make this one back to consolas, just to make it more readable. And let's just take a look at different components. And this is my page control component. Let's try to do the same with this one, but let's do a different property. Let's make everything bold on that. So this, all the items on this, all the the pages, the tabs over here, inherited the same traits, the bold, from that specific one. I can take that one off again. Let's go to the specific page that I have there. If I make that one bold, it's only this page that inherited those properties from the parent controller going down. That's the idea of inheritance. Now, the way we can do our own inheritance is where we work, and on here we have our parent character class, and this is the same one. I think the order might just be a bit different than what we just created, but we still have our private, our encapsulated properties over here, your name, your type, your health. They are all the private ones, and we've got our create constructor, the name, type, health. Then we've got our procedures over here, and then underneath the procedures we've got our functions, our get functions, our accessor functions, and then our toString method. Over here I just had a line that was different from the previous one, but still the same. If I do quickly take a look at my create. So in this create, okay, let me quickly go to the top and take it from there. So what is different in this program? I actually added different uses. I've got my class, my character class. That's the one we worked in previously. Then I created a class for the mage, and I created a class for my knight. My character is my parent controller, or not my parent controller, my parent class, with all the specific traits that you will find for a character. And then inside my mage class, I've got new attributes for that specific mage. So a mage has a magic type, and a mage has a level. But then this mage inherited the traits of the character. So under the uses, I need to incorporate my character class there. And then when I create a mage object, and this is my mage, which is inheriting the character class, not an object. Let's take a look at my character class. The character is a default object. That's a default one that they provide for us. But this character is now, the T mage type is now of the character class, which it inherited. So how we can use that when I create a mage object over here, and this again is a array of objects. So this object mage of the T mage class, that's where I created that. This character was legacy, don't need that anymore on this one. So the way I can use this, I added this code. We can do this for the knight one. So I create a mage, and instead of my I count, I've got just a mage counter, my mage counters, and I create a T mage from T mage class. This is my T mage, the type that I'm creating, and then I'm dot create character. So now you will not find this constructor inside your mage class. There's no, you can see there's no create character inside here. That was inherited from this character class, the character class that's just a T object. There's my create one, and now it inherited those all these public methods is inherited by your mage. And I send it the name, the type, the health, and then I added that to my radio group. I now have two radio groups, one for my majors, one for my nights. And I added the counter there. So let's quickly do this practical for the nights. My night is an object, also of the TNight class. And my night class, if I open that, in my night class, I actually have also the night that inherited the character class. And from here, I've got two private attributes, armor, which is string, and shield, which is a boolean. Does it have a shield, yes or no? And I actually created it, the set methods for this already. We have the set armor and the set shield. So let's create a character. So if night is selected, this happens in the night one. I need a counter for my night. Let's start there. Night counter, data type integer, and I set that equal to 1. Now let's do inside here, if it's not a mage and if it's a night, then I'm going to say my object control space of my night, and then I'm accessing my night counter, which is 1 at the moment, and I'm setting that to a TNight, the TNight class. If the TNight class, that is a subclass of the character class. And I'm saying the dot create character, and then I'm emphasizing this again. It inherited this property, this class, from the character class. You can see inside here my night, I don't have a constructor create character. That comes from my class over here, create character. And then this create character expects from my edit name.text edit, and that's not magic type. What is the next one? Is combo box type.text, and then my last one is my spin edit health.value, and then I can this one, as I said, at the type before I add it to my radio group. Let's add this to my radio group of my nights. At will be my index I night counter, setting that to, no, what am I doing now? Radio group night dot, typing all the junk now, dot items dot add, and then I'm adding my object night at index I night counter, and I can do the same like get name, and this get name is also inherited from the character class and not the night class. And I'm setting, no, let's say get type, adding a nice colon, and saying my object night at index I night counter dot get name, which is also from a character class. And then I can increment my I night counter. can probably do a toString also. Let's just do, before all of these, my rich edit, clear that. Then I can do for both of them my object, rich edit output.lines.add, and I'm going to say my object image dot add counter image. I want to do my toString, so I can just see what is my values dot toString, and then I'm going to do the same for my night, just with the night. I'm going to copy that from there, lend my own code, and add it there. So let's quickly test this, see if this actually works, or if we did a complete mess of code here. Okay, so my first character is Alan, will be a mage, 100, oh, that's a lot. Create character. Oh, what did we do here? Break, where is that? Break, result, F type, F2 string, name, type. Can't actually see what error is there. Object mage dot to string. We're going to comment that out. Then we can troubleshoot in a moment. Alan mage 100 create character, and then we can try the same for my knight. Make it Kim, create my knight. Okay, and then we have our two properties, our two items there. Let's quickly see what our problem was with the toString. Alan, you press Control, you can actually follow that. Character.toString result F type. Actually not sure what is going on, why that's not working. Let's test that again. Did I increment the increment before that? I incremented the wrong place. That's the problem. Yes, you see what I did here. I incremented at the wrong place. So I'm trying to access this first part. Will be the first number run will be item index 1 increment 2. So that's the problem here. That needs to be called before I do my increment. Otherwise, I'm trying to access something that does not exist, and no programming language likes working with something that's undefined or does not exist at the moment. Testing this one. Alan, type is a mage, 100, create character, and then it creates my character, the mage. And then let's make Kim, which is a knight, 50, create character 50. And then this was populated from my character class and also created my character class. Now let's use some of the properties in my subclasses, the knight and the mage class. So if I go to my code, if I click my mage, the specific attributes that are unique to the mage is the magic type and the level. So I added code for this, which actually checks the following. If I click the Mage button, it accesses my Mage, and it sets the magic type to whatever was in the Edit Magic Type button. The same with the level, and it does the clear, and then I add a toString, and I do a get spells method, auxiliary method from my class, my Mage class. If I press Control and I click on the spells, it takes me to the spells method of the Mage, and you see the spells is simple. If it's level 1, you can heal. If it's level 2, you can heal and levitate. If it's level 3, you can heal, levitate, and do some cool stuff. So quickly run and see if that works. Type over here, make it Alan, type some Mage, health is 100, create Alan for me. Alan's created. I can go to my Mage tab. I click on Alan over here. It populates my button over there for Alan, so I'm working with that one. Magic type, let's make it something like water. Level 1, if I increment that, level 1 you can heal, or just click the button, you can heal. At level 2, you can heal, levitate, and at level 3, heal, levitate, and do some cool stuff. So for the night one, I'm not going to go into code for that one. This is just the illustration. The same you can do with the Mage. You can actually do the same with the night one. You can add all the different components here you'd like to use. You populate it there. There's your output error there. And yeah, so that is the idea of inheritance. We work and get properties of that. Showing you this code just quickly again. This toString comes from, I'm going to press Control and go to the toString, and that takes me to the character class. If I go to the get spells, then I click that, and that takes me to my Mage class. So the way, just remember the way you click here, you create a object going up here. This is a Mage object of the Mage class. If I go to my Mage class, my Mage is an object of my TCharacter class, which is one of this, and the of that class, and that class is imported here. The same with my Knight. My Knight is in my Knight class is also a type from a character class, which is over there. There's my import for that, and in my accessing form, I've got all three of my classes listed here, my parent class and the two subclasses there. Yeah, so we get PowerPoint to work. I'd really like to say thank you. I think Microsoft Word, there's PowerPoint going now, deciding to work. From my side, I really like to say thank you for attending the session. I hope you got a better grasp of array of objects, a bit more of objects specifically. We spoke about array of objects. We spoke more about encapsulation as well, and we spoke about inheritance. Those are nice items that you can use, you can utilize, and you can really emulate any type of object you like. If you can think about it, you can emulate and you can work with that. Thank you, and see you in the next session again. Goodbye.
Well, that was an excellent session. Thanks to Jacques for that. He's also doing the next session that's coming up in just, I think it's 5 minutes time or something like that. I did star a few of the questions. We won't probably have time to go through all of them. And I also want to thank one of the people that's answering some questions on there, Patrick Prematin, who is one of our MVPs. So if you see Patrick on there answering questions, he's a guy that knows an awful lot, and got a lot of respect for him. And thanks to a few other people that have been helping us out as well. So that's what it's all about, sharing knowledge, and particularly inheritance. Object inheritance can be very tricky. I understand that. It's one of those subjects where you start talking about things that are very abstract. And so when you say, oh, inherit this and all the rest of it, it can very quickly get into language that's quite technical and not obvious, particularly if English is not your first language. So stick with us. We are going to keep explaining these kind of terminology. The next session is also by Jacques. It's actually quite a lot shorter. It's only 30 minutes, I think. And that will be Object-Oriented Programming Part 3, which is polymorphism and aggregation. And we're going to be going there in about 5 minutes. So let's just cover a couple of the questions. First of all, people were asking about record types. I kind of want to move on from that, but a record type is not really an object as such. It was let me just see how this spelled, MI Ramoxide, which is an incredible name. And they were just saying that they're a little bit baffled. They also talked about the fact that records just disappear once they go out of scope, once you're no longer within the scope of where that record was defined, then it does actually get reclaimed automatically. Whereas classes, as you saw with Jacques' creation there, where he had those errors, they are explicitly created, the objects, and they're explicitly freed up. There was a type of compiler where you wouldn't need to do that, where it used a thing called reference counting. But generally with the normal Windows type coding, you do have to create your objects and free them up and destroy them. So records are a little bit different. They're just collections of variables. So what was the other question? There was another one here. Well, just say for Jacques' benefit that Mo Maran was saying that they're really interested in the boot camp. So we've had a lot of very positive feedback. Many people registering as well. So I'm very glad for all of you to be along. All of these sessions are recorded. I know this particular session and the next one and the previous one were a little bit complicated. If it didn't sink in, don't worry. There is a live stream recording, and we will be probably chopping up some of these videos into more palatable bite sizes, so you'll be able to see them again and watch them again at your own pace. So don't panic if it didn't quite sink in. You will get to follow that along. How are we doing for time? Oh, we've got a few more minutes left. Yeah, and just really that goes back to rewatching these things. Someone was, Senior Tech was saying, oh, I'm a bit lost about the OOP, Object-Oriented Programming acronym. I get that, and I know that some people have found object orientation a little bit complicated. That's quite normal. You're not weird. You're not useless. Everybody struggles with it a little bit to start off with. That's why there are boot camps, and that's why there are books like Dr. Kevin Bond's book as well. So don't worry if you're finding it a little bit heavy going. Maybe you don't. Maybe it all sank in straight away. But if you are struggling a little bit with it, don't worry. There's lots more information about how this works. In particularly if I just go to chat, I'll just post this back up. If you go here, a lot of what we're showing today is from Dr. Kevin Bond's book. You saw Kevin in a session earlier on. Definitely worth viewing. Also, you can go to our own website, go to embarcadero.com, and we've got the .wiki there as well, and stuff like that that will allow you to view the information that you need and catch up. Okay, so we're basically at the time for the next video. The next one is following along from what we just did. It's building on that, polymorphism and aggregation. It's just more of the same. So you are following on from this previous video that we just showed. Don't worry, I understand it might be a little bit heavy going. As I said earlier on, stick with us, and we'll try and make it a little bit clearer as we go on. Anyway, off we go.
Welcome to this next session in the Delphi Coding Bootcamp that we are hosting for you. This session will be about polymorphism and aggregation, and I will be taking you through this next session. Yeah, about me, I'm Jacques Lowe. I'm a Senior Educational Specialist at the Western Cape Education Department in South Africa. One of my passions is developing problem solvers and critical thinkers. Teacher at heart, as I've been teaching for the past 7-8 years. For the past year, I've been supporting teachers and learners at the department. I live in Paarl, South Africa, and my hobbies include camping and to braai. So let's take a look at this session. Polymorphism aggregation, already told you about that. We will find that in the textbook in chapters 22, 23, 24. Textbook is how to program efficiently in Delphi. So the resources for this session, you'll find that on the session course 16, and then the presentation will be uploaded there. The sample application we'll be working with will be the polymorphism one. So let's jump into Delphi. If you follow the previous session, you'll know the program that we are working on, that we are still building on. This is the characters program. We've got 3 classes: the class character, our class mage, and our class knight. With the attributes of all of those, yeah, we spoke about that. I'm quickly just going to run through this, just get you an idea of what we've done. And also I've completed some of the code in this program. So let's give a name. Alan, the type will be a knight, 100 will be his health, and then this is the part we didn't get to get to in the previous session. So now if I click on the specific knight, you'll see he has his name gets populated there with a method. His armor, let's say his armor is good, and he has a shield, and I can create that, and then I populate this with my toString method from my character class. So the mage one, we've done that one. You can just quickly see if that still works. Max is our mage, max the mage, health 150, create the character. You will see there's our mage, and if I click on my mage, it will populate my name, magic type. Let's make it wind and level 2, and that creates my my mage for me. The next part that we'll be working with is this health part, but we'll get to that in a moment. So when we talk about polymorphism, the idea of that is where we have one method that can actually have various kinds of behavior depending on what you specifically want that method to do. And the way we actually get to that is we need to create a method, and I've got some script notes that I'm working for, just to make sure I don't have any problems when showing this. So I'm going to go to my class character, and inside here I'm going to declare a new, let's say, a procedure that I'll use this procedure in my subclasses, my class mage and class knight. Remember, the class mage is a object mage of the character class, the same of the knight. So this procedure we will use that to decrease our health. Decrease health, and then our parameter will be I amount of data type integer. And then what's different about this one, I'm actually going to add virtual and abstract to the end of this method declaration. And now you see, if I try to press Control Shift C, nothing happens. Let me quickly explain to you what these two keywords does for us. The virtual one allows this specific method to be overwritten or overridden or by other methods in other classes. So it can exist in more than one instance of this method. And the abstract, what that does, it allows for a no implementation of the decrease health method in this class. In other words, I do not need to have this decrease health in this class. Now, why would I need to do this specifically? This is getting back to the abstraction of objects and how we can use this. We can use the decrease health in the mage class or the knight class, but it will have different behavior as to our characters, how it will behave with them. So now going to my specific, let's go to my class mage. I can create the same procedure here. Decrease health, parameter is I amount, data type integer, and then I'm going to add override to the back of it. So then that allows me to overwrite what is in this specific method in the parent class. And then I can press Control Shift C, and that creates this specific method for me. And there you can see it was inherited from my parent class, my character class, and it's inherited over here. So that's the way we know we've got something working with polymorphism. And polymorphism is just the changing of already existing method. So here the method is created, and in this class we're going to change whatever's inside there. So let's decrease the health and create a variable here, local variable I health, and just doing that to help me a bit getting my code neat and organized. I health of the data type integer, and then I can say I health, I can set that to, and then I can do my get health, and this get health I will get that from, there's no get health function in this class, so I'm accessing my character class to get the health from this class, and that's also part of the inheritance that I'm working with here. So I have my health there, and now let's say, for example, if I'm a level 1 or level 2 mage, then I will only decrease my health. My health will be decreased with twice the amount that I receive. But if I'm a level 3 mage, then I will only decrease 1. So I can say if my level, and the level is in this, you can see level is in this private of this class, if level is equal to 1, or, and then I need to do my brackets over here, my first condition, if 1 or if level is equal to 2, and you can also have done the 3 one if you'd like to, then I can say I would like to set my I health to I health minus the amount multiplied by 2. Multiply by 2, and I can say else begin. I can set my I health to I amount to I health minus my I amount. So that's where I set that to, and then as this is a procedure, I still need to set my health, and I can do this by using set, the set health function, and I'll set that to I health that I've created here. So this is for the mage. So let's see where we can access this method. In my, I've got my health there, I've got my decrease health spin edit, I've got my decrease health button here. So I've already pre-coded this just to do some data validation for me, checking that my combo box is not, or my radio group is greater than -1. In other words, if it's not selected, then I know I need to code here. So now I want to access that. I want to say my object mage, and again this is an array of objects I'm working with. My array at index radio group mage dot items at radio group mage at radio group mage dot item index, and I'm adding +1 because my item index starts at 0, 1, 2, 3, 4, 5, and then my array starts at 1, so that's why I need to increase that by 1, but this should actually only be like that. Sorry for that. Radio group item index, and then I would like to decrease the health, call the method, and the amount will be from my spin edit decrease health. That's the one I'm calling here. It's going to the design over here. That one is spin edit, spin edit decrease health, the one I'm calling. And then we can do a, why do I have a problem here? Incompatible decrease health. Oh, dot value. And then I can do a, on my, I've got a reach edit health just in the same tab I'm working with, dot lines dot add, and then I'll add this whole object dot toString, accessing the toString of the character class in that case. And then I think I'm just going to unselect my radio group for the mage dot item index, set that to -1, so I can multiple click on the items and doesn't get confused. Let's quickly test that, see what happens. Let's add to my Alan, type is a mage, health is 100, create character. Then I can go to my mage. I need to set the, click on the mage, the magic type, let's make this water, and I need to set this level for my health to work. Let's go to the health tab, and then if I say decrease health, I set in my code if it's a level 1 or 2 mage, then it will only, it will decrease twice. So I'm expecting the health to be 98. Yeah, this is 98. I can decrease it again. Oh, I unselected that and click that one again. 96, 94. Let's see what happens if I make this a level 3 mage. Just continue. What did I do now? Forgot to select my mage in the radio group. Name Alan, type mage 100, create. Let's just select that this time and make it a level 3 mage. And then you can see there's the 3 items there. Go to my health, and then I'm going to decrease with 1. I'm expecting it to only decrease 1 to 99. Yes. So the behavior of this method is correct. We can change the mage's type to level 2 to make sure that if I decrease health, yes, decremented with 2 at that stage and another 2 at that stage. Okay, so that seems to be working. Now we can do the same for my, so that was my mage one. My knight one, I pre-coded this one, so we can just uncomment this. I've got a decrease health method over here that receives the IM mount, and again the override enables me to override this method in my character class. Going over here, and then in this case I'll just uncomment that, and in this case if a knight has a shield, then the amount decrease will be halved, and I use the div because we use integers here, and then I set my health, I get my health minus my I amount. So then in this case, just to iterate the importance of what we did now, my mage has a decrease health method, and my knight has the same decrease health method. But because of the nature of my 2 objects, the knight and the mage object, the method gets used differently. So let's quickly test and see how that works. Create my character. Let's make this max the knight. Health will be 100. Create that. Let's go to my knight. I need to click on him first. So I've got the one selected. The armor will be good, and he has a shield. And I'll click on knight, and then you'll see he has a health of 100. So let's go to the health button. I've selected my knight, and then I want to decrease the health by 1, and let's decrease the health with 10. So my code said I will div that divided by 2, so 10 divided by 2 will give me 5, so I expect this to be 95 his health. Of course this will not work because I didn't add the code for that. So let's quickly go do that. Sorry, head is all over the place. I've decreased the health. We've done this for the first one. Now we need to do the same for our knight. And just for the sake of saving time, I'm just going to replace my mage with knight, and please make sure when you do this you do it thoroughly, or rather step through the logic and make sure you have everything corrected there. So my object knight, get that, decrease the health. See, this is the same method that we call, but our result will be different each time we call that. Character, we had max there, knight 100, create the character. It's populated there. Select him over here. There's Max. He has good armor. He has a shield, and then he's created there. Go to my health button. Make this one 10. Now I was expecting it to decrease by 5. Yes, we have that. And if I go back to my knight and I select Max again, and I unselect the shield, so that's 95, then I'm expecting this, if I decrease by 10, to be 85. Yes. Okay, so I'm using the same method, decrease health, in both cases, and the result that I get from that is different. And that is specifically what polymorphism is about. The next thing we can actually do, which is quite interesting, is if I go back to my character class. Now you'll remember this virtual and abstract I added to my procedure decrease health. This virtual creates a virtual method of this, and the abstract allows no implementation in this specific class. But now let's say I have a method, for example, my toString method, and I would like to have an implementation of that in here, this toString, but I would also want, for example, to be able to override that. Then I can simply add virtual to the back of this one, and that allows a implementation of this method, the toString one, in this class. And then I can go to, let's say I want to do a toString in my mage class. I can go over here and I can do my function toString, and the result is a string, and I'm adding override to the back of that, and then Control Shift C allows me to create this toString method, and then I will set my result to, let's make it name. I want to say name, but now I can't, because of the encapsulation, I can't use the F name. But there's control space, there's no option for that. But I've got all the other ones. So the way I can access my name is to use the get method, get name, to access from my character. Luckily I have a get name method here. That's not in the private section. So I get my name of my mage, plus I'm going to add an hash 13. What else do we want? We will get name, other parameter type. Let's get the health, as we're busy with the health. Health plus get health again, but that's an integer, so we need to cast that int to string get health plus hash 13 for a new line, and then I've got my name, I've got my health. Let's see, let's get the level of the mage, as that's important in our calculation. Again, into string, and this is level is in this class. I can use the attribute for that. And do I need to have something else? No, I think that will be sufficient. So now let's take a look at our code that we have at the moment. I've got this toString method in my mage place, where I do my health, decrease health. I have toString that I'm displaying on my red health button, and in my knight I also have the red health and are using the toString method. So this toString method is referenced to the one in my character class, and this toString method is a reference to my mage class. So let's see the result, the difference between the two of them. Go to my characters, Alan the mage, 100 health, create that one, and Max the knight, 150 health, create my character. For the two of them, I can click on my mage. Let's give a magic type, will be water, level 2 mage. Go to my knight. If I select max there, its armor will be heavy. He has a shield, and I populate that, so that's populated. So now if I see I didn't unselect these two, so what will happen now is it's actually going to display both of them underneath one another. Good programming would have been after you click this button to clear up all your edit boxes and unselect your your radio groups. I didn't get to do that now, so I'm going to decrease the health. So there you see the first one is Alan, and then I've got Max. Note the difference in the display. I'm going to do this again, but now this button it's unselected the items. If I select my mage Alan and I say the decrease one, you can see it uses a different notation here than Max that has there. This is because my toString method of my mage class is the one that I'm overwriting in my character class, and that also refers to polymorphism. I'm getting a different result for using the same method that it was intended to use. Over here you can see that, and I can do the same with Max. Max will have the default toString in my character class, and Alan will have, that's 0, my own toString method that's unique to the mage class over there. So the two major points from this polymorphism that you should actually take away is the way that we declare our procedure and functions. We add the virtual and the abstract. The virtual allows you to overwrite the specific method in a different class that inherits this class, the parent class. And also the abstract allows for the non-implementation of this specific method inside this class. And then inside our child classes, our classes that inherit, we have our subclasses. We have our override, where we add that to the back of a method, allowing us to override the parent or base classes methods that was provided for us. So the next item I'm just going to talk about, and that is regarding the aggregation. So the idea of aggregation is the textbook definition is a special form of association with the meaning of a whole part hierarchy together with the ability to navigate from the whole parts to its different parts. So it's just actually setting up the relationship between different items, where we have our class, our character, for example, a character, and we can test for aggregation to see a character has a name, a character has a type, a character has health, a mage has a name, a mage has a type, and a mage has a health. So we refer to this, there's two types of aggregations. The one is a strong aggregation, that's actually a composition. For example, they use the reference of a book. You can't have a book without pages inside the book. Then you'll just have a cover. So a book needs to have pages, and then that is called a composition, where you can't have only a part of the subclass. If your book is your base class and your page is a subclass of your book, you can't have a book without pages. And then there's no aggregation between the two classes, where you need to have those two together to work. It's a composition, a whole part of the relationship or association with the aggregate object cannot exist without these components. And the other aggregation, the one that like we have, is the relationship between the character and the mage. And the character and the mage, the relationship we have here is, for example, we can have a character, but we can aggregate that, we can extend that into the mage class, subclass of that. So you can have a character without your mage or knight attributes, but you can't go other way. You can't have a mage without a name, so it needs to inherit that from its parent's class. That's only, that's the part of the aggregation that we bring into this, the relationship, the hierarchically relationship between the two classes and how they fit in with one another. So that was this session. It was a bit shorter than the previous one. The work actually flows nicely into one another, and I hope these two sessions really helped you to understand a bit more of object orientation and how to work with that, and that you will be able to utilize that in any programs and endeavors that you'll be working on in the future. Thank you for tuning into this session, and enjoy the rest of the bootcamp.
Well, that was excellent. Thanks a lot, Jacques there. Jacques is not going to join us live for the Q&A as far as I can work out. So it's going to be me answering some questions. The Q&A, shall we say, has been quite lively, talking about everything from where people were born to things like Simula 7 and stuff like that, which is slightly off topic about what we're talking about. So let me just go through a few of these questions, because there were quite a few. Probably the most kind of relevant question, and Kirk is pretty he's answered quite a few questions, so I know he knows a thing or two, and he was asking whether you could instantiate classes with unimplemented methods. What that means is that you have got in the class something that doesn't actually exist further down. You can't do that unless it is an abstract or a virtual method. I don't want to talk too much about things like interfaces, because that's when it's going to start to lose people here. Basically, if you can do it and the compiler doesn't complain about it, then you're good to go. But the short answer is no, you can't normally do that. It's almost like if it's a regular method that you've defined, then if you haven't got some code anywhere further down in your program, the compiler is going to say, well, hey, you've got an unimplemented, it's a forward declaration, I think the compiler message is, or something like that. What it's basically saying is, you've said in your contract of your class that there's going to be some code that does this thing later on, and this thing later on doesn't exist. So in that respect, you'll find straight away that you'll get a compiler error message. When you talk about virtual and abstract methods, then they work slightly differently. If you are inheriting a class and it would have to be a thing called an interfaced object, and it's from an interface, then actually you will get error messages again if you haven't implemented all the parts of an interface, which is a T interface, because again, that is a contract. It's saying that whatever your object is, if you are a knight, which was the example we had here, and you have a use sword method or armor on or off property or something like that, and you don't later implement that, then your contract is broken. You've said you're going to implement it. Where is it? So the simple answer, or the short answer, is no, you can't do that because the compiler will complain. The slightly longer answer is there are ways of doing it, but you know, it's a bit too much of a subject to go into. I'm very aware that what we're discussing at the moment, for some people, is probably overload and a little bit kind of overwhelmingly technical, because if some of the people that have followed along in this boot camp were just learning about loops and arrays, now when they're talking about polymorphic inheritance and aggregation and stuff like that, then that can really lose people very quickly, especially if English is not the first language or even their second language. So there you go. Let's have a look. What other questions have we got? So yeah, this question was in relation to destructors, because during Jacques' demo there, which if you didn't quite absorb it all, go to the replay and watch it again. I think the question was relating to overriding destructors, and someone said, oh, well, can you override a destructor then? In other words, when you create a class and when you destroy it, the part that is triggered is the destroy, the destructor, which is the common term for it. And you might want to override it. Yeah, so you certainly want to do something with the destructor, so that if it's got child objects or some database that it's linked to or some weird stuff like that, you actually want to manipulate that in the destructor, so that when your class is destroyed, then other things are tidied up as well. And that's very, very common in classes, because you might have a class that's got subclasses. I mean, it's very common you'll have properties that are classes that are created, and that class owns them to store some information. Could be records, could be other things as well. And in your destructor, in your constructor, the thing that runs when you create your object or your class, you will create those child classes and child objects and pointers and things like that. And in the destructor, you'll then tidy those up if they need to be tidied up. Depends again how you implement them. And the question says, so it only manipulates and destroys the created instance of the record, which was in a record helper, I think they were talking about. Same with the destructor of a class. You are trying to encapsulate the functionality of that class within the class, and not rely on outside objects. That's one of the whole points of having a class, is to try and encapsulate some functionality. And the point about inheritance is also inherit behavior from an ancestor class. So for example, if I took a human being and I was going to create a class called mammal, I might have a T mammal class, and I might have an ancestor class, so that called a T animal class. That animal could be a mammal, so a mammal has hair and suckles its young and things like that, and is warm-blooded. But another animal might be a marsupial, which is not a mammal. It actually has a different way of rearing its young, and some marsupials lay eggs, as you're aware. So the animal class is the ancestor class. The mammal is an ancestor of animal because it is a descendant of animal, because the mammal is an animal, but it's not the same animal as a marsupial. And you might have a duck, which is another descendant class of an animal, because a duck is an animal, but it's not a mammal and it's not marsupial. So that's how inheritance works. That's quite often the most common example you'll get given of object orientation and ancestors and stuff like that. You could have, for example, a human, and a human is a mammal, but technically is not an animal, but technically, genetically, we are animals. We just happen to be called humans. And you might say that there are different types of human. So let's say that one day a new form of human appears, and that human has superpowers. And so that human can fly. So up until now, you've had animal, mammal, human. And then all of a sudden, there's a new type of human that has superpowers. It's Superman, and Superman can fly. You still want it to be a human, but this particular type of human, a superhuman, actually is not a new descendant of humans, but is a side-by-side implementation of the human being. He just happens to have superpowers. And so that is polymorphic inheritance, because now we are taking that human and we're having two types of human, and that they both descend from an ancestor class. That sounds complicated, and I'm probably doing a very bad example of explaining inheritance, but animals, mammals, humans, marsupials, ducks, that's how inheritance works in the real world, and that's exactly how you can map it into your objects in the virtual world in programming. That really is the key to object orientation that these 3 sessions we've just had. It's about trying to make sense of being able to represent real world objects in the virtual world, in the programming world. Okay, that is what object orientation really is. And I've seen lots of different ways of explaining it. That was Jacques' way of doing it with knights and things like that. I've seen other people explain it with fish and sharks and stuff like that. And obviously, as the example I gave, which is animal, duck, and human being, and all the rest of it. But once you do start to understand object orientation, it's extremely useful. And it's so useful that nearly all programming languages now are object orientated. Back when I first started coding in the 1970s, which was the first time I wrote programs when I was a teenager, there was no object orientation. It was not a common thing. It did kind of exist, but it was not the typical programming paradigm. It was all procedural code. And then in the 80s, when I first started, I wrote COBOL programs for a long time as a COBOL programmer and a C programmer. We didn't have object orientation. And so representing the real world was actually quite difficult. You would suddenly have an integer represent, a number representing something that was actually much more complicated, like a sales order that has, a detail and a header and all the rest of it. So object orientation does make programming easier, but actually getting to the point where you understand how object orientation works is a little bit more of a kind of educational hill to climb. So, I know people struggle with it. And as Kirk just said, they can access each other's private members because they're in the same unit. Well, yeah, they don't have to be in the same unit. That is to do with namespaces. And in fact, it's common in Delphi, for example, to have a unit that's got interfaces in it, which we'll probably talk about at a different time. But the classes that are what's known as the concrete implementation of the interface is in a completely different unit. The advantage of that is that people can then include the interface without including the whole class implementation. Scrolling across the bottom of the screen at the moment, you can see the links to the language that we've been using all week and particularly using today, which is Delphi. It is a type of object Pascal, and it's very easy to use and understand, even weird things like object orientation. The next session that we're going to be talking about is called Keeping Secrets with Encryption. And that session will use, I haven't seen it yet, but that session will use a lot of the features of Delphi that makes it very easy to do encryption. and this is one of the powers of Delphi is a very, very fast language to get out there and write programs. It's much easier than many other languages. It's with Wouter Theron, I think I'm saying his name, and we are about to start that video any minute. So thanks for sticking along. Enjoy the video. I'll see you later.
So welcome everybody. Today we're going to be talking about encryption. We are first going to talk about some overview of terminology, then I'll introduce the mechanics of the Caesar cipher, just quickly mention modular arithmetic before we dive into the coding of encrypting, decrypting, and then I'll also offer a different view and how you can approach this type of problem. I'll just mention here that in the interest of time, going into modular arithmetic, there is not enough time. So the book actually does a fantastic job of delving into that particular topic. I would definitely highly recommend that you can check it out. So first, we start with encryption. What is it? So we say that a method of converting information, so which we refer to as plaintext, and into a secret form that cannot be interpreted, which we call ciphertext, using a secret method of interpretation, which we refer to as a key. So, for example, if I take the word hello, and I take each character or each letter within this word, and I move it 3 spaces along the alphabet, the output would basically give me KHOOR. In this case, we refer to hello as the plaintext. And the fact that I've moved 3 spaces to the right or down the alphabet is my key, and which produces an output which we refer to as the ciphertext. So, the Caesar cipher is also known as a shifting algorithm or shifting cipher. So, its simplest basically just to label out the entire alphabet, starting at position 0. That become important a little bit later on. And we need some kind of key. So basically the key tells me if I've identified some letter, how many characters or how many characters I need to rotate clockwise to find the new one. So for example, if we start with the first character of the word hello, which is the H, I identify the H on this alphabet, and then I apply the key of 3, which means that I need to move that H 3 spaces along down clockwise along the dial. So that should give me K. Then I do the same for the E. Identify the location of the E. I move 3 spaces on, which will give me the H. Same for the L. Identify where the L is located. 3 spaces on gives me the O. I've got 2 of them, so it's a double O. And then finally, identify the position of the O. Move 3 spaces on to the R, and that gives me my complete ciphertext of COR. Right. So if we're using an alphabet, there are 26 symbols used in the alphabet. So mod 26 is what we're going to use. To make this work, we essentially start with position 0 at the top, and we label that A, and then that gives us a total of 26 spaces all the way to 25. Right, and this is quite useful for us because we can use mod to calculate the net effect of any movement. So, for example, if I start with character A and I move clockwise or anti-clockwise for that matter, then I'll just end up back at A again. And the modular arithmetic plays nicely because if I move 26 and I modulate that with 26, I just get 0. Right? So that's just basically the 0 can be seen as my net effect or as my remainder. Or if we start with position A, position 0 and the letter A, and we want to move 30 spaces clockwise, that would mean after 26, we will just end up back at A. So that means I need to move an additional 4. That gives me B, C, D, gives me E, right? So applying the modular arithmetic to this, using mod 26, I can easily calculate 30 mod 26, which is equal to 4. So that gives me the net movement of position number 4. Okay. So let's delve into the Caesar cipher. I hope you enjoy this. Right, so I've got a console application open at the moment. One of the big annoyances of using a console from the IDE is that whenever you run the console, you don't actually get a chance to see any of the output. So if I just say here, hello, and I basically run this, we see that there is output, but it will happen so quick that I don't actually get a chance to see anything. So I would always just put in a read line here at the end, basically just to wait for user input before continuing. Right? So just by as a default, I'll just always put that line in there. But yeah, okay. So what we want to do now is we want to basically allow the user to put in some plain text, okay? And what we need to do is we need to look at each and every single character of that input and determine where exactly that character is located on the alphabet, and then we want to push it ahead by the key. So let's say the key is 3, we want the letter to move ahead 3 spaces. So there are a couple of ways that you can do this. We can use strings only, but that causes a little bit of issues, or we can opt for an array, which simplifies things a little bit, but it also means that we have to focus a little bit more exactly what we're doing and what position we are in. So I'm going to show the method of the array, and then I'll maybe show how we can also do this using strings only. So I'm just going to clear some variable here. Let's say put in an array where I'm going to place my alphabet. Let's just define this as an array starting at index 0 and going all the way up to 25. And we're going to put some characters in there. Okay, so I'm starting with position 0 because this is going to play nicely with our modular arithmetic a little bit, as we'll see a little bit later on. If we start at 1, that causes a bit of issues, and we'll look at that maybe in an example as well. So I think the easiest for now is just to declare an array starting at index 0, going all the way to 25. So we've got an array with 26 slots, and the idea is basically going to be to put a character of the alphabet in each and every one of those slots. Okay, so we could, if you want to, you could go over here and you can just declare all of your characters individually if you want, but I think that's a bit time consuming. So what I normally do is I just say, okay, well, I've got an integer here, let's just use a loop to populate this thing. I think that's probably going to be simplest to do. Okay, so one way to do it would be to use the ASCII table, right? So looking at the ASCII table, we've got all the characters here. We see we've got uppercase A, we've got lowercase a, but for the purposes of this demonstration, I'm only going to focus on the uppercase. So we see that A corresponds to decimal 65, and if we scroll down, we see that the capital letter Z corresponds to the decimal 90. Okay, so I need to keep 90 and 65 in the back of my head. All right, so here's what I'm going to do. I'm just first going to populate the array with characters, let's make it uppercase, from the alphabet. Well, maybe we should say maybe from the ASCII table now. And we know that A corresponds to 65 and the last one Z corresponds to 90. Okay, so we're going to run a loop. I'm going to say for I is equal to 0 to 25, do, and let's say to begin, because we're going to start with index 0 on the array and we're going to run all the way to index 25 on the array. So I have to use the index of the array if I want to do this. Okay, so we're going to say our alphabet, oops, alphabet, position I, and well, we can get a character from the ASCII table using the command char and then inputting some type of number like 65, and that will give me the A. but we want to start at 65. So, and since the I runs from 0 to 25, I can literally just put in an I there. So this will give me, as the loop runs, it will give me a all the way down to when I is equal to 25. We get 25 plus 65, which gives me 90. So I should get the Z. Okay, so we can just run this, and obviously nothing happens because we don't have any output on our system at the moment, but we can kind of get a view to see what is going on if we just output this thing as it's happening. So I can literally just put in right, and every time after I've placed something in the array, I can just output it, right? So running this, I would expect to see all the characters from A to Z appear on the screen. Okay, so we've got A all the way through down to Z. Right, okay, so now we've got that, that's all working, so I can just comment this part out, I don't need that. I know my array is populated with the letters of the alphabet. And now we can start thinking about how we're going to encrypt and how we're going to decrypt it later on. So let's maybe put in some variables here. And let's put in a plain text variable, and let's put in a ciphertext variable. Okay, and both of these types are going to be of type string. And maybe we want also some kind of a key input as well. So let's say the key is an integer, and this is basically the key that we're going to use to shift our letters along the alphabet. Okay, right. So let's put in some input here. So we're gonna ask the user for plain text input. Okay, so let's do that. We say right line. We're gonna say please enter some plain text. Oops, plain text. We can capture that. Read line is plain text. Okay, so we've got the input. Right. So now what we need to do is we need to basically look at the input that the person has put in. But remember, sometimes when people type in things, sometimes they'll do weird things. So maybe someone will type everything in caps, and someone else will type everything in lowercase, and then you've got other people that do a mixture of both. And since we are only working in capital letters, I think it would probably be safe to just make sure that we actually also only work with uppercase letters. So whatever the person puts in, I'm going to make sure that I convert the input to uppercase. Okay, because that's going to make it a lot easier. Obviously, if you wanted to work in lowercase, then the ASCII table would work a little bit different for you. You would basically start here at position number 97, and you will work your way through down to position 122. Right, so that's up to you how you want to do this, but I normally just use uppercase. It's just simpler that way. So when I do these types of algorithms, I like to just comment them in so I know exactly what I'm dealing with, and I can visually see what I'm doing and where I'm supposed to go. So I'm just going to put in the alphabet in here. Luckily, I don't have to type out the whole thing because it's already here for me to use. I can just run this and just copy all of that. Right. Put this in over here. And let's just assume that the input that I'm going to use, let's say we can use the word hello. And also let's assume that I'm going to apply a key of 3. So that means that every single character in this original string needs to shift to the right by 3 spaces. So we need to determine what ciphertext I should expect as an output. Okay, so this is our input. Let's assume this is our input, and we are assuming that we're moving 3 spaces. So what we need to do is we have to look at each and every single character in this input string. And for each character, we need to figure out where exactly it's located on the alphabet, which is over there. And then once we've done that, we can apply 3 shifts to the right. So 1, 2, 3. So the first one corresponds to K. So plain text H corresponds to cipher text letter K. Okay. And then we do the same for the E. So we look for the E, right? And we say 1, 2, 3. So that E is basically going to move to the new position. So the new letter will be H. And let's look for the L. Let's move on 1, 2, 3. We get the O over here. We've got 2 of them. And last but not least, we've got the O from the hello. And that needs to move 1, 2, 3. So that should give me an R. Okay. So at least now I know when I'm applying this algorithm and I'm evaluating my input with hello, I know which output I should expect to get. Okay, so there's actually 2 things happening here. The first is I'm going to loop through this particular string, the input, the plain text string, and then while I'm looking at each and every single character within the string, I need to loop through the entire alphabet over here and able to find that particular character that is located in the string. Okay, so let's first see if we can do that. So because I'm running 2 loops, I'm running through this particular string, and I'm also going to have to run through this array. I actually need 2 loops, right? So I'm going to go up here, and I'm going to add another variable j, which will allow me to loop through the array. Okay, so let's say, and I don't want to have to put in, I haven't actually put in a key here at all, but let's just do that quickly. So I'm going to comment this out for now, because this will save me from having to type in word hello every single time. And let's just assume that our key is equal to 3. Okay. Right. So let's first loop through the string. So I'm going to say for I is equal to 1, because the first character of a string always starts at position 1, right? To length of the input string, so it's plain text, do, begin. Okay. So now we need to start looping through the alphabet, because what I want to do is I want to find this particular character in this alphabet. So I'm going to say for j is equal to 0, because that's where the index of this array starts, to 25, do, begin. Okay. So the first for loop is for the string, the second for loop is for the array. And I'm going to say, okay, if is plain text I, in other words, the character that I'm looking at this point in time, if it's equal to the corresponding character within this array that I've got up here, then again, let's say let's do our alphabet j. So what's actually happening here? So we are looping through the word hello, and I'm going to isolate each character one at a time. So the first, when I is equal to 1, I'm going to be looking for the h, and then I'm going to loop through this this array until I find that h within the array, right? So this position here of I and j, so j being from the alphabet and I being the first character of the string. So once I find that character in the alphabet, all I'm doing is over here I'm outputting that same character, but this time from the alphabet. So if I just run this, I would expect to get hello. Okay, so we go. We've got hello over here. Let me just clean this up a little bit. Go up back here. It's going to annoy me. Sorry. I'm just going to comment this out as well. Let's run this quickly and see what this looks like now. Let's look at the alphabet. I'm just going to comment out that part in the beginning as well. Just give us a cleaner output. Okay, so we've got output hello. Perfect. So now what we need to do is we need to take whatever the position is in the alphabet. In this case, the corresponding position when we found it is going to be equal to J. And then we're going to apply our rightward shift of I key. And I key is equal to 3. Right? So we're going to take the position where it's at, and then we're going to shift it on by 3 spaces. So if I run this now, I would expect to get an output of KHOOR, which is what I've got. Perfect. That's not too bad. So we can formalize this a little bit more. We can say, okay, let's just build a string, ciphertext. Let's initialize it as an empty string. And then rather than having right over here, I'm going to say ciphertext is equal to ciphertext plus, and I'm just going to add that letter from the alphabet. Okay, and then once the loop is completely finished, I can now return over here and I can say right line s cipher text. Okay, so let's run this and I get exactly the same output. Great, this works perfect. So what could possibly go wrong? So let's say I put in something else. Let's say we can go back over here and now we can change our program a bit. We can say please enter some plain text, and we can now record whatever the person wants to put in. Right, so we don't have to put in hello the whole time. And we can also say right line, please enter a key. Right, that's for our cipher. And we're going to say read line I key. So we capture that information. So running this as before, we can type in the word hello, type in the key of 3, and we get quote, right? And as I mentioned earlier, even if you type in lowercase, it's not going to make any difference whatsoever. So when I've got something like this, I like to run it a few times just with some test values, just to see if this behaves the way it should behave. So if I do 4 A's and I move everything on by 1, I should expect to see 4 B's, which is what I've got. Or let's say I do A, B, C, D, E. Let's move it on by 5. I get F, J, H, I, J. Perfect. But what happens now if I enter, say, the letter Z and I move it on by 1, right? And then I get a smiley face. Okay, so that's not what we want. We don't want smiley face. We actually wanted to loop back, right? We wanted to when it goes beyond this beyond the letter Z, we actually wanted to start at A again, right? So how do we do that? Well, we've already looked at modular arithmetic, and modular arithmetic basically enables me to start from A, go to Z, and then when it goes beyond Z, it can basically go back to A. So how do we do that? So let's first see how that's going to work. So let me just comment out this part over here. Maybe we can comment out. Actually, we don't need to comment out anything. So the problem is over here. So we've got J plus I key. So this is going to be problematic for us when this value exceeds 25, because then essentially it's nowhere located in the array anymore. There's no corresponding character for J plus I key when this value is greater than 25. Okay, not a problem. So we just take that value, whatever it may be, put in little brackets, and then we just apply mod 26, right? Because if we get to, say, position number 26, which was a problem for us, right? When we move the Z beyond one position, we get to position 26. And if we do 26 mod 26, we just get 0. So that would just give us the A again. Okay, let's see what happens. So let's run this. So let's type in the letter Z, type in the key 1, and then that's perfect. I get A again. And what's really nice about this modular approach is that if I type in Z, and let's say I type in any number, let's say, I don't know, this big number, it will just keep looping around and starting from A and run from A to Z the whole time. And what's also interesting here is if I take, say, the letter A, and I shift it on by 26 positions, then I should just get back to A. Or in fact, any multiple of 26 is going to bring me back to the same character. So let's say type in 52, which is 2 times 26, and I get back A again. Right? Okay, let's see if we can decrypt this thing. So I'm going to just start with whatever we've encrypted, and I'm going to see if I can start with this particular string and then use the same key, see if I can go backwards and go back to the plain text. Right? So this essentially now we're starting with this, and we want to see if we can move back to allow. Okay, so I think the algorithm is essentially going to be the same, because we are going to look at each particular character within this string. We're going to find it in the alphabet, and then rather than moving the letter 3 spaces to the right, we're just going to see if we can just move it 3 spaces to the left. So let's do that. So let's say for I is equal to 1, because the string starts at 1, to the length of S ciphertext, right? 2 again. Okay, and we're going to run through the loop through the array as well. So 0 to 25, do again. I'm going to say if S cipher text I is equal to R alphabet J, then begin. It seems perfectly reasonable to assume that we can do something like this. We can say R alphabet, and we're going to put in here J minus I key. Seems doable. Mod 26 like we've done before. And yeah, that seems reasonable. So we basically loop through this particular ciphertext. We look for each character in the array, and once we find that particular character in the array, we just move 3 spaces to the left. We keep the mod 26 there in case we're dealing with large numbers, but we actually don't need it now. So let's take it out for now. So just run it and see what happens. Enter some plain text. Hello, let's place 3. And I get queer, and then after my algorithm has been applied to this ciphertext, I get back to hello. Okay, so that looks kind of promising. But what about if I try something else? Like, let's say I put in the letter Z, right? And let's move 3. So if I start with plain text Z and I move 3 spaces onwards, I'm going to get ABC, right? And then ABC, but then when I try to go back from C to plain text, and I just get an empty part. So what's actually happened here? So over here, essentially when J minus I key, if that value is negative, then we're actually moving outside of our array, right? So that's not part of the array anymore. So you can say, okay, well, let's just do that thing we did before. We're just working in mod 26, so that should solve the problem. Well, let's see. Z, and I press 3, and I still have a problem. And the reason for this is that in Pascal, when we apply mod 26 or mod to any number, if the input was essentially negative, if this number here was negative, it's going to give me a negative answer as well. So it doesn't actually revert that number back into between the numbers from 0 to 25. So one possible suggestion may be, okay, well, maybe if this number is going to be negative, maybe we can make it positive, right? So we've got a function for that. It's called absolute value. So absolute value takes any number and then returns the same number, but just the positive of that number. So -1 will become 1 and -6 will become 6. So this seems like a reasonable thing to do. So let's put in a z, move it by 1. We get A, but then when we go back, we get B. So that's also not quite right. Okay, so that doesn't work. Okay, so let's try something else. So the absolute value doesn't work. So one way to think about this is to go back to the original discussion. Where we had our alphabet. Okay, let's just think about what's actually happened here. So we started with the letter H, right? And then we applied our key 1, 2, 3, and then we landed back at K, right? So H has moved to K. So one way to do this would be to say, okay, well, hang on. If H moves by 26, then H just stays in the same location. And another way of saying that would be, well, after H has moved 3 spaces to K, if it moves an additional 26 spaces, it's just going to end up back at H again. So what I'm saying is that whatever the location is at this particular point in time, and the key is 3, for example, that means that I take this and I apply an additional 23, that's going to solve the problem, because I've moved 3 and then I moved the additional 23, so that's just the same as when I started. Nothing has actually moved at all, right? So let's try Z, 1, A, and X. That's also not right. Oh, because I moved by I moved by 1. I'm sorry. I'm really sorry about that. So Z, let's move 3. And I get C, and then I get Z back again. So that's absolutely perfect, but we saw just now that if I actually use a different key, then this 23 is absolutely useless, right? So we can't be using a 23 here. So we can say, okay, well, let's just change the 23 to 26 minus I key, like so. Okay, so run it now, and let's say put in Z and 1. I get A and I get Z back again. Okay. One thing that might be a little bit strange about this is if in the case where you've got 26 minus I key, and it's going to be a number that's going to be negative again, and that's going to cause problems for you. So if you put in like a really large key, for example, let's say Z, and let's put in 53, for example, so that should move me to A, because 52 will move me back to Z again, and then an additional 1 is going to move me to A. I get A, but then once again I'm stuck. I'm not getting any output again because the key is too large. So you can actually reduce the key, because if you think about it, a key that moves something by 3 or by 4 or by 5 or whatever, regardless, it's always going to move. It's only going to have an effect as long as it stays within this realm. So either the key basically is there's 0 movement, where it just stays where it's at, or it's 1 movement, or 26 is just going to be back where it starts again. So essentially, we can reduce the I key to its net effect. So we can say use mod to reduce the value to its net effect, or its remainder, right? So we can say I key is equal to I key mod 26. So if someone, for example, types in a really large key over here, let's say, I don't know, something like 53, for example, then 53 mod 26 is just going to equal 1. So that's the same. If I use 53 or I use 1, it's going to have the exact same effect. So I might just as well reduce its value back to 1. And then I won't have a problem here where this value is going to exceed 26 and cause problems. So if I run this now, I press Z, let's move it by 5,000. I get H, and then I get Z back again, right? Or if I use the example that we've been looking at, Z, and I put in 53, I should get A, and then from A, I get back to Z. So I just want to formalize this a little bit more and say is plain text is equal to the empty string, and then rather than having this right over here, I'm going to say is plain text is equal to is plain text plus this R alphabet mod 26 business. Okay, and then once it's all finished, I can just say right line is plain text. Okay, so running it the first time, let's see, type in hello, the key is equal to 3, I get hello, or cool, and then I get hello back again. So the method that we used an array, but I also said this is also possible to do it with a string. The book does actually go on and talk about public and private key encryption, but to lay down the foundation for that is going to take quite some time, and there's definitely not going to be enough time to delve into that. But the book does have some excellent examples, and they provide some code as well for you to explore. So I thought maybe I'd use this time to revisit the Caesar cipher, but maybe just show you a different way to think about the problem, rather than having to shift the letters left and right. So for this, I'm going to use a constant. Let's just call it alpha for alphabet. Let's call it, yeah, alpha alphabet's fine. So you can see. Okay, there's my alphabet, and I'm going to need some variables. I'm going to have plain text. I'm going to have my ciphertext as a string, and let's put in an I for an integer, and then I'm also going to add a salf. Let's call it cycled, also a string, and this is going to become clear in a second. Okay, so first things first, let's maybe get some input. So right line, say please enter some plain text, and we can capture that and say is plain text, and we can also ask the person to enter some key. I'll fix that now. Please enter a key. Just fix this quickly, and let's capture that as well. IQ. And we need to declare a variable for IQ. Okay, so we've got our plain text and we've got the key, and what I'm proposing to do now is the following. So what I'm saying is that if we have, say, alpha, and alpha is equal to the alphabet as we know it as a constant, and what I'm saying is the following. So let's say if someone puts in the word hello, and we've moved it by 3. So this is no different than, rather than moving the letter 3 spaces onwards, we can also think of this as moving, rather than moving moving the character 3 spaces to the right, we can also think of this as moving the entire alphabet to the left, if that makes sense. So in other words, what I'm saying is if I do salf cycled, and I can cycle those 3 positions to the left, so let's say this is my alphabet. So what I'm going to do is I'm going to say, okay, I'm going to move everything to the left, and then the A should just be back in the end again, and I move it for the second time, and the B gets added to the end, and I move it for the third time, and the C gets added right at the end as well. And now we'll see that H is completely aligned with the K, and we see that the E is aligned with the H, and the L is aligned with O, and the O is aligned with R. So basically, we just essentially just cycled the entire alphabet 3 units to the left. Okay, so to do this, let's start with F of cycled, and let's just copy what we have for the constant. Right, so now both of them have the alphabet in them, and let's just see what this does. So let's say for I is equal to 1 to 1, do begin, and let's say S of cycled is equal to well, what we want to do is we want to copy one thing at a time. So that means I'm copying from position number 2, and I'm copying a total of 25 characters. And then after that, I'm going to put the A at the back, right? So I'm going to say copy, and I'm copying from S of cycled. I'm starting copying at position number 2. Let's make this a little bit bigger. And then I'm copying exactly 25 characters from position 2 onwards. So that should give me, just that command alone will result in S of cycled being equal to B to Z, right? And then let's just add the first letter, so S of cycled, and let's add position number 1. Sorry, it's my home language that's messing with me now. Okay, so if I've done that, and I can do a right line over here, S of cycled, I should expect to see B to Z and then followed by an A. So no matter what I type in, doesn't really matter, but I get B all the way through to Z and then A. So if I apply this 3 times, or I key times, then I should get D to Z, then ABC, right? So just type in, doesn't matter here, the key is important. So I get D all the way through to Z and then followed by ABC. Okay, that's pretty cool. So now all I need to do is the following. I say, okay, I just loop through the plain text. I say for I is equal to 1 to the length of S plain text, do, again. And we need to find the position of the character that we're looking at in plain text. So in this case, we're looking at example hello, and I'm looking for the position of the H in the original alphabet, right? Once I've got that, I'm going to take that position from the original alphabet and return the character for the same position from the cycled alphabet. Okay, so let's see how this works. So I'm going to say, let's maybe do this to S ciphertext is the empty string. Okay, ciphertext. What have I done here? Ciphertext. Sorry, ciphertext. Okay, so we say F ciphertext is that, and then we're going to say S ciphertext is equal to S ciphertext. I keep putting a T there. And now comes the tricky part. So first thing is I'm going to look for the position of S plain text I, right? We're going to look at the H, the E, the L, L, O, and we're going to look for that position in the original alphabet, right? So this is going to return, this part over here is going to return an integer value. Okay, so what I want to do is that position of the, let's say the H, and we've got the position here, let's see, 1, 2, 3, 4, 5, 6, 7, 8 in the original alphabet corresponds to position 8 in the cycled alphabet, right? And the same is going to be for the E. The position, which is going to be 5 in the original alphabet, corresponds to the position 5 in the cycled alphabet. So I'm just going to say, okay, well, that's just the S cycled alphabet. S cycled, S of cycled like that, right? See, so I basically just look at the position of the letter in my plaintext string in the original alphabet. Then that same position, I'm going to read that letter from the cycled alphabet using that key that we applied earlier. And then I'm just going to say right line is ciphertext, like that, and let's see if it works. Let's say hello, enter key 3, and I get quote. And what's nice about this approach is even if it doesn't matter, I don't have to mess around with mod at all. I can say hello, and let's say I move everything on by 53, for example. You know, so I would expect the H would go to what? H would go to I, and then we would see that the E would go to F, and the L would go to O, right? And the O would go to P. So let's run that, IFMMP. So this works actually really well. I don't have to think about mod or anything like that. I just thought it would be a different way to approach this problem. And then, of course, if you want to decrypt, it's going to be exactly the same thing, but rather than cycle everything the way that we've cycled here, I'm literally just going to cycle the other way, and then I should basically be able to decrypt. Not a problem, and I think that concludes the Caesar cipher. Thank you so much.
Okay, well, that was a pretty comprehensive quick run, shall we say, encryption, some fairly basic level encryption, but it was really good. And I've got some good news that I've got his name right. He's corrected me. Wouter Theron is with us live and ready to answer your questions. Hello, Wouter. Oh, hang on. He's got to press some buttons. There you go. See, he's a master of master of encryption, but not necessarily cameras. Is that right?
Yeah, that's right.
Yeah. Hey, great video. A lot of very positive feedback on it as well. Especially from Bertie, who seems to think that you've missed your career choice and should go and work in broadcasting. I think
Broadcasting, yeah. Well, there's still time.
Yeah, well, yeah, the day's still young. Okay, so I did star some questions, and I've also got some links as well. So one person was, I'm just going to see if I can pronounce this properly, Orchard, let me see, Lei, L-E-I, I'm guessing that's how you pronounce it. They're just saying it's an example of how to start encryption for someone like me who has zero exposure. A couple of people had sort of said, oh, you know, oh, there's much more advanced encryption and all this kind of thing. But I just thought you'd like to know that someone actually said, well, this is aimed at, you know, the first steps. Would you have a comment on that, do you think?
Yeah, I think it's a good place to start. I was a bit torn whether I should delve into something that's quite ancient, or whether I should do something a bit more modern like public key encryption. But then I had to first lay a foundation in a proper foundation in modular arithmetic as well as prime numbers. So I was scared that I might lose some of the audience if I do that. So I just thought maybe just keep it first principles and just show how it's done. The kids in my class seem to enjoy that quite a lot. And what's nice about this is that you can build your own letter arrangements and things as well. So you can do whatever you want. It doesn't have to follow from A to Z.
Yeah, and in fact, in our private studio chat that we have down here, ticking away, you did mention that you start with console apps and teach the students with console apps, and then kind of expand out from there. So I think it's kind of like baby steps. Is that what you're saying?
Yeah, it works. For me, it works really well, because if kids are new to programming, then there's two things that they have to deal with. One is they have to deal with the IDE, and they have to deal with a language they've never seen before. So I've just kind of removed the IDE somewhat out of the equation and just focus on the language for the start. And then later on, I start introducing the VCL application. That's worked pretty well for me so far. So I'll keep doing that. If it
Yeah,
were up to me, I would just code in console all the time.
Yeah, I think you're absolutely right. I think, take away the where is the part of the menu I need to click on, where's this, where's that. I think it's a very sound practice. Not everybody does that, and I think yeah, I kind of tend to agree with you. Make the language stick a little bit first, and then introduce some complications with the user interface and the
Yeah, and
IDE.
especially for the kids. Yeah, and especially for the kids as well. They go in there, they just have these visions of being a hacker, and now what looks more hacker than working on console?
Yeah, I have one of those masks behind me. Normally when I do webinars, I have a background with a shelf full of interesting things. And one of them is one of those anonymous masks. And I always put it up there. I hasten to add, I'm nothing to do with that. But I just do it because kids love it. And guaranteed, every time I do a webinar, someone goes, "You're a member of Anonymous." And they think I'm something. No, I'm not. I'm a commercial programmer. And that's how it works. Okay, so I thought I'd also just talk a little bit about some extra steps. I don't think you've got another session that kind of builds on this. Is that right? This is your only session?
No, I only had this one session. I think if I had another session, I probably would have looked at public key encryption.
Yeah.
But yeah,
Okay.
even getting this one done was time consuming.
Yeah. Oh yeah. No, I mean, the thing is, we're trying to compact everything into quite small edible chunks. And really, some of these things like encryption, you could spend forever talking about them. If I just share my screen, if you are using RAD Studio itself, the main RAD Studio, it also works with the Community Edition as well. If you go to Tools, and then there's a thing that says Get It Packet Manager, which is just highlighted there at the moment. What will happen is a little window will pop up on here, and hopefully it won't do anything weird when I'm streaming. And there's all sorts of components and libraries and things like that in there. One of those libraries that comes up, you can type in the word encryption or hash or things like that, and it will show you all sorts of libraries that are available, ready written. The other thing that you can look for is a product called Lockbox. This is now, I believe, open source, Mozilla public license. That goes into a lot more depth. And I just want to emphasize that Vota's demonstration is, as he said, it's the beginning steps of encryption. And particularly you were showing Caesar ciphers and stuff like that, which is really, the foundation of the principles of ciphers. Lockbox goes into a lot more, like crazy things like blowfish and hashing algorithms and stuff like that, because once you get into public and private key and all the rest of it, it's better to use somebody else's code than write it yourself. I think, is it?
Yeah, definitely.
Yeah, I mean, I can't do it. I'm sure. There are far better people out there. That's all they do. They stay in darkened rooms and not allowed outside in the sunlight, and all they do is write encryption algorithms. So it's
just math. It's all just math.
Yeah. I have Delphi to do all that for me. I don't. Oh no, I don't. Need to do that. So I don't go down that path. So that's one thing. And there are quite a few encryption libraries that are sort of ready baked and ready to go. There is also a hashing library, system.hash, which is built into the Delphi language. Again, explaining what a hash does is kind of related to encryption. What a hash does is if you hash a file or a memory object, it will give you a number that says, a unique number that represents that file's hashing. I'm not doing a very good way of explaining.
No, that's perfect. It's perfect. Yeah, that's a perfect explanation.
If you then go and try and edit that file and change a couple of lines in it, or let's say it's your last will and testament. If someone's got the hash and they can hash your last will and testament, if someone changes that to say, oh, he's going to leave everything to me, and the hash doesn't match, then someone will know that your last will and testament has been edited, for example. Same with house transactions and stuff like that. So it's kind of what it's used for. it's related to encryption, but I just want people to understand that hash is not an encryption algorithm. It is just a way of saying that something that has or has not been changed. Whereas an encryption algorithm is really preventing people reading what you don't want them to read in the first place. And you did an excellent job, I thought, of explaining that. Let me just check that we're doing good for times. So what was the other thing? Senior Tech, who's one of our frequent flyers, shall we say, has been with us most of the week. Asked if they're built-in functions in Delphi to do that. I've kind of just answered that really. Yes, there are some. James, I think this is one for you really, although they spelt encryption with the Egyptian craziness spelling, encryption. But what would your comment be on positional encryption really, on what you showed in terms of should they use that to secure their I don't know, their
Definitely no. That's just basically, that's the type of encryption you would use maybe if you don't want your parents to figure out what messages you're sending, but that's not something for
like
public communication. Yeah, definitely. No. For public and private key and hashing, then I would definitely use the built-in functions for that. It's just going to take forever to write all of that up, but yeah, it's not something that it's not secure in the sense that you can use it for a website or something like that. Definitely not. Yeah. It's easy. In fact, there are algorithms to quickly, I mean, you can just run through every key from 1 to 25 just using a loop, and then eventually you'll find something that you'll be able to read. So yeah, it's not going to work so well.
Yeah, and in fact, that's called brute forcing, and it is one of the principles that was used originally on the Enigma Cipher as well. I actually used to live in Bletchley, so I've been to Bletchley Park many times, and Alan Turing's office. I like to go and get my picture taken outside it. And
oh wow,
it's very cool. Yeah, but I actually nearly rented an office next to his old office. But there you go. There's a bit of history. But yeah, I mean that encryption by you know, the Enigma cipher was far more complex, but actually even the techniques involved there were not actually that far different from what you showed. It's still the principle of rotating letters around just exactly as you showed there. Much more complicated, obviously, because it was wartime, the Germans and they
use machines.
Yeah, they use some very complicated machines, but there's still the principles. You press a letter on the typewriter of the Enigma, and it did some shuffling around, and then out came a letter that had been shifted by so many characters. So the basic principles of what you showed was actually then built upon with some very complicated wiring and rotors and stuff like that. But really, the principle was still the same. It's just that every time, every letter was shifted by a different amount, and you didn't know what it was unless you knew the key of the day. But and that was broken by maths. Actually, you know, mathematics really helped break that as well. So don't rely on the Caesar cipher to protect anything valuable like your bank details, and expect it to be safe on the internet because nothing's safe. And actually, of course, you know, nowadays the supercomputers and the trend towards you know, these very, very powerful parallel computers, lots of encryption is broken.
And quantum and quantum computers coming out as well. So
yeah, which break it in milliseconds compared to years, which is extremely concerning. I mean, the argument there is that eventually the encryption will be completely useless, and somebody will have to come up with a different way of transmitting private information, because you'll just have to assume that if it's encrypted, it's breakable. So there are quantum communications that they're looking at and stuff like that. But that's way beyond the coding boot camp, I think. Yeah. Excellent. Well, look, you know, a lot of positive comments about the stuff that you said. I did promise also on the, hang on. Yeah, I need to do that. I did promise to the people that I would, let me just see, post this as well. If you are a Slack user, then I definitely recommend this Slack group. It's run by another MVP. I'm an Embarcadero MVP myself. And it was Cockney was the first widely used encryption, said someone. Cockney rhyming slang. But this group is run by an MVP, very talented MVP, but there are lots and lots of Delphi programmers in there. So if you do use Slack, I definitely recommend to go to this. If you're watching this recording of this and it's more than 30 days, then the link will actually expire. That's just the way Slack works. But if you're within 30 days of the broadcast, then use this link and get on there and chat with other people, the Delphi people. Excellent. Okay, any final words from you? Walter? Is that, am I saying right?
It's voted, but
Vote,
yeah, it's
there
fine.
you go.
Yeah, it's a very Dutch name, but thank you so much, Ian. You've been a wonderful host.
Yeah, well,
there's nothing else I want to add.
all I do is just stand here and talk for, or sit here, should I say, and talk. So you guys do all the hard work, and yet again, the quality of everybody we've had on. I know your colleagues with some of the other demonstrators and teachers. It's been absolutely brilliant. A lot of positive feedback, and a lot of people saying thank you. So excellent. Okay, well. Thanks a lot, and I'm now going to talk about the next one, which is the next session is called Working with Colors and Pictures, and that is I should have asked Walter how to say this, but it's Heimo Jeski, and it's called Working with Colors and Pictures, and it's going to start now. I'll speak to you later.
Welcome to the Coding Bootcamp 2022 22nd August, especially for the Delphi interested programmers. So today we'll be working with colors and pictures, and that specific series called then Core 18, and that can be found on GitHub with all the source code that is explained and demonstrated here. Let's get started. One or two words for the presenter. The presenter is Heimo Jeski, it's myself, lecturer at Tshwane University of Technology. I'm Delphi user since 1995. Specializations are like technical and engineers programming, and especially in Delphi, C++, and C#. On the communal side, I am engaged in Delphi for Schools South Africa and built in the past some computer centers for underprivileged schools in our environment. Concerning products, I did some in-house products as well as some small-scale enterprise applications like LMS for some smaller company, and the USB alert system like for us in-house, or then a code detector for detecting a duplication. Now let's turn to the interest of today. We want to investigate the colors of Delphi House, Delphi then handling the colors, and what can we do with those colors. So most probably you played around with some colors on your Delphi compiler, and you most probably saw that you can select colors through the property list, and there you've got the option, for example, to select from predefined constants like plus minus 52 different colors, then with names typically starting with a CL, like CL Aqua, CL Lime, CL Red. Second option would be like you type in a hexadecimal number starting off with a $00, and then some interesting numbers. We'll try to investigate and analyze those numbers. And the third option is you can actually input a quite big number from small to that big number, but then it's not that easy to relate your number to a specific color. So let's focus then on the hexadecimal input option, and let's investigate a little bit. First of all, we need to put the decimal system alongside the binary system, alongside the hexadecimal system, to get some idea how things are put together and how they're working together. For example, we've got that number here in the decimal system, 234. Now the 10 at the bottom, of course, is then the base of that number. Since we are most of the time making use of that decimal system, we are not actually putting that 10 down, so we just accept all the numbers are in the decimal system. What I'm interested in is the fact that we need to look at place values. For example, the 4 has got like the value of units. So typically we would say 4 times 1 equals 4. The 3, for example, has got the place value of tens. That means we need to multiply it with 10. 3 times 10 gives me 30. And of course the 2 then has got the place value of 100 or hundreds, and that gives me 200. Adding all these up is then 234. Now we typically see that from our right hand side to the left hand side, that place value then is incremented by a multiple of that base value, and that is very important to take note of. So each time we are moving to the next higher place value, we have to multiply by 10, and that is what we need to keep in mind, looking at the different number systems. Now let's put the binary system alongside the decimal system, alongside the hexadecimal system. Typically we're starting all system off with a 0, then we increment to a 1, then we increment to a 2. Now interesting in the binary system, as the term is telling us, by only 2 numbers, only 2 digits available, we already have to move over to the next higher place value, so the 2 has to be expressed as a lots of 0, 1, 0. Right, so likewise we need to go further and further down the line, and we're getting bigger and bigger numbers. Now interesting in the hexadecimal system, as the word is telling us hexa, deci, it's 16 system. So it's actually looking forward to make use of 16 different symbols before it switches over to the next higher place value. Now, of course, after the 9, we didn't have a next value, so people just took the A, B, C up to F. Now, counting all these different symbols, you'll get up to 16 different symbols starting from the 0. That is important to notice. So they've got all the different systems with different base values. Right, now let's go in more detail. If we fill up on the binary system the last 4 all with 1s, we were actually then completing half a byte. And of course, a full byte would then make use of all 8 digits. Now, half a byte then is equal to a single completed hexadecimal number, whereas a full byte then makes use of 2 decimal symbols, numbers, whatever you want to call it. Same time as we're looking at a full byte in the decimal system, we can think of having 16 times 16, and that adds up then to 256 different numbers or possibilities to differentiate between. If we're talking range, we're talking starting from 0 up to 255, which is the last one. That is important to notice. So let's keep in mind, 1 single byte in binary system, 8 bits. In decimal notation, 0 up to 255. And in the hexadecimal system, we're going from 00 up to FF, which is then the highest notation in terms of hexadecimal notation describing a single byte. Now let's translate that type of information we just looked at in the decimal system into the hexadecimal system, and that is important to notice. So we also have place values, but these place values are of course a multiple of 16. So for the lowest or the unit value, I have to multiply with 16 to the power of 0, which is equal to 1. So 10 times 1 gives me 10. Next place value is 5. So I have to multiply 5 with the multiple of 16. So that is 16 to the power of 1. So 5 times 16 gives me 80. And the 2 right in front then, of course, is times 16 to the power of 2, which gives me then 512. And again, we've got the place value here. You could have written a 16 at the bottom, or some people just put an H to indicate it's the base of 16. Now turning that over into more foundational knowledge concerning numbers, we need this background knowledge. We can see that one single pixel then is made up from a blue channel or a primary blue color, from a green channel or a primary green color, and then the third one is red. So mixing blue and green and red in different strengths or weights, we get these specific beautiful colors. So each primary color, and we call the blue one the primary color, green is another primary color, red the third one, is then presented on one single byte. So we've got like 1 byte for blue, 1 byte for green, 1 byte for red. That brings us to the fact that we can have like from 0 up to 255 indicating the strength of that specific channel. Now back to Delphi's property color, we saw earlier that we can actually accept color indications in 3 different ways. Predefined constants, starting with a CL, then just a number, that is actually close to the maximum number, goes up to 16 million something, and then the hexadecimal notation. Now for this time, the leading zeros were actually taken out. To quickly calculate the maximum number of colors then we actually can display, we can remind ourselves it's 3 byte, which is then 3 times 8 bit, or then turned around, and bits is 3 times 8 is 24 different bits. And that gives us the same value as 256 to the power of 3. And in terms of a decimal number, we would get like 16,777,216 different colors, which is of course a lot. Now let's have a look if we go the reverse route. That means we've got one of these big huge numbers and we want to find out actually what type of color do we have got in front of us. Here's one example, 247,820. You wouldn't easily could tell what type of color we've got right in front of us. Now that means we need to start off and kick off with the highest bit value, which is then the blue part. And the blue part then of course, think back to the place value, has got the place value of 256 to the power of 2. Now trying to divide this into each other, we would guess plus minus something like 3 and some additional. So having the reverse calculation, 3 times 256 to the power of 2 gives us that big number which needs to be subtracted. From somewhere in primary school we know these type of calculations. Now of course that 3 now is the weight for blue inside this color. Now let's move on and let's calculate the next color, which is then the green color. So the next place value, next lower place value, then is 256 to the power of 1. Now trying to divide that into the big number of 51,000 gives us round about 200 and something. Now doing the double and the reverse calculation again, multiply it, and you will see it was fitting like 200 times, and that of course means we've got a weight for green of 200 units compared to the maximum possible of 255. So that's a very strong weight of green. That means most probably that color will come out quite strong green if the red is not too strong. Now what's left over is just a 12, and of course 256 to the power of 0 gives us 1. 12 divided by 1 gives us 12, and that is then the weight for red. So to carry that over to our demonstration on the right hand side, you can clearly see we've got a huge weight of 200 for the green part. We've got a small weight like 12 for the red part and a very small weight on the blue side. And we can just for repetition mention that the most significant byte then is the blue one. That needs to be multiplied with a place value of 256 to the power of 2. And then on the right hand side we've got the least significant byte, which is then the red part. Mixing all these nice colors together, we'll get the resulting color of a fresh green 24-bit color. And that is important to notice. It's a 24-bit color. 8-bit for the blue, 8-bit for the green, and 8-bit for the red. Now, if you need to know more about the background of color definitions in Delphi, you can also consult Dr. Kevin Bond's book, beautiful written, very nice background information. And as I read up, it is available from Amazon.com. There's the title. It's published in the UK. There's an ISBN number and so on. And I am specifically then extracting some knowledge from chapter 37. Right, that brings us to the first part of background information. And we had a brief look at how Delphi defines colors. Now we need to take the next step. What do you want to do with it? And how will we actually apply it to some nice application? Now, just for demonstrational purposes, I built a small application in Delphi, of course, to demonstrate actually the co-working of the blue channel, the green channel, and the red channel. So, as we touch actually those buttons, which are trackbars, and you can see they're indicated from 00 hexadecimal notation up to FF, highest possible weight or number for that channel, or then in decimal notation from 0 up to 255. So as I'm pulling down my lever here for the blue channel, I'm of course making my blue channel stronger and stronger, and you can see how that blue is actually then changing. Same for the red. Then you can see right on top we have got 3 different number indications, the blue, green, red, each one on its own as a decimal number, and then multiply it to each other. As you can see, if I'm putting in some blue weight, how fast that added up, multiplied up number then is increasing. Then on the bottom side here, we've got these channels separated as 3 groups of hexadecimal numbers. And that's the one we want to use, because to relate from that hexadecimal number to the color, it's quite nice and easy to do. Then on top of all this, I had some additional buttons at the bottom here. I can keep, for example, a number. So it's blended in right here, and I can do slight changes. For example, I can change the red a little bit or to that side a little bit. And you can see slight deviations coming in, or then the green channel more. So you can play around with this. What counts on a later stage is I would love to change the last number from the decimal triplet here and see how it's actually influencing then the color in total, or that specific pixel. We'll come to that detail. Right, that should be sufficient for first. On the left hand side you can also blend in another color if you want to have some additional comparison. Let's stop it here and let's dive into some more detail concerning the color manipulation. Now let's move on with our investigation and coming to some good Delphi code. We are still busy with series core 18. So we want to make use of some real good Delphi coding then to hide some information, simple information inside an image and retrieve it on a later stage again. So let's assume there was a beautiful image like that one. And we got some nice information. We just kept it easy and straightforward to keep the program easy and straightforward. And we used only normal text. And this image then swallowed all the information and nobody recognized any change. There was no change recognizable. Then, after some coding from Delphi again, we could extract all the information right out of this picture or then image again to reproduce the original text. That would be a lovely dream. To actually do this, we need to zoom in a little bit and make it visual how Delphi then could make use of those pixels. So let's assume we've got a beautiful Delphi picture here. We are zooming into a small part inside that bitmap image, enlarge that part, and select one of these small pixels down here. And let's investigate that pixel. How is it built up and what can we possibly do with it? Now, as we know from the past, it is made up from a blue, green, and red channel. The blue channel then is the higher order value, should be multiplied with 256, 256, and so on. Putting all this together, we get the hexadecimal number like a 89, a 5C, and a BF. You can instantly see the 5C is lower in value, the BF is higher in value. To take notice of, and that is very important, one single pixel then is built up from 3 different bytes of data, which we then call 224-bit color bitmap. Now let's see. Before we can go on, we must have some double checks whether we are in line with these prerequisites. So number one, the text may contain ASCII values only. I took that as a first example. We can do some more complicated in a follow-up session. But ASCII values, that means straightforward, simple text. Next, the image has to be a bitmap, a BMP, because of a good reason of 24-bit color depth. The bitmap image has to be defined as a 24-bit color depth because of the 3 byte. And then the last one, the bitmap image has to be 3 times larger than the text. Most probably that is already clear why. Otherwise it will become clear on a later stage. If all these items are in place, let's proceed. So for example, we could look at this piece of text. I just took some nice beautiful text from NASA. And we like to extract, starting from the left-hand side, all these different letters and start merging them into a bitmap. Now, what is the logic and what is the theory behind it? Let's start with the N. So we take the N and translate that N into its relevant ASCII value, which would be like 078. You can look it up yourself inside the ASCII table. Then on the other hand side, let's zoom into maybe the first pixel inside the bitmap image. It could have a blue value of 137, for example, for the first byte, most significant byte. It could have a value of 092 for the green part and a 191 for the red part. Now the theory behind this is the following. Each digit from N, from above, will now override the last digit from each color channel. So we take that 0, we start overwriting the 7 to get a new value for the blue channel, which is 130. We'll do the same for the green channel. We're overwriting the 2 and it will become the 7 from the N. So our new weight number now is 97, and the same for the red. So the 1 was replaced by the 8. Great. Having all that in mind, we of course would be interested now, how did that color actually change? Does it ever change? And here's a bit of a test for you. You can compare that color to that color and you would hardly see any difference. Now the color difference is put more closer or more blown up on the right hand side, and you can see there is a slight color difference. But if that is only applied to a single pixel, you'll hardly see any differences. Now to translate that into some good coding, so I need to pre-discuss some of these helper functions, otherwise things are getting too complicated later. So here's one of them. So we'd love to make use of that self-defined method or then function. I just called it change pix. And I'm having one color pixel, I call it input color, that one on top here, to be manipulated. So that's one of my inputs. Then I've got further 3 inputs, and of course these 3 numbers are coming then from the N, which we just had a talk through. Is 0, 7, 8. Now these 3 digits are then passed over into that function, and something magically happens inside the function, as we just saw it in the diagram. Always the last digit will be overwritten, and no actual change will happen to that pixel. After all that is done, then that particular pixel will be returned as a manipulated pixel, and the coding could look something like this. So there is the header right on top again, as we saw it earlier. Now here is typically the Delphi method get B value. That means get me the blue channel's value based on a decimal number from that pixel. So I'm getting the weight from the blue channel, and I'll capture it right here. I'm getting a similar weight for a green and a similar value for the red part. Now, having all these available, we can now do the changes as we anticipated in the past. So let's calculate through one of these. For example, the blue value from upstairs here, I can then integer divided by 10. For example, I'm having a 137 for the blue value. I'm dividing that by 10 integer division, and I'm getting out of this a 13. Now, of course, the 13 needs to be multiplied with a 10 again, so I'm getting a number of 130. Now, I just need to add in the 100 value, which was passed over here through my parameter list. And at this instance, for the example n, which was 0, nothing changes actually. So I'm having a final number of 130 for the blue channel, for the manipulated blue channel. But of course, that 0 still changed from the 7. So there is a change in the last digit. Likewise, we can do that to the green part and to the red part. And all of these will have changed as we demonstrated it on the previous slide. Now, in case I had a pixel that came in with a 254, for example, and I'm adding in a 7 or an 8, for example, it's of course going beyond the 255. Now, that would be a real big change for the color, because now we've got an overflow inside a single byte. So it'll go from 255, it can't go bigger than 256, so it'll start from 01 again. But the 255 is close to white if we put all channels to full power, and the 000 is close to black, so that's a sharp contrast. So to rectify this problem, we just decided to minus a 10, which brings us back into the range we should be. Having all these in place, all 3 different channels with new values, adapted values based on the ASCII character, we put it together and we call up the function, the Delphi function RGB. Now you will be surprised it's the other way around, but it stands for red, green, blue transformation. It's expecting 3 different bytes. You can see they are sent here as bytes. And out of this we get the resulting T color object, which is sent back as a result of a function call. Great. Having all this in place, we can go over to the opposite side if we want to demerge again. That means we want to extract an ASCII character from a bitmap pixel. Then we would actually go the opposite route. So, for example, we would run through all coded pixels and extract the last digit from each color channel. So that could be visualized as follows. Remember the N we had, so we had the 0 and the 7 and the 8 here. Now we need to take these numbers together again. Then that means actually we're extracting the last digit from each and every channel to come up with a number of 078. That is of course a sequence number inside the ASCII table, which can be then translated into the simple 8. And likewise, we could go for the second character, the third character, and we would make up the text again. Great. So in coding, that could look something like this. Let's call that function like character from pixel. So we are getting returned a character from a pixel, and it's very important that we talk like ANSI characters, since we are talking ASCII symbols, ASCII characters. Otherwise we would run into the problem of talking Unicode, which makes the whole process more difficult. Now I just mentioned here it receives 1 pixel as a T color, that is my input pixel, and it returns then a single character. Now the first few lines we know already, and coming to the next few lines here, we're extracting the information from the last digit each time. So we just take the blue value of the weight of the blue part. We say modulo 10, what is left over if we divide it by 10, and we're getting the remainder then for the hundreds, for the tens, and for the singles or the units. Multiplying the hundreds with 100 to get the place value in its correct position, the tens with a 10, and the singles we just leave them as they are. Putting all this together, typecasting it as an ANSI character, we're getting our result to be sent back. Fantastic. Now to have some concluding ideas, data merged into a bitmap, and to just summarize 1 or 2 points and point out some more points, we did like change the last digit from the decimal numbers for all 3 channels, typically resulting in something like that. Then I put down the original image like it came up inside the demonstration, as we'll see in a moment, and then the image again with merged data inside it. You can hardly see any differences between these two. And I took this light shaded and soft shaded red part because that would be the easiest to actually spot the differences. So about no change can be recognized comparing the 2 bitmaps, even though there's sitting information inside here. The bitmap cannot be reversed to its original anymore. That means if we've got once merged some information inside that bitmap, we can never return it to the original. And then if you like to, you can change the coding that's coming right now. Minimal changes will enable you then to encrypt data in the bitmap, encrypt data, save any data like a Word document, an Excel document, or any type, and then also include Unicode. Of course, you need to brainstorm a little bit. That brings us then to the theory, to the end of the theory part. Let's go on with the coding for sharing some good Delphi color pixel merging. Now let's turn back to Delphi and let's kick off with a demonstration of that application. So we're loading a picture first. It must be a bitmap as we heard it. Now I've got several bitmaps like here and available on GitHub. Let's just select that reddish scaling self-made picture again. We are getting some summary information on the right hand side, which is important. So there's a file size, 3 million, so that's roughly like 3 megabyte. The width of that, the height and the pixel size, so many pixels, so that's about the maximum of characters we could merge in. It's a bit count of 24-bit. That is marvelous. So that is what we are looking for. The next step would be like we're loading some text to be merged into that image, which is a bitmap image. So I took this mass type of documentation I scanned from the internet, and we can see it has got some 105,000 characters plus minus. So they're a little bit different counts because we are adding some additional characters. Then third step is we are merging it together. So here goes our merging process. Process finished. Now all that text is sitting right inside that bitmap, and we are saving that new picture. Swapping over to the next tab sheet, then we can reload that merged picture. So there is my copy of that one. Then we start to decode again this information, and here comes all my data. You see those numbers flying as the characters are extracted, and then of course we can save it again. Great and beautiful. Let's have a look how that coding is coming about and how Delphi is working with it. First of all, we need to state somehow a maximum number of characters, and I just call it like the max doc, which is 20 million, so that's roughly like 20 megabyte. Then of course we are making a new data type up here, big array, so it's an array going from 1 to that big number here of NC string, NC character. That is very important, to take NC character and not just character. Now we've got all the different components sitting on the form, and then we have got some class data members here. We'll come to them as we go by. Then the helper classes are stated here, the prototypes, and let's quickly then move through all these different items. So displays bitmap parameters, width, height, and so on. I got this one, if I'm not mistaken, from the Tories web page. Some time ago. I couldn't find it anymore again, but most probably it's also provided by some other web pages, how to extract then the information of a bitmap concerning size, pixel size, 24-bit, and so on. I'll not go into too much detail of that one. You can retype it or you can download it yourself if we find it on another web page. Now coming to the first helper class, we talked through that first helper class. Let me just stretch it a bit here, then we can see a little bit more. There's my first helper class, change pixel. So it's receiving an input color or pixel then. It's receiving the hundreds and the tens and the units from the to be merged character. And we had a nice look at the functioning of that helper class. This one we didn't have a look at, but it's just simply splitting up a character like the N into its different hundreds and tens and single units to be merged then on a later stage. So typically we can see we are dividing by 10, and then we're taking the modulo of 10 to get down to these numbers. Right, next one is then another helper class, or that's just straightforward reading in the information. It has got a default name here, like the reddish bitmap, but of course you can override it through selecting another file name through the open dialog. Now having all that in place, we have to test whether it's a bit count equal to 24. If it's not, we actually need to make the user attending to this. Here we go. the active way, the button load. So we are actually now actively loading that. We are testing for the size, and the size is displayed here. We're closing down again. Assign file is not so much used anymore these days. I think it's an older way of talking to the files. Very practical for me. But I believe file streaming is also taking over those functionalities. So here is then the double checking. So the file size may not exceed 1/3 of the bitmap file size. If that is the case, we need to push out a message and we need to exit the application because it will not be able to merge it. Now, if the application is not exiting here, we can move on. We can do some nice calculations, especially around about the capacity. Now that is actually redundant. I can take it out again. I just had it in to slow down the process and have a look what's really going on. So for my purposes, I found it easy and very practical to have a specific symbol then put at the end of each line. So there's my line marker. We could call it not a bottom line, but a top line, because it's actually never used. I used it then as an end of line marker. Likewise, I've got an end of file marker to be very explicit. So it's twice these little funny symbols here. If you want to look it up, in my ASCII table, it was like the sequence number 164. But any other odd character would do. Now let's just take that one out too. We don't need this one anymore. Let's move on with the button merge. That means the merge process. That is the most critical part. So there are lots of temporary variables here. We need to go back to the file size. We've got a bit of a progress bar indicating how far we are with the merging process. And what we actually do now, as you can see it here from the central part, this outer while loop then is running through line by line. That means it takes the first line and then starts a merging process, and then it walks from left to right horizontally, pixel by pixel by pixel. And each time it's calling up our helper function find character details. So there's my character, like the character N. It's split up into hundreds and tens and unit values, which are then later on used downstream here. Let me first go line by line. So if the merging process is still valid, we are double checking whether we are not reaching actually the end of file markers, which were explicitly added in. If that is not the case, we can translate the next pixel. That means we are calling up our helper function change pixel. We are sending down the original pixel, which we refer to by, that is our bitmap. We are referring down to the canvas, and from the canvas we are picking on a specific pixel, which is then identified by its W and the H, which is then, the H is from top to bottom, and the W then is from left to right, like the width. And based on that specific XY coordinate we could think of, we are then picking a specific pixel, which is then changed according to these three numbers. Now these three numbers, as we saw it earlier, are then overwriting the last digit of each one of those color channels, and the result, since the function, the result is then put into that pixel, which is then overwriting the very same pixel. Then we increment to the next byte inside the text file with that incrementation, and we increment to the next pixel with that increment W. Right, so that is then doing the merging process. Now some nice nitty-gritties here, just updating the progress bar and updating the percentages, how far we are. And then of course, as we hit the end, we have to state we are done like 100%. Sometimes it ends like 99.8% or something, that line. Right, then we of course have got the opportunity to save that image, so we can look it up inside a new file. We just added the bottom line new BMP, not to overwrite the previous one. And we start off with the second tab sheet then, where we have got another helper class, which is then extracting again the character from a particular pixel. So there's my pixel sent down here as a parameter, and running through all this, which we had a look at during the slideshow, returning an NC character. Now let's see, here's my button decode click, some temporary variables again. We first try to, yes, what is happening here? Yes, we're going through the memo box, and then we are calling up the picture, and we try to investigate the width -1 since we're starting with a 0, and we put that into the variable of pixel per scan. Scan meaning like one line at a time. Having that one line at a time, we can then run through this second inner while loop here. So while the demerging is still active and valid, and my particular pixel is not yet exceeding my pixel per scan, that means the amount or the number of pixels per line, we need to then engage into doing the following. We're extracting a character from a particular pixel. So there is my pixel. I'm extracting that character. I'm putting it right into character X. And character X is defined as an NC character, very important. Now that character X, of course, need to be tested against the end of file, or then if that is not the case, it need to be tested against the end of line. If it's the end of line, we need to take that gathered information. That means we add it into that line one character at a time, as we see it downstream here, and then take that whole new line and empty it again, so we can fill it up with the next new extracted sequence of characters. Then of course we've got some incrementation here for different values, and we're coming to the end. Now then of course we have got the button load, that is just to reload the merged or character merged picture, and then the button save if we want to save it with a new type of predefined label. I think it was actually spelled out here inside the edit box, so we could take this name. Now that brings us roundabout to the end of that session. Thank you for listening to that interesting conversion or the merging of ASCII text into a bitmap and retrieving it again. Thank you. Bye-bye.
Well, hello everyone. That was not the session I thought it was going to be, I have to say. That was Hemal Heski, or just and actually I notice he's around as well, so he can correct me on the spelling and pronunciation of his name. Great session. I actually thought it was just going to be about colors, and actually in a way it followed on from the previous session about keeping secrets with encryption from Volta. So that was really great. And the good news is Hemal is joining us now live for live Q&A. Hello, Hemal.
Good evening. How we doing?
Oh, your microphone's a bit crackly. If you've got something covering it, you probably need to move it away a little bit.
Okay.
Yeah. Yeah, still a little bit crackly. Not quite sure what's going on. Move it away from some speakers or something if it's near there. Anyway, I just wanted to say great session, absolutely brilliant. Very, very interesting. And actually, I didn't expect you to be going down the route that you did, because actually, in a way, what you showed with the colors, where you were using steganography, which is obviously the proper title for what you're doing, was really a really good demo of colors. I'm absolutely impressed. And if people are wondering what that is, I'll just share this screen for a second. So this is a Wikipedia page about steganography. Steganography is the thing that you were showing where people encrypt text into images. It's actually been around since the Greek times, I think, or something like that. But it's a very interesting technique. So let me just cover a couple of things. So Sylvain Bouillon, I think would be the right way to pronounce that name. I'll just get that to come up. He or she mentioned that, I'm guessing it's a he, mentioned that they use it a similar way to include an SVG inside a bitmap, which I think is slightly worryingly overcomplicated. I would probably do it in a different way, and you can actually use PDFs as well and things like that. But yeah, I mean, is there anything that comes to mind for you in terms of colors? Was there something that you felt you didn't cover in the video, or that you felt you could have maybe explained in a different way? I thought it was great. I didn't have a problem with it at all.
I think I put too much information inside, but still it's an interesting idea, so I just wanted to share it. A person could have made it like just simpler and easier and maybe spread it over 1 or 2 sessions.
Yeah, and I think that's the thing that you know, the good thing about you guys who are professional educators, which I think you are yourself, you have this way of imparting the information in a way that actually makes a lot of sense to other people, and I think that it took me by surprise. I was there, I was merrily doing something else, going, oh well, it's colors. I think I probably need to focus. But not.
Yeah, to tell you the truth, originally there was some comments from some people where that shouldn't be like part of the encryption theme. And I had it previously demonstrated under encryption was 2, but since I simplified it so much, I took out the whole encryption idea and I just thought call it merging it with stuff.
Yeah, I'll just paraphrase what you're saying because your microphone's still a bit crackly. I'm not quite sure why. It's probably the NSA. They've realised that you're teaching people about how to hide secrets in images, and so they're trying to block you from giving out any more information to the world's spies around the world. And James Bond is sitting there working out what's happening. So there you go. You sound clearer. Say hi or something like that.
Okay, I just swapped. I've got several microphones, so I took another one. Yep.
There you go. See, now you're as clear as a bell. In fact, you're probably clear.
Okay, great.
Yeah,
thanks.
Excellent. Yeah, I mean, steganography is a very interesting subject, but I think it also, you know, what you did there was demonstrate quite well how to handle colors as a result. So, you know, well done on that demo. That was a really cracking demo. So just to carry on from what Sylvain said. I do it by overwriting completely the first pixels. No, excuse me. I'll say something as well that I've worked in a few companies where home rolled encryption was quite important, weirdly enough. And one of those in particular used to do things to video files, which would embed information in the video files as a form of encryption as well, because what they didn't want, they didn't want someone to be able to download a driver from the internet that would work it out. But essentially, it was doing almost what you were doing, but on multiple frames of a movie or something like that. So, yeah, you know, I mean, anybody watching what you did, that is the foundation for some real stuff out there, out on the internet. You know, it's good stuff.
Yeah. I just see at the bottom another person did the same thing, but just increasing the size of the bitmap. That was just one of my goals, to not increase and not change the size of the bitmap. So you actually can't see that there's any change for a normal person looking at the picture. though you've got some valuable information sitting right inside the picture. Yep.
Yeah, exactly. And I think also as well, really the best form of encryption or you know, secrecy is to make it so that people don't realize it's happening at all. And as soon as you start changing the size of the files, then people are going to go, wait a minute. Of course, the slight flaw in your plan is that most antivirus programs would start panicking about you encrypting data in files, and we're probably breeding a whole new set of virus writers, but they're not going to succeed, you see, because that technique is not going to get past most things like Malwarebytes and stuff like that. How did you come into this sort of intro? What made you think of steganography? Because I'm really impressed at how novel an idea that is for showing color management.
Yeah, sorry, I don't know the term that you're mentioning. I just thought of a nice idea. I just thought of a nice idea to entertain kids on the one hand side, students on the other hand side, to keep them busy with an interesting type of theme, and that's what came about.
Yeah, well, you know what? The thing is, I think if you're a sufficiently smart person, which you clearly are, sooner or later, when you come up with a novel idea, you may find that someone else who's smart has also come up with the same idea, because it happens. I think I've done something amazing, and then someone goes, "Oh yes, well, you know, it's been done before." It happened to me recently.
Yeah, I didn't do the effort to actually look up and do some research. What type of encryptions do get in pictures? I just did it on full stop, just to enjoy myself.
Well, do you know what? I have to say, you absolutely hit the nail on the head. The solution that you came up with is actually one that's used for certain types of people don't realize it, but sometimes license strings are stored in bitmaps that otherwise look normal and things like that. So it is actually used, and as I said, I mean, you know, you didn't realize, and that's fine, but steganography is the actual term for it. Yes. But okay. That's Wikipedia for you. You know, they're everywhere, and you did a great job. It was just a genius. I think it was a genius solution for teaching people colors. I was blown away. I honestly thought you were going to say, here's how green works and here's how red works and stuff like that. But no, you did something completely novel, and it followed on nicely from the encryption as well. So well done. I just have a couple of things that I need to just plug for a second, because I don't think we've got any other specific questions about colors. There are things like device-independent bitmaps and stuff like that that do complicate the idea of storing text in images. So if somebody wants to go and do that in practice, then you pick your images carefully, I think is the answer.
Since that code is really a little bit more complex, it is on GitHub, so people can download it. And even that in-between demonstration I put there, very nice to actually match up colors and even use them in web pages. They can download it. The full source is there. It's actually not long code.
Okay, well that's great. I mean, we'll make sure that we get those links to GitHub up, because the whole point of this code camp this week is to make sure that people are picking up on the basic techniques, but also if we've got longer examples like that, that's great. If you want to message us when we're done, we'll make sure that oh there you go. Someone has actually just posted in the I'm not sure which person did that, but someone's saying there's a learndelphi.org GitHub repository, so we'll probably put it in there. Is that what they're saying? I'm just
it should be in there now.
There you go. It should be in there now. So I didn't know about that. That's news to me. Hooray! Okay. Well, look, how is it you pronounce your name again? Because I didn't quite catch it.
A little bit difficult. Heimo. Heimo is the first one, and Jeske in German, Jeske, but the English people Americans say Jeski. So you're quite right.
Oh, there you go. I said to someone earlier on, when we do another one of these, I'm going to go away and have a language school boot camp for a week so that I can get everybody's names right. I can handle Jim's name. That's not a problem. But there's a few others. It's been a challenge.
Some uncommon names, yep.
Yeah. Well, I just want to thank you for your session. As I said, I think
thanks a lot.
a genius way of explaining colors to people. You did a really good job, and you know, I think that this has been the theme this week, that some of the instructors we've been on, you know, mostly from South Africa and various similar places, have really shown there's some great educators out there who really know how to take that knowledge and dump it into people and really kind of enthuse them in this what I find is most entertaining profession you could possibly do is a software developer. But yeah, you know, they maybe won't do it for a profession, but I still find it very interesting. So, you know, thanks a lot for your help.
Thanks a lot. Thank you.
Okay. So as you can see, Jim is here. And the reason is that Jim has got a session coming up, and just for once, I get to introduce Jim instead of Jim introduced me the other way around. That's funny, isn't it? So Jim's session is going to be about debugging, so finding, fixing, removing bugs. I don't see the bit that says putting bugs in the first place, but that's usually a session that I'm expert at. So.
So putting bugs in the first place, that the process of writing code is putting bugs in.
Yeah, in my case, I'm expert at doing that. So, okay, all right. So I will leave Jim to it, and have fun, everybody. And I think, Jim, you're going to be taking over some hosting after that. Is that right?
Yes, I am.
Okay, all right, no problem. So thanks, everybody, and we'll see you again. I will probably speak to you all again tomorrow at some point.
Yep.
Have fun.
Thank
Over
you.
to Jim.
Thank you, Ian, for hosting. All right, so let me bring up my screen here. This is a 2-hour live session, and reason I did it this way is honestly, debugging is kind of this mystical dark art, I sometimes think. And honestly, even with 2 hours of this, or even if we did this whole boot camp just on debugging, we would not even scratch the surface of doing it effectively. But my idea is that I wanted to do this live, so that, you know, if you have questions, or you're like, oh, how did you do this, or how does that behave this way, or what about this, that you can ask those questions, and I will do my best to answer those as we go along. So let me I have a few slides, and we'll go through those, and then I will hop in the IDE and do some code and some debugging. So you should be seeing the screen now. And yeah, this is debugging, finding, fixing, and removing bugs. And as I was joking with Ian, actually, I was joking, but the reality is every time you are writing code, you are introducing bugs. It's just the nature of it. I've worked at a number of really large companies that had huge code bases, and they have statistics where they monitor. It's like, we have this many lines of code that have been written, and so therefore we know that this many bugs are generated. And until we QA enough time to find those bugs, then they know they need to keep doing QA. So especially like I worked at companies that do like embedded software and firmware and stuff like that, things that are traditionally not able to be patched or updated once the software is once the hardware is released with the software embedded into it. So it's it's an interesting thing though to think about, is that you are, as you are writing code, if you're not specifically fixing a bug, you are introducing bugs. Now, even when you're fixing a bug, you can create bugs too, which would be regressions. But let's go ahead and dive into this. So real quick, if you don't know who I am, I'm the Chief Developer Advocate Engineer for Embarcadero. I've been developing software for a long time. When I was just a wee lad in grade school, grammar school, whatever you want to call it. I don't know what grade it was. My parents got me a Commodore VIC-20, and I'm like, that is what I'm going to do. I'm going to be a programmer. I don't know what a programmer does. but that's what I'm going to do. And I've worked at a few other jobs over the years, but I've done a lot programming most of the time. And when I wasn't doing it as my main vocation, I was doing it for fun. And when I was doing it as my main vocation, I was still doing it for fun. I started out in BASIC, then went Turbo Pascal, loved Turbo Pascal, Delphi, and then actually went out after that, really becoming, I think, a pretty good programmer in Delphi, and learning a lot of other languages as well. And I actually learned to really appreciate most languages. I think all languages have some value, but Delphi is still my favorite. Even when I was working full time doing C#, I would still do Delphi at home. And sometimes when I needed something done quickly, I would do it in Delphi. But there's still times, even now, that I'll use another language for something. My claim to fame, though, is I invented and patented swipe to unlock and pattern unlock back in 2000 when I was working for a hardware company. And the company I was working for licensed it to Samsung, and I completely forgot about that. And then I saw a headline during the Samsung Apple lawsuit saying Apple didn't invent swipe to unlock, Jim McKeith did. And I'm like, whoa, that's my name. So I had to go look, and sure enough, it had a number of patents, and one of the patents was covered drawing geometric shapes to authenticate yourself to a computer. So enough about me. Let's go ahead and start talking about bugs. Where did that thing go? There it is. So we're going to talk about understanding bugs, error messages, assertions, and then some of the other topics that are related to bugs. Kind of one of the natures of debugging is, like I said, is as you're writing code, you're creating bugs, and when you remove bugs, sometimes you're creating bugs. So there's a lot to this, and I think the reality is software is never done. It's just you get to a point where you're done enough. This, like a lot of other sessions, there are chapters in Dr. Bond's book, How to Program Effectively in Delphi. Chapter 9 is on exception handling, and chapter 43 is on debugging. So definitely can check those chapters out for more information. I'll reference a little bit from that, but most of this stuff is going to be supplemental as well. The slides aren't yet, and I'll have the slides and some examples will be up on the GitHub, but they're not there yet. So this is actually kind of interesting. We're going to do a short history of computer bugs, and we can, oops, wrong button. We can discuss that and see what maybe see if you know the origin of computer bugs. So back in 1947s, which it's hard to believe they had computers back then, but they had electromechanical and electromagnetic computers. They used electric relays, mechanical switches, etc. This is before vacuum tubes, which is before transistors, which is before microchips. So quite a while ago, 1947, before my time, they had these computers. This is a picture here of the Mark I, which the Mark II was. Mark I was kind of almost a proof of concept, and the Mark II was a much more substantial computer, and it was huge. It was 23 tons and occupied over 4,000 square feet, or 370 square meters of floor space. To do addition, it was I mean, fundamentally, all computers are calculators, and to do addition, it took 0.125 seconds, or 8 hertz, to do addition, and it took 0.75 seconds to do multiplication. So it was not incredibly fast by today's standards. But the first computer bug, so the Mark II was designed by Grace Hopper. If you don't know who Grace Hopper is, I really recommend you go learn about her. She's amazing. You can find interviews with her. She was on David Letterman, talking to David Letterman. She would carry around a piece of wire to say, this is how long it takes wire or light, or this is 1 second for light to travel this long on a piece of wire. So she would talking to people, and they'd be like, well, why do we need to make things smaller? Well, that's why right there. Every time light has to travel that far, it's going to take a second. I'm probably getting the distances wrong. Anyway, she's amazing. Check her out. She had a clock that ran backwards too, because she said, saying this is the way we always did things is the worst, one of the worst things that you can do. It's a huge mistake. But they found a bug in the Mark II, an actual moth that had gotten into the relay. And I see Jamie just mentioned that in here. Yeah, a bug got in there and caused some misbehavior, and they were going in trying to figure out why the system was misbehaving. There was not a stored program in the Mark II, and so debugging was a hardware thing at that point, and they found this moth that had gotten into a relay and was causing problems. And they put a tape in the logbook. There it is. That's the very first computer bug from September 9th, 1947. So a bug is unexpected or unattended behavior in a program. It might cause an error message. The other thing about it is it may cause exploits. So for example, I've been studying Portuguese with the mobile app on Duolingo. And because I've developing software for so long and working with software, I'm always thinking about corner cases and things where wondering how things would work if you do something. I was like, I wonder, because one of the things you have to do in Duolingo is it will play a clip of audio and then you have to say it back. So you press one button to listen to it, then you press another button to say it, and it listens to what you say and tells you if you're learning the language properly. And so I was like, I wonder. And so I tap the listen button and then immediately tap the play button. And when I do that, the listen button changes back to like it's not tapped anymore. But then if I tap the listen button again, immediately after the play button finishes, then it says, oh, you said it perfectly. And so I tricked it because an unattended behavior was if people were to tap things, users tap things in that order. And essentially I have an exploit. Now, all I'm doing is exploiting, preventing myself from learning Portuguese as well. But that's the point, is that it's not always going to get an error message. It's just going to produce some sort of behavior that unexpected or unintended. Oops. So some sources of bugs, and we'll talk a little bit about this, but it's really, I just want to point out that bugs can come from all sorts of places. They can be errors in code where you type something wrong. For example, off by one errors are a really common source of bugs where you think, oh, I'm counting from 1 to X. So you do a loop from 1 to X, but you should actually be doing it from 0 to X minus 1. Or you do it from 0 to X when you should be going to 0 to X minus 1. Something like that. It's an off by one error. Really common. Another thing is incomplete specifications, which is where you don't think of a situation that should have been in the specification where you're coming up with what the program should do. And then the user does something that you didn't expect, and all of a sudden the program misbehaves. You can have hardware failures, all sorts of hardware failures. If you use a computer much, you know that computers do eventually fail. Interference from other programs, for example. So you have a program, but then if somebody installs a different program, all of a sudden that program can interfere with that program, either unintentionally or intentionally. Sometimes the libraries that you're using, especially with systems that have runtime libraries that are independent of the program. For example, like Java, you could have somebody updates Java or installs a different version of Java or whatever, and then all of a sudden the program can behave differently because the behavior in the library has changed independent of the program itself. It is an advantage of Delphi is that your libraries are compiled into it, so you don't have that risk. But even then, you can have a behavior in the library you're using in, for example, Delphi, that is not behaving in the way you expect it to behave, and that can produce a bug. Improper input. There was a famous quote, Charles Babbage, another fantastic pioneer in the weird world of computer programming, that built this analytical engine, or was building this analytical engine. He didn't actually build, he built the difference engine first, and someone asked him, and the difference engine would calculate these mathematical formulas. And someone asked him, what happens if someone puts in the wrong numbers to begin with? Will it give you the right numbers back? And he's like, no. And this is where the term garbage in, garbage out comes from. That if you put bad input into a program, you're going to get bad input out. You can't, there probably are exceptions. There's always exceptions in ways you can do this. Programming is such a broad thing, but generally speaking, if you get bad data going in, you're not going to get good data out. Yeah, Jamie just pointed out there was a recent article from oh, what's his name? Chan. He wrote the Old New Thing and said that there was a bug back in 2004 where if someone played Janet Jackson's Rhythm Nation, it would cause hard drive, either the hard drive on the laptop that it was playing from or even a hard drive next to it. It had the right resonant frequency like you would for opera singer to sing to cause a glass to break. It would cause the hard drive to crash because they had the little read heads in there. So just the right frequency that it would just cause them to cause problems. And actually, there are other cases people have shown that yelling at a hard drive can actually interfere with its access times. People have done that as well. Anyway, low-level drivers, operating systems, and cosmic rays. Cosmic rays, and this is something that they've theorized for a long time, and servers will have what's called error checking and correcting memory to prevent this or to lessen this. But a cosmic ray can come down from space and hit memory and turn a bit from 0 to 1 and change it. And it's hard to prove that it has happened, but there are situations where they're pretty sure that's the only scenario that could explain what had happened. But on the space station and on space shuttle and rockets, their computers usually have multiple redundant systems in them, and all those systems, they have like 3 systems or more, have to be in agreement, because once you start to get, as you go up higher in altitude, if you're outside the atmosphere, you're getting hit with a lot more cosmic rays. And so it's really common that those computers will have the programs won't run as expected. So they do have that. It's something they deal with in space travel. Now, an example of incomplete specifications, this is actually a joke, but I love it because it is such a good example of that. Software quality assurance engineer walks into a bar, orders 1 drink, orders 1 beer, orders 0 beers, orders a whole bunch of beers, orders a lizard, orders -1 beers, and orders just garbage and everything. Those are the tests that he runs on the software. But then, of course, the first real customer walks in, asks where the bathroom is, and that wasn't something that they thought of. It wasn't part of the specification to be able to define the software to properly handle that, the software of a bar. And the bar, of course, burst into flames, killing everyone. So the dreaded corner cases, really, that's when you're writing software, you need to think. I actually remember talking to I was collecting requirements for some software, and I don't remember exactly what it was, but he was explaining the situation, the usage of the software. And I'm like, well, what if the user does this? And he's like, oh, they'd never do that. I'm like, okay, so we should prevent them from doing that? He's like, no, we can let them do that. And I said, well, then how should the software behave? He's like, I don't know. I said, well, you can't have it both ways. You need to say, these are the possible inputs. These are the possible states the software can be in, and then deal with those. And if you're not going to deal with a state, you should prevent it from happening. So the first thing we're talking about is exceptions, and I'm going to go in and show some exceptions here. There's some information in Dr. Bond's book on that. Here's the page from chapter 9, page 144 on exceptions. An exception is an unexpected or at least unusual condition that arises during program execution, which cannot be easily handled by the program. I think that's a pretty good definition of it. There's exceptions, of course, with the definition, but essentially it's where the program encounters a state that it wasn't programmed for. And an exception gives it the ability to react to that unexpected state. Classic examples are for opening a file and the file doesn't exist, right? Or the file's read-only, or the data is read from the file is wrong. And so an exception is raised, and I'll show what that looks like and how you can deal with that in software. Trying to monitor the Q&A here to make sure in production software for others to use, it's impossible to think of everything. Yes, this is very true, senior tech. It's impossible to think of everything you don't think of. So there are things, that's where exceptions come from, is really, you should think of that, right, is that you want to program your software in such a way to deal with, like, hey, these are the possible things I could expect to happen, and this is how I'm going to deal with that, and I'm going to prevent things that don't fit into that. But when something happens that you didn't think of because you didn't know, you weren't thinking of it, that is where an exception occurs. So exception handling is the idea of move error checking code out of line. So if you have like a block of code that says, I'm going to read this file, you don't need to check to make sure the file exists. Although you could, obviously, there's different levels of robustness you can have in your application as far as how strict and careful you want to be. But if you don't check to see if the file exists and you go to open the file and it doesn't exist, then exception handling lets that be handled at a higher level, out of line. So this allows the source code to be more concise and then have the error handling outside of the actual code that's reading the file. So when exceptions do occur, it branches out of line from to a handler, and then the handler performs some operations to attempts recovery. If it can't recover, then can display an error message to user. One thing that's really important about errors in programs and exceptions and stuff is it's better to have the program stop working than to be in a invalid state. So for example, imagine you're using a calculator and you're adding up some numbers, and for some reason the calculator, something happens, something unexpected happens to the calculator. It's better that the calculator should say, whoa, error, or shut off, or something, as opposed to giving you a bad number, right? Especially, you think of like I don't know, I guess I'm dating myself, an adding machine, right? Where it gives the roll of tape, and you can look at it and say, okay, here's all the numbers, and there's the total at the bottom. And you're like, okay, I know these numbers are right, so therefore the number at the bottom should be correct. But if the adding machine had an exception in it, something went wrong, and it was in a bad state where it was giving you the wrong answer, that would be very undesirable. You instead want it to give you an error and say, whoa, something happened. So you don't want your program to ever be in a bad state, and that's one of the important things of exception handling. So senior text asking, does this mean you should be aware of levels or error levels? For example, crash versus wrong input. Yes, you definitely can have, and I will talk a little bit about this when I talk about exception handling here, actually, shortly, that there are different ways to handle exceptions where you can say, I want to handle the exceptions I'm expecting, for example, and exceptions that I'm not expecting, you're not going to handle them. And Kirk is asking, will the replay include the chat Q&A? So the replay of the full day live stream will include the chat as well. And any of my display on the screen, like yours right now, will be included in there too. Kirk also asked, there is the counterexample to the notion that software cannot damage hardware. That is true. It can damage hardware. Stuxnet, if you're not familiar with it, you can look at that. That's a really interesting exploit against some hardware. It was a software exploit that damaged hardware. It can always happen. And Kirk also pointed out that telegraph operators had to attribute problems to bugs on their wires. I remember being in school, and you always wanted to find, in doing computer programming, and you always wanted to find the one student in the class that was really good at breaking your code. You'd write it, and you're like, hey, come try this. My friend was named Lonnie. I'm like, Lonnie, come try this. And he always would break it. Oh, it was frustrating sometimes. He would just do stuff that you just did not expect. But that's the important thing. You want to find those things and fix them early, especially in production code. How to exit gracefully. So I'll show you some of that. So let me see where I'm at with my. Actually, let's go ahead and I'm gonna jump into the IDE. Oh, I hope I have the IDE open. Oops. Hold on one second. I moved some windows around and I don't have the window in the right spot. Okay, so here we go. This is, I've got my IDE open. I don't have the welcome screen because I closed the windows, but let's go ahead and make a new project. I'm going to make a VCL application. Everything I'm going to show you in the book, it does a console application just because console application is real simple here. But pretty much everything I'm going to show you will work basically the same in any type of application you're making. And the concepts, of course, work on other programming languages as well. Most of them have some sort of exception handling. So let's go ahead and make a simple program here. And we're going to say, this button is going to divide. Right, and so here we're going to have a number and we'll say 100 and then we'll display the result here. So I'm going to click this. So edit boxes let users type in any number they want to. So I'm going to have to say label 1 dot caption equals edit. Actually, I'll do this. Edit 1 dot text divided by edit 2 dot text. Now, right now, if I try and run this, actually, I don't even have to run it. The error insight is going to say, whoa, hold on, Jim. You can't divide strings. If I try and run it, it's going to give me an error message at the bottom here. I have to save it first. Operator not applicable to this operand type. So that would be a compile time exception to compile error, compilation error. So notice it does say error down here. So I'm going to say two integer. Or to int. Or to int. And let's run this now. Errors and error. Oh, so I'm trying to put a extended into a string here. So I have to say float to stir. There we go. So I'm taking the strings in edit, turning them into integers, and then putting those integers back to a float, or which dividing them gets me a floating point number, which then I'm turning it back into a string to display to the user. All right. So the specification was we want to let users divide two numbers. All right. So let's go ahead and hit divide. And there we go, gave us the result we expected. If I put a 3 in here, it's 33.33333. All right. So, hey, this works, right? I can even put like a bigger than 100 number in here. I'll put 200 in here and I get back 0.5. All right. I've made a simple calculator. But what happens if I put a 0 here? All right. So if I divide 100 by 0, that is a floating point division by 0, divide by 0 error message. So a little cool piece of history. When Delphi was first introduced at the conference, they did a program similar to this where they divided by 0 and caused a divide by 0 error message. Now, at the time, if you wrote a program in Visual Basic, which was very popular at the time, and you had to divide by 0, it would actually cause the entire computer to crash. They would get the blue screen of death and you lost all of your work. So you had 3 programs opened and this program had some unsaved work in it, and you open another program, your calculator, and you hit divide by 0. And if the program didn't explicitly handle that and check for that 0 case and the exception occurred, it would crash the entire computer and you would lose all of your work. So having this exception handling built into the compiler, into the tool you're using, was something. I mean, it was Delphi didn't invent that, but it was something that is a thing we take for granted anymore today, but makes a huge difference in your software. So let's say this was a big, complicated program. I'm like, oh my goodness, I'm getting this odd error message that I don't know where it's coming from. Now in this case, I've only got one line that actually does something here. So it's pretty easy to track down. but I'm going to go ahead and debug my program. Now there's two buttons here. There's run without debugging and run. Senior tech, been there, done that. Blue screen of death, BSOD, yes. So common, unfortunately, back in the day. Kernel panic still happens all the time. Let's see. So I'm going to turn on, so one note, and someone mentioned this in the comments. There's two options in your build configuration here. There's debug and release. If you're going to debug your application, which is running it with debugging here, this option, see the little bug behind the play button, then you need to make sure you're in debug configuration. If you're not, then you're not. It's not going to include the debug information you need in your application. So yeah, the reason you have that is because the debug information could potentially slow the program down a little bit, make the program a little bit bigger, and also could allow somebody to more easily reverse engineer your program. Still not incredibly easy, but it is possible. So that's why the purpose of release is it kind of cleans up your program you're releasing so it doesn't have some of that extra stuff in there. So I'm going to turn on debugging and run with debugging. And my program keeps popping up on the other monitor here, so I have to move it over here. So there we go, that works. So I'll put that 0 in here, divide. And now I've got a new message here. This is a message that pops up in the IDE. So the IDE's popped up and my other program has gone behind it. Since I have two monitors, I could actually have one with my program running on and the other one with the IDE, so I could see the error messages as I was looking at the user interface. It says floating point divide by 0 at, and it gives me an address here. So I can say break, and it's going to actually take me to that line of code and put this red line here and says somewhere on this line. And so now I can say, let's look at edit1.text is 100 and edit2.text, mouse over here, it's 0. I can also come here and right click on it. There we go. And go to debug and say evaluate modify. And again, it showed up on the screen. Oops. And we see that it's got a value of 0 in it. And you can do as well, I can go and say, I don't know why it's got really slow here. I can go debug, add watch at cursor, and that will show over here. It'll show me what the value is of that, and it shows, that's a value of 0. So this is useful if you're doing some more involved debugging. You can have use your watch list here. Another thing that's useful is the call stack. And when you get in more complicated programs, this will really save you. Is you might be like, wait, how did I get to this line of code? And this would show you. Now, right now, it's showing me that there was a button right here, custom button click event handler is how I got to this code. So this is the line of code I wrote. This is the code in the library, in the VCL library that I'm using that led there. Now, if you saw the session, was it yesterday or I don't know. I'm sure your brain's probably full too. There's another session on subroutines, functions, and procedures. If I had another routine, actually, I can go ahead and do that. I'm going to hit stop here. And I'm going to add a new routine here. Call it I use Control-Shift-C to auto-complete that. And I'm just going to move this over here. And say do division. Spell that right? Looks wrong to me. And actually, I'm going to, so let's do that. And I'll run this again. And put a 0 in here and hit divide and break. And again, it shows here, but now we'll see that in button 1 click, it called do division. So we see it has that information in the call stack there, which is useful in keeping track of how you got there. Because sometimes, it may be a user did different paths to get to things. And so it's useful to know how you got there to what caused that error message. So now I see what's going on here. It's like, oh yeah, you can't divide by 0. Silly me. So I'm going to try and handle this. So there's a few ways you could handle this. One way is I could use exception handling. So I would say try Let's see. And show message and not divide by 0. Okay, so I'm just like, I'll just say, don't do that. Don't divide by 0. All right, so now I'll go ahead and run this again. Bring this over here and put the 0 in there. And now I'm giving a nice error message to my user, right? Or I could, for example, say, another option would be, I could just say, I could go like this and say, I know, I'll just say, label 1 dot caption equals 0, right? Which is not a valid answer for dividing by 0, but we'll pretend like it is. And run this again. 0. All right, so now I feel like I'm happy. I've solved this error message, right? We're no longer getting that cryptic error message that users are going to panic about, and we're giving them something useful back in return. So the other problem, though, is let's say someone comes in here and says cookies and tries to divide cookies by 0 or cookies by friends and still gets 0, and that doesn't make any sense. I want to divide cookies by friends. That should give me something meaningful back. And so now it's not as useful to the user. And the reason is because this traps every possible exception. So if I take this back out of here, I'll get this out and run this, we'll see we're getting a different error message. This is not a valid integer value. Oh, that's what the error message is, right? So we've hidden some useful information from the user by trapping all kinds of exceptions. So what you can do here is I can say, let's leave that off. And come here and say, on E divide by 0, do. And so this says if it's divided by 0, then we would say cannot divide by 0. So now if I put 0 in here and hit divide, oh, I'm getting a different error messages. Haha. So let's go ahead and run this with debugging. I'm not getting E divide by 0. I'm getting something else. Let me run this and see what the error messages are. The actual exception classes. Class. Oh, interesting. That is not an E divide by 0 exception. So when an exception is raised, you get, what? I wonder why that's doing that. It has a class that the exception is. And the exception is not, the class is not E divided by 0. The exception is, I'm sure let's leave the screen, so let's move it over. It's the class, see this? This is the class here. So, oh, that is interesting. I'm curious, this used to work. I've done this demo before explaining how divide by 0 works. And that used to be E divide by 0, but it is not now. So let me do a different demo here. I'm not sure if that's a bug or if there's something I'm not thinking of. But, well, I guess it would be a bug because it is something behaving not the way I expected it to, right? Let me go ahead and do a different demo here and I can show a process here for this. So let's say I want to count the lines of code in a file. All right, so let me go ahead and get rid of this one here, and this would be show and explore, and let's copy as path and set the text there. Oh, I need to get rid of the quotes. And I'm going to say, this is going to say count instead. I'm going to write some code in here. I don't need this anymore, so take that out. And I'm going to use a t-string list. This is the new inline variable syntax that was introduced in recent versions of Delphi. If you're using an older version of Delphi, you'd have to do this a little differently, but for the purposes of what we're doing here, this will work fine. So anytime you create something in code, you need to free it when you're done. So I'm going to say sl.free, and it's going to free that. And I'm going to say sl.load from file, edit1.text. And then I'm going to say label1.caption equals sl.count toString. This is just going to count the number of lines in that file and put it in the label. So we run this, and I hit the count button, and 38. All right. I can actually come here and look, and there's not actually a line there because that's where the end of line marker is. So 38 is right. I believe that's right. So this is working. But what happens if the file does not exist? I'm getting an exception. So let's go ahead and debug this now. Kirk says it works on his machine. The divide by zero works on your machine, Kirk. So I don't think I'm running a beta. Wouldn't be the first time I messed up. And we just got a bunch of spam again. Sorry about that. One second. Let me go out and set up a filter for that. I set up a filter yesterday, and then they came up with a new, now using a different term. Where is this at? There is too many settings options on YouTube. Settings, nope. Settings, nope. Come on. Oh, I remember what that. All right. That would be a bug in YouTube's user interface. Okay. I think I've cleaned those up. Unfortunately, when that happens, it does clear out my chat history. So, all right. So right here, see this says EF open error. That's the exception class that I got. So now I can break. And so this is interesting. The error occurred in system Debugging.classes, which is the class that has the open in it. So when I call the open in here, you can see right here, here's my button 1 in my call stack. It called strings load from file, which made a file stream, which called create on that to open it. And so that's where the call stack comes in useful. But eOpen file stream is the error message I got, or the or is the exception class. And so I can come here and say, we'll break, and I want to say, try accept show message file doesn't. Actually, I'll show how to do this. If you just do double single quotes, then you can do a apostrophe in there. So now if I run this again, and the file doesn't exist, I have a useful error message now that's not so much scary for my users. The problem, though, is again, is I'm trapping all types of exceptions. So what you want to do is you want to, when you put an exception handler in here, you want to say, I only am handling E, F, open error. File doesn't exist. And the reason is because if I trapped all types of exceptions, there could be another exception here that maybe was an out of memory error, right? Maybe the file was too big, and the user would be like, but the file exists. How come I can't open it? Well, I can't open it because I ran out of memory. That would be, on most modern computers, that would be a huge file, but it's still possible. So the point is, the key point is that when you're doing this, when you're saying, I want to trap an exception, you should only trap specific exception types. And this, you'll see occasionally people do this, where they just make an empty exception handler, and they're like, I don't want error messages in here. And now they've hidden the information. There's no useful information in here for the user or the developer, for the Q&A or whatever, to know why is this no longer working, because they've just hidden all that information. So that's the key, is you should trap specific exceptions as specific as possible there. Now, Miguel pointed out that mad accept is helps a lot identify source code when the bug occurred running application production. Yes, mad accept is a fantastic tool. There's a couple other ones like that when you're writing code for production. Definitely you'll want to check those out. Could do a whole session just on using mad accept. It's very, very powerful. Now, another thing that's going on here, and that's not obvious, is another type of bug. So I'm going to go here. Oops, wrong button. Source. So this is the source code of the project. So frequently you're not in here working on this part, but it's something good to know that is there. And I'm going to say report memory leak spawn shutdown equals true. And what this will do is it'll find out a memory leak. Now, a memory leak is when you allocate something and it doesn't get released. So right here, I'm creating a string list and then freeing it, right? So I should never have that problem. If I didn't have free here, then I would get that error message where I'm getting a memory leak. So let's go ahead and run this. And we'll hit count 43, close it, no memory leaks. Okay, that's good. So we'll run this again, and I'm going to say, put that error there so the file doesn't exist. File doesn't exist. Okay, that's what I expected to do. And I close it, and it's over on the screen. It says, unexpected memory leak has occurred. The expected small block leaks happen, T string list. But I'm looking at my code. I have a free here. Why did this happen? The reason is because whenever there's a pattern you're going to want to use anytime you call create. And so let me show you what that pattern looks like here. You're going to say try finally. And so this is also an exception handling pattern that says that whenever I'm going to try to run these lines of code, and whether they work or not, whether they create an error or not, I'm always going to run this line of code. All right. So this doesn't capture exceptions. It doesn't handle exceptions. But what it does is it gives you the ability to guarantee this is ran. All right. So now we'll run this again. And I'll put in a invalid file name, hit count. I'm getting the exception because I'm debugging it. But then when the application gives my nice error message, file does not exist, I hit OK. And then when I close it, there's no memory leak report. And so that's a really important pattern to do. Anytime you want to guarantee another line happens. So another example of this is like, let's say, for example, you have a button that when the user clicks the button, you're going to disable the button and then do something. And then when that something finishes, re-enable the button. Re-enabling that button is important because if an error message occurs, like that, let's say, for example, the file doesn't exist, and it pops up and says, oh, file doesn't exist, but the button never re-enables, then they can't fix the error message, and then they're stuck in a unexpected state. So that is a really important example of that. So anytime you want to make sure something else happens, you want to use this try finally block. And in practice, this gets used way more often, try finally, than try except. Another option is you can use the, actually, I haven't done this before. There's an application events on it, and it has a on exception event handler here. And so here you can actually make a global exception handler for your application. And you get the exception object, and you can say something like if E is EF open error, then I'm going to use the message dialog, which is a little fancier version of show message. And I'm going to say file does not exist. Although it could be any type of, or it could be any open error. So really at that point, I don't know what the case is. And the dialog type would be error. And buttons are. And I can take this off here. And if I run this, it works. But then when I put something here so the file doesn't exist, the exception occurs, and I say continue, and it's handled in my global exception handler here. So that's another option. Again, you want to always trap the specific types of exceptions that you're getting so that you handle them correctly. One note about try except, and this is really funny that this actually happened, or I'm not sure if it's funny or sad, but I had I was working at a job, and one of the existing senior developers was showing me a code base that there was a code base that wasn't very often maintained, and he went in to show me, kind of give me an overview of it as he's fixing a bug, and he used the try except block to make sure memory was free instead of the try finally block. And his logic is that when you have a try except, the except block, actually I guess I gotta show you the code. I was going to try and explain it, but it's easier to show it. Even though this is bad, do not do this. I will write that right here. This is bad. Don't do this. He would do this. He'd say, and here he'd say raise And then here you could say SL free. Now his logic is that the description of the try except is that the code after the except block is executed. So if I do this, I'll do it. Show a message. You can see it. Done. So we actually got to that line because except ate that exception. It consumed it. It hit it. But if I put raise in here, and so what raise does is it actually raises the exception object back up again. So raise gives you the ability to do something and then spit the exception back out, which isn't a really popular pattern, but it's a pattern that you can do. And so now if I run this, and make the file not exist, file does not exist, done is never called. And the reason is because except allows that exception to bubble back out again. So I just got the memory leak error over here and get away. And so he's doing this and I'm like watching and I'm like, oh, that's odd. I've never seen that pattern before. And I'm thinking about it for a second. I'm like, I don't think that works that way. He's like, sure it does, because everything after an except block gets called. And I'm like, but not if you call raise in there. And he's like, yeah, it does. I'm like, well, let's make a test. And so he made a test similar to this where he had a message dialog in there. And sure enough, it didn't work, which you just saw. And he gets this look on his face like, I've been writing code like this for years. So you saw how easy that was for me to test. Always test your assumptions. If you think something is going to behave a certain way, you should test it. And a great way to do that is with unit tests. So let's go ahead and make a unit test. How are we doing for time? So Miguel says he's been using mataccept since C++ Builder 6. It's a lifesaver. Mataccept is a fantastic tool. I would agree. Oops, that should be there. So we're going to talk about unit testing next, but actually I'll show mataccept. This is a really great tool. And I'm trying to remember what the other one is. There's another one that's very similar to mataccept out there. But if I remember correctly, isn't like it's no, there's another one I can't remember what it's called, but it has a free version as well. But it's like a free light version. But yeah, this is incredibly useful. And I cannot remember the other one's called, and I'm spacing it. Actually, I know where it'll be. Boom, 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 boom. Nope, it's not listed here. Oh, okay. It does have a free without source for non-commercial use for mataccept. I thought there was another one though. Oh well, mataccept is great. I like to be impartial. Eureka log, that's what it is. Is it listed here? It's not. All right, let me go to the Eureka log website. I like to try and be impartial because I don't want, especially when there's two tech partners that are both fabulous. Eureka log and mataccept are two fantastic tech partners. And so I don't want to exclude one. So Eureka log is another great one. These two tools are really phenomenally useful. Like I said, we could do a whole session on that. There probably are videos out there elsewhere that go into detail on this. Okay. Pete just said best session yet. Well, thank you, Pete. I'm glad you're appreciating it. Let's see. Where's I got? Oh, that's right. I was going to do exception or unit testing, and I had a slide on unit testing. So unit testing is a software testing method where you test individual units of source code. And so individual units, so in Delphi, we do call a source file, a unit, but it can also be, unit testing is actually individual methods, individual functions, individual methods of an object, individual procedures. It's the smallest possible unit that you can test. So that example of the QA engineer, the reality is, if you had a method called order beer, you would have a unit test and you'd pass 1 to the unit test, you'd pass 0 to the unit test, you would pass 9 quadrillion to the unit test, you would pass lizard to the unit test, or I'm sorry, you'd have a unit test that passes these values to order beer and test to see if you got back the result you expected. And the beauty of this is that you know that when you make a change to orders in the future, your unit tests can run. You can rerun your unit tests over and over and over again. So every time if you write a unit test, you can run the unit test every time you change your code. And you should run it every time you change your code. And you will know if your code still behaves the way you expected it to. Now, there is a CodeSite is another tool, which I will talk about shortly as well. There is a methodology called test-driven development. And this is a software development methodology where the idea is that you should write your test before you write your code. So if you're going to have, actually, I'll give an example of what this would look like. So let's go File, New, Other. I have 2 monitors, and one monitor is high DPI, the other one is not. And it creates all sorts of interesting behaviors like this, where you get these odd looking things. Okay. And my high DPI monitor is the main monitor, which of course makes it even more complicated. So I'm going to say create unit test, create startup. There we go. So we're just really going to scratch the surface of unit testing here, but I want you to become aware of this as being it's something that you can do. So right now, what this is going to do is we'll add a new. That's a new behavior that it's taking a second there to appear. Add a new unit, and we'll call this save it. So unit 23 is unit under test, and unit 22 is, we'll say, my unit test, and unit test example. So in here, we're going to have a procedure. Actually, we'll say order drink. How's that? And we take a function. Let's say it's a function. Let's see. Let's comment here. With Jedi Code Library, you can also show exceptions with call stacks. Yeah, Jedi Code Library, very useful. I should bring that up as well. That didn't get it. That's the easiest way to get that one. Tools. Package manager. Jedi Code Library. It has a ton of stuff in there. Oh my goodness. If you're not using Jedi Code Library and JVCL, if you're doing VCL development, definitely check these out. So this one works with FireMonkey as well on most. Some of it works on cross-platform, but some of it's Windows specific. But if you're doing Windows development, definitely check these out. Very useful. Let's do this. We'll say const name is a string, and we're going to return a float, which would be the amount. Actually, it would be what's it, the real. Preferred. All right. Oh, unsatisfied for it. Yep, because I haven't implemented it yet. So test-driven development would say that I should put no code in here, and I should go in here instead and write my test. So test one is going to call, so we'll say file use unit. So we're using unit under test, and we're going to say order drink, and we'll say drink name, beer, let's say root beer, for root beer, and drink count is 1. And we would say that we expect, so it would say, make sure I'm doing this right. It's, oh, come on, my brain's going blank. I did not sleep very good last night. I apologize. DUnit. No. I'll get there. It's thinking the wrong term here. Test. Oops. My brain just totally checked out on me. Let me look in the documentation. If all else fails, right? DUnitX is the unit testing framework I'm using. So here's an example. So this is a great thing to check out here. You can just go in here, look at this, and yeah, assert are equal. All right, I was close. I was just not there quite. So I would say assert are equal. Let's say we're expecting root beers to cost $1. All right, so oh, I hit tab. Sorry. What is this error message in here? Nope. Okay. Oh, all right. I gotta say 1 root beer. Oh, it's $1. Nope, I'm still getting error messages. Oh, so it's upset because it doesn't know what type that is. That's interesting. I'm not, so if I was using an object, which would make sense, then I would create it, create the object here in the setup and teardown, but it's not, oh, let's do this. Var total single equals I'd say total. What? Let's try this. Are expected. Getting the error message. Oh wait, expected. There we go. All right, so I just had to be, I was being too clever. So now I'll run this. And so the program I ran, all it does is runs the test. And it said test failed, expected 1, so is not equal to actual 1. Oh, I did it the wrong way around. So it should be the way around. If I look at this, it should say expected first. I always do that. I don't know why. So expected is the value I'm expecting. Total is what I got back. So now I run this. Expected a 1, and it's not equal to a random number, and that's because it's undefined, which I had a warning that said it was undefined. And the error message is 1 root beer costs $1. So now, oh, that's fine for the unit test. So now I'm going to come in here and say, okay, if drink name equals root beer, then result equals drink count times 1. So 1 is what we decided was the cost of a root beer. And so now I'll run this. And success. No tests failed. There's other tests here that I didn't actually use, but we'll notice I'm still getting a warning down here. And I have a very strict policy in code that you should not have warnings. Hints and warnings, those are there for your help. If you're getting those and you're like, oh, I don't need them in this use case, then there are compiler directives to turn them off in that one situation. So to only turn them off in the one situation. Otherwise, those are there for your help. And so what they're saying is it's undefined. And so if that's a good warning, because let's say I have another test here. Just go ahead and make it a test. We'll call it B. And in this test, I'm going to test sprite. And one sprite costs $2 because for some reason sprite is more expensive. Expecting 2. So I'll run this. Oh wait. Okay, I know what the problem is. I didn't say test 3 is a test. So let's move that down here. I need to say this is also a test. Called. So tests found 4. So it did go up by 1, and we see that 1 failed. And again, we see 2 is not equal to some random number. 1 sprite costs $2. So I could say else drink and sprite and and I need to have a final else. We'll say result equals 0. So whatever else it is, we going to say actually we should raise an exception. So to raise an exception, so saying we're in a state we don't know how to handle. So it's a drink besides Sprite or root beer. So therefore we're going to raise an exception. So this is exception, which is just general exception, and we'll say unknown drink type. I have to say uses sysutils, which is almost always in your uses clause in any other unit, but that's where exceptions declared. And so now we're not going to have the hint saying that we're not all defining all of them. All our tests pass. And so now we can do another test that says, remove this one here because I'm not using that for right now. Actually, I'll remove all these that I'm not using. Simplify this. And I know I'm kind of flying through this. This is a pretty involved, but it's something I want to make you aware of. And then as you're aware of it, you can go out and do some more reading on it. Nick Hodges has a book on coding in Delphi that does cover this as unit testing. So, and I believe Alistair Christie's new Code Better in Delphi covers this as well, but it's not out. That's not published yet. And I bet Marco Cantu has books that cover as well. So in here, we're going to say cert dot, there's an option in here that says is raised or is null, is empty, is not null, will raise. There we go. Will raise, and I'll say exception. The wrong key, I hit the F1 key. It's bringing up my help. I don't need help. Well, I might need help, but that's not what I was trying to do right then. Kills. Will raise exception. Oh, this won't work here. Yeah, it will. All right. So I need to say no. So because I'm not doing an object here, that's not going to work. But I could do an object where I would say if I had declared the order drink as an object on a bar, then that would work. But because I made my example too simple, it's not going to work. But the point is that you can also test to say this should raise an exception if I try and order a drink of one other type. And so you would go, the point is that you would go through your tests and you would create a test for every edge case, right? So what happens if I order an invalid drink? What happens if I order a negative number of drinks? What happens if I order too many drinks, or etc. But apparently also I need to add an option for where's the restroom. Otherwise the bar will explode. So that's just a quick introduction to unit testing. Oh, I left the message up there. Let's see. Glenn is saying, I have an app that occasionally just shuts down, no error messages. I suspect WinServer is shutting it down for accessing memory it shouldn't, but I can't replicate it. Would one of these apps mentioned help? MatAccept or Eureka Log would probably help in that because it could capture that and save it to a log file when the application gets shut down. Another thing that is useful is CodeSite. Let me bring up the page here for that. Oops, wrong window. And the other one is Brain. Come on. There's a quote I heard the other day that said, when you expect yourself to remember something, you're going to get let down, because I don't know if it's just because there's another logging program. There's a few other logging programs. CodeSite is one. There is one that's by Grigi. Grigi Log, I think is what it's called. Let's find it here. Gridgy Cloud Logger. And then the other one I'm trying to think of is, I'll show my screen here in just a second with these on it. Is I can't think of it. All right, there's other ones out there. Let me show my screen again. So there's CodeSite, which is by Raise Software, and there is a light version that's included with Delphi, and Gridgy Cloud Logger, which is open source, are two logging programs. There is at least one other one. Actually, there's probably multiples out there, but I just cannot think of what they're called right now. So let me show you. And so what loggers allow you to do, actually, I'll show a quick, short, simple example here. Let's close this. And I'll reopen my, this one here. Debug string, and I'm going to say form created. So in the form create event handler, I'm going to say form created and spit that out to the log. So now when I run this, oh, come on. Oh, it's in, nope, view, debug windows, messages. All right, this is in Dr. Bond's book, and I was just reading it, and I know it's, what did I do wrong here? Let me open his book up. When all else fails, read the directions, right? Okay, output debug string. Huh, it's showing it the way I did it there. Let me try one more time. I just missed the message. In debug mode. Maybe the line's not being called. It certainly looks like it is. Oh, I know what it is. There is a weird. I have another program installed that is intercepting debug strings, and I ran this before. So that's a reason not to use output debug string. That's a simple example of how to do that. But then the other way you want to do it is with either Gridgy Cloud Logger or with CodeSite. Let me install CodeSite. Yeah, so Gary pointed out that with when I was trying to do the will it raise or will raise, I should have used an anonymous method. That's true. That would have worked. Yeah, and Kirk pointed out the studio version of CodeSite has a great feature, single click to generate messages on all subroutines, entry and exit. That is so useful, that instrument to instrument everything. If you're trying to figure out what's going on, or track through a program, figure out where an error message is coming from, stuff like that. So useful. Something's going on here. I've got a case of the demo gremlins. Give me a second here. Figure out why this. Years ago, I actually wrote a program that would capture all output debug strings on your system, which is not the one I have running now. I have a different one running now. But that was actually really useful. I wrote it for capturing errors from Delphi, or errors from an application built in Delphi, and it would log them. And that was before I discovered the CodeSite and Gridgy Cloud Logger and the like. Let me see here. Okay. There is a video on YouTube with Ray Konopka showing CodeSite in action. Highly recommended. Go check that out if you want to see more about CodeSite. But I'll get a basic demo for you here. Close that. Tools. Right. Oops, not showing my screen. I don't think that. Oh, yeah, that's a different project. Let's make a new application. I was installing some software that I'm working on, the Python related software, and I bet you I've installed an IE extension that has created some weird behaviors. I love that about Delphi, that you can create IDE extensions and stuff like that and change the behavior, but more than once I've created problems that way. Oh, that's odd. That is really big. Weird. Oh yeah, Bob Swart did a CodeSite session at DelphiCon as well. Yeah, so if you just do a search for CodeSite on YouTube, you should be able to find Ray Konopka or Bob Swart's sessions on it, which are going to go into way more detail than we are today. But if I go to Tools, CodeSite Express, I can bring up the on the wrong screen, of course. Come on. The CodeSite dispatcher, which runs down on my system tray. The dispatcher lock, there we go. And this is where I can get a list of like messages and stuff like that. So actually this will show things here. And then CodeSite controller, there we go. Here's where I can configure the dispatcher and stuff like that from this. And live viewer. That's what I was looking for. There we go. The live viewer. And so here is where I'll bring up back the help again. So if we go here to the getting started, it says you want to bring up the live logging and the live logging tutorial. So let's go in there, Delphi live logging tutorial. So I'm going to add code site logging to my users clause and then say code site.send my first message. So let's go ahead and do that here. I'll put a button down. Oh, wow, that's really big font. All right. Logging, and then here I'll say code. What did I send was code site.log? Where did my help go? Did I close it? That would totally be a thing I would do, is close my help. Yeah, code site.send. Oh, send, not log. I am hitting all sorts of weird keys on my keyboard. All right, let's try this again. Send message hello from code site. So now when I run this application, after I save it, I have autosave turned on. I know computers are so picky, aren't they? So let's bring this up here and my live viewer. And so now when I hit this button, this shows up here. And so what this does is this allows you to, what logging does is allows you to capture information from the program while the program is running. And you can capture all sorts of information here. So this is just a simple hello message. But you can have all sorts of, you can pass values in here, all sorts of different types of messages, very detailed what you're doing. And so what this does is allows you to do things and see like how often a certain routine is being called, when a routine is being called, where it's being called from, what values are being passed to it, and stuff like that. And this makes it really easy for you to observe the behavior. You can also have the code site logging turned on or off based on whether or not you've compiled with debug information or with flags. And you can also have the logging be collected out in the field. So an end user could be using it and you can say, okay, turn on logging, and you'll tell them the secret handshake to do to turn on the logging. And then it can collect that log information and you can get it. Gridgy Cloud Logger, another one. And totally forgetting the other one. Let me find it real quick. As I remember it, I'm gonna be like, oh yeah. Partners. Nope, that's not it. Smart Inspect. That's what it is. So Smart Inspect is another one. This is, as a developer, you're going to want to have a good logging tool. And out of those three, and there probably are other ones out there, those three are a good place to start. Pick one of those, learn how to use it, and get familiar with it. And you're going to be surprised if you've been developing for a while and not had a logger. You're going to be like, oh my goodness, I've been developing with my hands tied behind my back. Is it gives you just a lot of useful information where you can see what's going on in your application as it's running. Okay, let me get back to my slides. Oops, wrong window. So Miguel's saying it would be nice to have a trace function on programs, inner time, exit time, memory accepted, ejected by the compile time. CodeSite can do that. With the full version of CodeSite Studio, you can have it automatically do that sort of thing. There are other tools out there that will do that as well. Let me bring up my slides again. Where are my slides? So I wanted to talk about robustness. And so there's, in my mind, there's two different types of robustness, but there's this robustness principle, Pastel's law, which I think is a good summary, good thing to think about. But it says, be conservative in what you do and be liberal in what you accept from others. And so what this means is that it goes back to what I was talking earlier about that idea of capturing requirements or defining what the behavior of application is going to be, is that you need to think about what potential different types of input might I receive. So for example, when I was typing in the unit tests, right, I might say, oh, you know what, root beer might be spelled maybe accept different types of uppercase versus lowercase, or a space between root and beer or something like that, right? And so adding that in there to be more liberal in what I accept and being able to accept different ways of having root beer defined, that is being liberal in what I accept. But then conservative in what I do is to say that I want to be concise in that the output of that method, of that order drink, is always going to be a number within a certain range, right? It's always going to be a number. I'm never going to return lizard as an option to buy drinks. And so that's a real important thing, is to think, the more you can put into your code, to think about what's the broadness of the inputs I may receive and how can I behave that way. I am also a big fan of you can do asserts in regular code. So no, you can say assert in condition is one dot text does not equal blank. All right, and then we got a message here that says must provide some text. So an assert is interesting in that this is a exception that can be turned off. So the comment here, if CodeSite is Rad Studio version agnostic, there is updates to CodeSite. If you go to the website, it does say it's updated for 11 or Rad Studio 11 Alexandria, but it will keep working for the most part. There may be some things that change, but it's not going to break it. I can't think of. You might have to like make a small change to your code, or make sure that it's added to your path in the IDE path or something like that. But those are all things, if you've installed code before in your IDE, installed components, you'll be able to figure out. And yeah, they would be updated right away. Okay, so let me run this. Oh, it's already running. That could not create output file. I almost feel like there should be a feature in Delphi to say, hey, if I'm trying to run it and I've already got it running, just kill it and run it again. Maybe I'll make an add-on to do that. Okay, so right now it's generating nothing, but then if I delete this and hit the button, then I'm getting an assertion failed message. You must provide some text. So the interesting thing about asserts in here, as opposed to unit testing assertions, is that if I change this from debug to release and run it again, oh, it's still, oh, I know why. So if I go here to project options, Delphi compiler, and it's one of these. Oh, compiling. Right here, assertions. So I can set that in release configuration, I want to turn assertions off. Honestly, I love assertions and would rather keep them on all the time. But the idea is with assertions is that you can set it so that in debug mode, assertions are on, but in release mode, assertions are off. And so that way you can say, when I'm testing my application, when my application is in test, being tested, I want to assert a certain set of behavior, a certain set of expectations. And then when it's being tested, you can make sure, the idea is I should never get an assertion. But then when I go to release, so now I've turned it so that in release, assertions are turned off. Oh, I got to hit build. If I did it, maybe I didn't. It's possible I didn't check the box. All right. So now there's no error message. So the idea with assertions is that you're like, if you know having a number of checks can slow down your application and that speed is really important to you, then you can turn off in release. And so during test, it's going to run slower, but then in release, you remove the assertions or the assertions are ignored, and it's not going to create error messages. But so the idea is that during test, you make sure that you never ever get any of these assertions, and then they're in production. That should never happen. So Terry's saying that the code site Express Studio is currently a one-time purchase, but he believes it's going to be a subscription in the future. I'm not sure if that's the case, but I think it's a great product. As a one-time purchase, is definitely something you should buy. So assertions are a useful thing. But like I said, I'm a really big believer in that if I write a routine like my order drink, that you should open with some things and like, hey, this is what I'm expecting my input to look like, and be very strict in that, or very specific in that. And then also you can have assertions at the end. So this would be called preconditions and post-conditions, where you're like, after my routine is done, this is what my output should look like. And that gives you a way to be very sure that your program is behaving the way you expect it to. And we're actually getting up here on the end of time for this session. I was trying to keep an eye on questions as we went along. If there's any other questions about debugging in general, I am happy to discuss those. I'll bring up my slides and make sure there wasn't any points that I was wanting to cover that I missed here. Oh, I didn't do breakpoints. Breakpoints are really useful. I think I did a breakpoint, but I didn't really talk about it. You put a breakpoint in here, and it lets you your program stop at that when that occurs. Yes. So David's saying, I'll address it right now. David's saying, isn't an assertment to use to catching logic errors rather than validating user input? Yes, correct. So it could be if you so if you think about your program in different layers, right, and you have a layer that collects user input and then a layer that has logic, you put your assertions down here. And if these assertions may be on the input that's coming into this logic layer, from the user input layer. Oh, you can't see me because so yeah, you have your logic layer and your user input layer. And so you have your assertions down in the logic layer. And if and it's on the input that comes to this logic layer, right? So for example, order drinks, it should be certain values. Now, when you're testing your application, if you get these assertions, that means this user input collection layer is not properly filtering the input. So you would add code to your user input layer to make sure that the values that are being sent to your logic are of the correct values, range, types, so on and so forth. Because yet you're not going to know what your user inputs. If you're going to remove or turn off assertions at runtime or release mode, then you definitely don't want to do that for user input, because users will put anything and everything as input into their application. Okay, so I put this breakpoint in here on the button click. So I click button 2 and it stops here. This is where I can come in and I can inspect values in here as well. I can, you can do conditional breakpoints too. This is a really useful thing. If you go to breakpoint properties, you can do a condition. So here's a great example of that. Let's go. Zero and say for var I equals 0 to 100. Equals 1. I would say total equals total minus 2. And consider integer must be byte. So now if I run this, the breakpoint off, I should get an error message if I thought this through correctly. Because that will eventually, yeah, range check error. So now let's say I wanted to look at this and say, well, wait a second, at what point am I getting a range check error? Because at that point, this number is too big. And so I can put a breakpoint in here and run this again. Oops, wrong one. And if I come here and look, total's 1. Well, 1's not going to cause a range check error. So I can come here and say breakpoint properties and say condition and say total is greater than 100. All right, and so I only want to stop when total is greater than 100. So I can run this again. And now I can look at it and say total is 128. And so then I can use the step over and I see a range check error. So breakpoint properties are going to help you kind of narrow in. So especially in like loops where you don't want to have the breakpoint firing all the time. Before I discovered breakpoint properties, I remember, saying continue until it finally happened. So there's a lot of stuff you can do in there. Once you get into breakpoint properties, there's more things you can do too. Yes, you can have breakpoints enable other breakpoints. Lots of amazing stuff you can do in there. Breakpoint properties. And you can actually get here in advanced and do other things here as well. Ignore subsequent, handle a subsequent, yeah, all sorts of stuff you can do. You can say I want to break only after a certain number of passes. Lots of great stuff in there that you can do. There's lots of documentation on that. So Terry's asking, let's see. Have you contemplated doing a series of debugging related videos? So much information that could be covered. And one of my weaknesses personally goes on to say, I barely touch various options for debugging that are baked into Red Studio, call stack, threads, events, CPU, windows, etc. I thought about it, and that's part of the reason I did this one. The reality is there's a lot to it. So I will see if we can get something that goes into this in more detail. Because, I mean, we've spent 2 hours on it here, and I've really just scratched the surface on these topics. Oh, I'm glad that you've found this so engaging. That's great. Oh, yeah, drag and drop this is a cool one. I'll go ahead and hit button 2. So I can use this here step over it. And I can go here and say total, and I can right click on it and say debug value modify. And I can change the value, new value. Oops, here to 2, and say modify. And so I have my mouse over total. It says 2, but then I can grab this guy here and move him back up to the top. And then now he's 1 again. And then I can go here. And so let's see. Total's 2. I can drag it back there. And that'll make total 1. So cool. My audio just went bad. I'm sorry. Yeah, so dragging and dropping. And my screen. Oh, my screen's not shared. Let's do this again. Set a breakpoint here. All right. I will. My sound is garbled. All right. Hopefully you can hear me now. Okay. I switched microphones. I have a backup microphone. It's just not as good as the fancy microphone I have right here. So audio is back to normal. Okay, good. So you should see my screen now. So let me do this here. This is really this is just barely getting into like power debugging stuff. But so right now I have total is 3. So let me go. I should have a view debug windows local variables. I wonder where that's at. There should be a window for local variables. I must have it. I moved this to a different monitor, and I bet you it's like hidden somewhere. That's all right. So I'll just add a watch here for total and I. Okay, so I is undefined right now and total is undefined right now. So as you step in here, now total has a value and I has a value. And we can watch as it's going along. You can see the values changing here in my watch list. And then I can drag this here and drag it back up to the top again. And then start tracing in here and see now total's back at 1. And I can also right click on total and say value, we'll make it negative. Oh, let's see, new value. Man, I got range checker. Anyway, oh, my sound's garbled again. Oh, is the sound back? Weird. I don't know what's going on with the sound. Maybe that's my sign I should stop. If you do have any questions, go ahead and put in the question panel, though, and I'll try and answer them. And then I will also do in the future to try and do this again. Switch microphones again. Kirk says you must have a computer here someplace. Yeah, you'd think I'd have one that works someplace here, but oh, sounds good. Okay, I don't know what's going on. Anyway, any other questions or comments? I will look at doing another session on debugging. It's honestly, I think that debugging, at least for myself, I feel like it's something that every developer feels like they're not very good at. And so maybe that's probably why we haven't seen more sessions on it, is nobody feels comfortable enough to do a debugging video. But hopefully this was useful. And I saw a few people saying this was actually quite useful and interesting. Realistically, there's a lot of stuff out there. I think there are some books that get into debugging, so I could talk to the authors of those books to see if they want to do a video on the topic. But let's see. Coming up next is Boyan Mitov's talking to microcontrollers with Arduino. I saw Boyan online earlier, and his session is another 2-hour-long session. Boyan is a genius. I learn so much from Boyan all the time and find him incredibly fascinating. Can we do a session on flying on the seat of your pants? That was this session. Flying by the seat of your pants. Yeah, Boyan's session, this is fascinating. I'm actually really interested in this. He makes a lot of great stuff for talking to Arduinos and working with other types of embedded system. His video is 1 hour and 20 minutes long, and then we'll have Q&A after that. Terry's saying, can I +1 my own suggestion? Oh, for the debugging video? Yeah, absolutely. Mon saying, problem with Python for Delphi, I just installed Python 3.4. I don't know what the problem is. You'd have to check debugging books related to Red Studio. Actually, I bet you I do. Let me look real quick. I believe, I'm not sharing my screen. Yes, that's another one, refactoring. Oops. Yes, Kirk, you'd think I'd had a computer somewhere around here. Extract method is another good tip for debugging a large process. Let's see here. Nick Hodges. Where's his website that he has? There it is. The table of contents. I have a copy of his book. Hold on a second here. Let me find my copy of his book that I have, and I will bring that up. And actually, oh, there's a I don't see. He does have. Oh, I'm not sure I'm reading it. Oh, I'm glad to hear that. Seattle Share, PyScripter is absolutely awesome. I really like PyScripter quite a bit as well. I'm a big fan of it too. So glad to hear that. So here is Nick Hodges' Coding in Delphi. And I thought there is a chapter on unit testing and also dependency injection, which is really useful. Interfaces, this is a really great one here. Let's see if there's, he doesn't have I thought there was. All right, my mistake. This is a good book though, and I'll have to do some research into seeing who has some books on debugging or resources on debugging. And actually, you can get this book for free right now. We do have a special offer going on. If you go to Embarcadero.com, while you're here, of course, register for the 11.2 preview webinar coming up. If you're not on 11.1, you can get the free trial or upgrade. Of course, want to always suggest this. But if we go here, I think it's under resources, white papers. Yeah, so you can get dependency injection in Delphi, code faster in Delphi, coding in Delphi, and more coding in Delphi. 4 amazing Delphi books. And code faster, I don't think he might get into debugging in there. I know he's got another book he's working on, Code Better in Delphi, that may also have some stuff in there. Let me see real quick, because I know I have a copy of that one too. As I collect books. Faster. There it is. Code faster in Delphi. Nope, he doesn't get into, I don't see anything on debugging in here either. But it has some shortcuts related to debugging. All right. Interesting. Well, maybe he has it in his next book that's coming out. Oh, it's top of the hour. I got to get started. Martha's been messaging me. Oh, yes, that's a good one. YouTube's Mark Eddington's Debugging Techniques. Danny Thorpe had another one on like T-Leaves debugging or something like that. That's another great book, another great video on the topic. So I'll see about collecting some of those up and get people going. I will respond. I see another message about Python for Delphi. I'll respond to that once we get the session going. So let's go ahead and get started with Boyan's session here. And I'll see you guys on the flip side for Q&A.
Hello and welcome to Coding Bootcamp 2022. My name is Boyan Mitov, the president of Mitov Software, and in this session I will show you how you can use Arduino to program Arduino manipulator and how to create Delphi applications to control it over serial communication, Wi-Fi or Bluetooth. Here is the robot manipulator arm I will use in the projects. As you can see, it has 4 degrees of freedom controlled by 4 servos. It comes with Arduino Uno and potentiometer shield that also has connectors for the servos. It has 2 additional connectors for 2 more servos. It also comes with Bluetooth connector. We can install Bluetooth to serial module here. And it came with power adapter that I will use to power the robot during the experiments. The shield, for some additional information, allows also seating an Arduino Nano size board, but we will not use this feature. Important to know is that there is a jumper which allows the Arduino Uno to be independently powered from the potentiometer servo shield. We can expand the robot by installing the Bluetooth module on the connector, or we can install another shield underneath the potentiometer shield. In case there are conflicts with the pins, we can also replace the potentiometer shield with, as example, universal sensor shield like this one. If we wish, there are a variety of other shields that we can use to upgrade the module, as well as connecting other sensors and modules to the top of the shield, or if we use sensor shield, add even more sensors to the different connectors. The robot can be programmed both with the Arduino IDE and with Zuino. With Zuino is by far the easier way to program it. We can communicate with the robot from Delphi application multiple ways. The simplest way is using serial port over USB. Alternatively, we can use Bluetooth if we add Bluetooth module to the shield. If we install a Wi-Fi shield, we can also use Wi-Fi to communicate to the robot. Finally, we can replace the Arduino controller board with a different controller that has built-in Wi-Fi or Bluetooth. When working on a robot project, we are likely to encounter a variety of challenges. There are often shields using the same pins, causing conflicts when trying to use the shields. Some shields are simply not compatible with each other, and we have to look for alternatives. There are sometimes also electrical problems, such as power noise causing the boards to reset, bad wires, back connections, reverse plug connectors, and many others. There are also mechanical problems. Sometimes servos can get stuck, rods can get jammed, wires can entangle into the moving parts, or bolts and nuts getting on the way of the movement. When doing communication, there are also a number of things that we have to pay attention to. We have to be careful to select the right serial communication speeds, Wi-Fi host names, port numbers. In Bluetooth LE, we have services and characteristic get values that we have to enter correctly. When developing the Delphi projects, we also have to pay attention to project settings. When we work as example with Bluetooth, we have to make sure we have the right Bluetooth permissions properly set. Finally, as usual, there are always a variety of coding challenges and surprises when working with the hardware. In this session, we will use animation timeline to control the robot. The timeline has channels controlling the servos, and we will need to have the right values to position the servos properly. The simplest way to achieve that is to manually position the robot, controlling the servos with the potentiometers, and once positioned, to record the values so we can use them in our animation timeline. For this, we'll write a simple Visuino application for the robot and a small Delphi application to display and record the values. We will start with new Visuino project, click on this drop-down button and select Add Shields. This will allow us to add shields to the Arduino. Expand the robots category and select the Sinwing for potentiometers and servos shield. Click on the Add New Item button to add the shield and close the editor. This will add the potentiometers and the servos from the shield to the Arduino. Now I will add a packet component to send the potentiometer values to the serial port. The packet is capable of packaging multiple channels together to send over single serial communication. And now click on this button, select Analog Channel and add 4 of them to the component. Close the Elements Editor. Now I can connect each of the potentiometers to the corresponding channels. And the output of the packet to the input of the serial communication. To make sure the packet communication is reliable, it is highly recommended to always add header marker. This will allow the beginning of the packets to be discovered and the communication to automatically synchronized. Not adding head marker may lead to unreliable communication. We can simply connect the potentiometers to the servos, and I often do that. However, if we move the potentiometer too fast, the servo may become a little jerky. It is better to smooth the operation by adding ramping components. I will add 4 ramp to analog value components. Select the components in the toolbar, right-click and select Out Multiple Components, and you can enter the number of components you want to be added. And I will connect them to the servos. I will set the initial value to 0.5 to have the servos centered. And now all I need to do is connect each potentiometer to the corresponding ramp to value component. The project is ready. Before we upload the code to the Arduino, we need to make sure that the Arduino and the servos are powered separately. The servos consume quite some power, and it is very dangerous to power them from the Arduino. Even if we don't damage the Arduino, when the servos start moving, we'll have enough power noises that the Arduino is likely to reset. For this, we'll use the power adapter included in the kit to power the servos, and we'll use the USB to power the Arduino, disconnecting this little jumper here. Now I'll go ahead, connect the USB port, switch to the Build tab, select the correct COM port where the Arduino is connected, and click on this button to upload the code. If necessary, the code will first be compiled before uploading. Now, as you can see, I can use the potentiometers to control the robot and position it the way I want. I can also connect to the COM port and monitor the positions as example on the scope. The Visuino project is ready. Now we'll create Delphi application to receive, display and save the values. I have already started a new VCL project. To receive the data, we'll need to add a COM port component. The component is part of the communication lab. Then we'll need to unpacket the 4 channels for the 4 servos. We'll use unpacket component, also part of communication lab. We can double click on the unpacket and add 4 floating point channels. Make sure we set the same header marker we used in the Visuino. To work with the 4 values received by the unpacket, the simplest way is to add 4 SL generic real value components. The unpacked channels have events, however, the generic real value components are much easier to work with. Now connect the COM port to the unpacket and the 4 floating point channels to the generic components. Since I plan to display the values from the components, I will need to synchronize them with the main thread. I will set synchronization as single buffer since we just want to display the most current value. By default, the COM port component as well as the serial communication in the Visuino will have a speed of 9600. This speed should be sufficient for this project. Double-click on the COM port component to select the COM port where the Arduino is connected. Now I will add 4 TEdit components to display the values. For each of the generic filters, I'll double-click to create the onProcess data event, and I will assign the text of the corresponding edit based on the value received by the filter, and I will do some formatting to display it with limited precision since the values will be somewhat noisy. the code in the 4 events is identical except the edit that is being accessed. Now we can try to run our project and see if we will receive the values from the robot. As you can see, we are reading the values, and if we move the robot, the values will change correspondingly. We can record the values from here. However, I will make the project a little bit easier to use. I will quickly arrange the key edits, set them to be anchored to the right, add a memo component, anchor it to the 4 corners so it will resize with the form, set the vertical scroll bar to be visible, and now I will add 4 buttons. Again anchored to the right. For simplicity, I will use copy and paste to replicate the button with the settings. We'll set the caption of the first button to be add, second clear, third load file, and the last one save file. Before I do anything else, I will add one more edit to add nodes for the position, again anchor it to the right. I will name this edit node edit. And now I can start adding the code for each of the buttons. For that button, first I will add all of the text from the edits on a single line, and then I will clear the node edit, text, so I can enter new information. The clear button will simply clear the lines, and for the load and save I will need load and save dialog. So up, open dialog, and save dialog. For each of them, I will set default extension and populate the filter. And for the load button, if open dialog execute succeeds, we will load the lines from file. We will do something very similar for the save button. except it will be the save dialog, and instead of loading, we will be saving. Before we try the project, we will just clear all the values from the edits and the memo. And now we can try the project. We can position the robot at the position we would like to start. Enter a name for the position, as example start, and click the add button. As you can see, the position is recorded in the memo. Now we can move the robot to the next position. As example, just closing the clock. Type a note and click add. This way we can start building our timeline for the animation. And we can save at any point our recording and continue later. We can open the recording in Notepad when we populate the timeline. This should make our life much easier. Now we can go ahead and record all of the movements in preparation to use them for the animation timeline. Once we have all the robot positions recorded, we can start creating a timeline. For this, we will use the timeline component from Animation Lab. Again, I have already started and saved an empty Delphi VCL form project, and now go ahead and add a timeline component. I will double click on the component to open the timeline editor. And I will add 4 real timelines to it. I have prepared a notepad file with the values we will use for the timeline. I will populate the values in cubic spline. We can do it with linear interpolations, however, cubic spline will make it much smoother and more interesting. So I'll go ahead and add a cubic spline. And I will add 4 points inside the spline. I'll repeat this for each of the channels. Next, I will position the points to spread relatively evenly. We don't need to be very precise about this, we can always move them a little bit around if not happy. Our points look quite good. Now I can expand a little bit the timeline, setting the interval to 5 seconds. To make our life easier, I will make RadStudio to dock on one side and dock the notepad on the other. Now I can go ahead and start populating the values. We need to set the initial values into the initial values for each of the channels. For the final values of each of the splines, we'll put the final value of our sequence. For the first point, we'll put the value from here. We'll repeat this for the rest of the points. Our timeline is finally done. Since in my case I recorded it from left position all the way to right position, I would like to also add 2 linear movements to move the robot from right to neutral central position and from neutral central position to the left. For this, I will simply add a couple of linear interpolations at the end for each of the channels, and I will insert linear interpolation at the beginning. and I will do few adjustments for all of the points. To get those positions, I again use the same recording application we did earlier. After some experimenting, I am finally quite happy with my timeline. To be able to start our sequence, we'll need to add a button. We can write code to start the timeline with the button. However, instead I will use visual live binding with OpenWire. I will select Add New Visual Live Binding for the timeline. Search for Start and add multi-sync pin for it. Select the button, switch to the events and add clock source pin for the on-click event. Switch to the OpenWire view and connect the button to the timeline. To make sure the timeline doesn't start as soon as the application starts, I will set the enabled to false. The project is ready to start adding communication with the robot. The simplest way to control the robot from Delphi is to use the serial port. For this, we'll need to create a simple Visuino project to receive the data and control the servos. Start with new Visuino project. Add the shield. Add 4 ramp to analog value components to smooth the servo operation. Connect them to the 4 servos. Set initial value to 0.5 to make sure the servos are centered initially. And now we'll need to add unpacked component to unpack the data that we will receive from Delphi. We need to add 4 analog channels for the 4 servos. Set header marker. Make sure we remember the values we set here so we can set them the same in Delphi. And connect the 4 channels to the RAM to value components. Connect the input of the unpacked component to the output of the serial port. Since we will be sending quite some data, we should increase the speed of the serial port. As example, to 115-200. This should give us relatively fast and reliable communication. Switch to the Build tab and make sure that the correct COM port is selected. Click on the Upload button. If necessary, the code will compile and then upload. The code is uploaded and our robot is position centered. Now, in our Delphi application, we can add the components to communicate with the robot and send the timeline data. We'll add a packet component to packet the 4 channels together. Make sure we add the same header marker that we set in our Arduino project. Double-click on the component to add 4 floating point channels. Not to overload the communication, we will set some relatively low but still reasonably high clock rate for the data. For clocking, we will use a clock component. And we'll connect the clocking component to the packet component. We'll set it to send 15 samples per second. This should be fast enough without overloading the communication. If we don't connect the clock, anytime data is changed, it will immediately be sent over the serial communication. Sometimes it could easily overload the communication. I will also connect the 4 channels from the timeline to the packet component. Now all I need is to add a COM port component to send the data. Make sure I select the right COM port and the same speed we set in our Arduino project. Connect the output of the packet component to the input of the COM port and our project is ready. If we want, we can add a couple of gauges to show us the current positions of the servos. I will set the max value for the gauges to 1 and I will connect the gauges to the corresponding channels. And we can test the project. Click on the start and see the movements of the robot while monitoring the movements on the gauges. Next, we'll try to control our robot over Wi-Fi. For this, we will need to install a Wi-Fi shield. I will use the Adafruit Airlift Wi-Fi shield This is a very nice shield that has a dedicated ESP32 based Wi-Fi controller on board. However, unfortunately, this shield is not compatible with the potentiometers and servos shield. Some of the pins are used on both shields, and if you try to use them together, you will have conflicts and the Wi-Fi will not work. For this, I will also replace the potentiometer servo shield with a generic sensors shield like the one shown on the picture. When we install the new sensor shield, we will need to connect the servos to pins that are not used by the Wi-Fi shield. For this, we will need to figure out which pins are available for us to connect. For this, we can use Visuino to help us. We'll start new project and we'll add the Airlift Wi-Fi shield. The shield will immediately show which pins are in use. If we connect anything on the shield, it will also immediately gray the pins. So at the moment we can use any pin that is not gray. I will also avoid using the chip select pin for the micro SD. So this means that the best pins for us to use will be 9, 8, 6 and 3, going sequentially. We'll install the servos on these pins. Before we start replacing the shield, make sure to disconnect all the power and USB from the Arduino and the shield. Next, I will go ahead and carefully disconnect the servos. I will try to keep their order in terms of cables, so it will not be confusing when we connect them to the sensor shield. Now very carefully grab the shield itself. Avoid grabbing the potentiometers because they are fragile and you can easily tear them off the shield. The best points are probably here, here and here. And start carefully unplugging it from the Arduino. Put the shield aside and bring the Airlift Wi-Fi shield. Make sure you have a shield that has both male and female connectors. I have even made a video how to install the proper connectors on the shield. I will post it in the resources at the end of the slideshow, and also will post under the video when I post on YouTube. Next, carefully align the shield with this protruding outside matching on both boards and this connector matching the Arduino connector underneath. And carefully plug the shield, pressing on the connectors. The shield is properly installed. Before I install the sensor shield, I will need to connect power to it, since we would like to be able, the same way as with the potentiometer shield, to have the servos being powered separately from a power supply, using this jumper to separate or join the two powers. I will use this connector with wires and a small screwdriver to untighten the connector. The shield, this particular one, has the VCC and ground clearly marked. I have checked, and the colors on my particular cable match. Make sure by measuring the voltage on the cable when connected to the adapter that this is positive and this is negative. And connect properly to the connector. The red to VCC. And tighten. And the black to ground. And tighten. The shield is ready to be installed on top of the Wi-Fi shield. Again, this uniquely looking side of the shield with this sticking part has to match the same sticking parts on the Arduino and the Wi-Fi shield. Place the shield so it is properly aligned with the connectors. Like this, and plug it in place until it snaps. Now we'll go ahead and install the servos. Hopefully I still keep the order correct. Now before you rush to plug them in, pay very careful attention to these letters here. This is ground, V is power, VCC, and S is signal. Make sure you properly orient the connectors and don't plug the servos in opposite order. It is a bit confusing because in the potentiometer shield the order is reversed. Signal is here, where signal on this shield is here. So you have to reverse the connectors when you unplug from this shield and plug on this shield. Pay attention to the order. This is one of the pitfalls of working with robots. So let's consult with our nodes. The first connector will be connected to signal number 9. Connector number 9 here. So this servo is connected to number 9. The next servo is connected to number 8. Then number 6. And again, remember what I said about the pitfalls of reverse connectors? I succeeded for a brief moment to connect them with the wrong orientation. The orange has to be on the side of the signal. The next one goes on number 6. And the final one will go to number 3. If I have not messed up the order of the servos, everything should be fine. We'll discover very soon when we start testing the robot. Our shields are installed, the servos are connected, and we can start testing the robot. We can try to make sure that the cables are not impeding the robot. As I mentioned earlier, entangled cables are a common danger when dealing with robots. I need to make sure there is enough slack to this servo not to impede the movement. The robot should be ready for Wi-Fi control. Make sure the connector here is disconnected, the jumper is disconnected, so the power from the shield will go only to the servos, and the Arduino and all the electronics will be powered through the USB port. This way, preventing any damages to the USB from the two power sources fighting each other. Now we can go ahead and create our Visuino project for the Wi-Fi control. I will start with new Visuino project. I will click on this button to add Adafruit Airlift Wi-Fi shield, configure the shield. For this, we'll need to add access point to have the Arduino connect to it, and enter the password. Next, I will add a socket. We have variety of options. I have decided to make my Delphi application to be server and have the robot connect to it. This way I can have few robots connecting to the same server and being controlled at the same time from the same application. So I will add TCP/IP client socket. For host, I will enter the name of my computer on the network, and I will enter a port 222 as example. Our shield should be fully configured. Next, we will need to add servo components. Search for servo in the toolbar, select the servo component, and add 4 such components. We will start adding them from the bottom to the top. So servo 1 will be connected to digital pin number 9, servo 2 to digital pin number 8, 3 to 6, and 4 to 3. This matches the order of the servos on the potentiometer's servo shield. Now, to make the servo movements smoother, I will add ramping components. Select ramp to analog value from the toolbar and add 4 of them. Connect them to the corresponding servos. Next, we will need to unpacket the data. Add Unpacket component. Click on the Tools button to open the editor and add 4 analog channels. Close the editor. Make sure you enter some values for the head marker and make sure you remember the values so you can enter the same values later in Delphi in the corresponding packet component. Connect the channels to the ramp components. To make sure the servos will be positioned centered when you power the robot. Set initial value for the ramp to value components to 0.5. Now I can connect the input of the unpacked component to the output of my socket. Our project is ready and we can upload it to the robot, but we can do one more improvement. The shield has RGB LED on it. We can use the LED to indicate our connection status. For this, I will add digital to color converter. Set the false value to red and the true value to lime. Connect the output of the component to the input of the LED and the input to the connected output of the socket. The project is ready and we can upload it to the Arduino. Switch to the Build tab and make sure that the correct COM port is connected. Click on this button to upload the code. The code is uploaded and you can see that the Wi-Fi shield is trying to connect to the socket. Now we can go ahead and modify our existing Delphi project to send the animation timeline over Wi-Fi. Select the COM port and remove it. Instead of COM port, we will add a server socket. We will set the port of the socket to 222. Switch to the open wire diagram and connect the output of the packet to the input of the server socket. Now we can run the application. A Windows security alert is likely to pop up. We need to allow access for the socket port. If we connect power to the robot, you will see that the Wi-Fi shield will show red LED light. And within few seconds, when connected, the LED will turn green. Now we can try to control the robot. As you can see, it works. We can repeat again the same. Depending on the quality of the Wi-Fi, the robot sometimes will move smoother, sometimes jerkier. To control the robot over Bluetooth LE, in Arduino we can load the already created serial control project and simply change the serial port speed to match the speed of the HC08 module, typically 9600. The sensor shield that we installed on the robot for the Wi-Fi has connector for the Bluetooth module. Unfortunately, they have installed on my one male connector, which makes it a little bit more difficult to connect to the Bluetooth. I will need jumper wires. Instead, I will go ahead and put back the potentiometer shield, which has the proper connector for my Bluetooth. I will go ahead, remove the shields. I can leave them connected together. Disconnect the servos. And connect the servos to the potentiometer shield. Make sure you orient the connectors properly. Pay attention that they are 180 degrees compared to the other shield. And go ahead and connect in the same order. Make sure that the signal is the white or orange wire and the minus is the black wire. All the connectors are in place, and yes, ground is properly connected on all the connectors. Now I can go ahead and install the shield. Installing single shield is much easier than installing a stack of shields. Now I will reopen the serial port project in Arduino and change the serial port speed to 9600, which is the speed of my Bluetooth module. Make sure that on the sensor potentiometer shield the power jumper is disconnected, the Bluetooth module is not installed, and connect the USB cable to upload the code. Click on the upload button to upload the code. Now I can disconnect the USB, connect the jumper so we can power both boards from the same power connector. Take the Bluetooth module and make sure I install it matching the pins as described here on the board. VCC to VCC, ground to ground, TX to RX, and RX to TX. They have to be crossed because transmission on one board is receiver on the other one. Connect the power adapter and our robot should be ready to be controlled over Bluetooth. To control the robot over Bluetooth LE from Delphi, I will create a FireMonkey application. I will start by creating new multi-device application in Delphi. Select blank application, add 4 track bars, make them vertical. I'll start with 1 track bar, position it the way I want it, set the max to 1, the value to 0.5. Since the servos have values between 0 and 1, they're normalized, we will send values between 0 and 1 from the track bar. Anchor the track bar to left, top and bottom. And now I will use copy and paste to add 3 more track bars. And now arrange them roughly equally spaced. Next, I will add a shape indicator to show me when I am connected to the robot. I will use circle for this. To access the Bluetooth LE, I will need Bluetooth LE component. In order for the component to work, I have to enable the Bluetooth permissions for the project. Both Bluetooth and Bluetooth admin will need to be enabled for the Android platform. Since I'll be running Android, I need to also grant permissions at runtime. For this, for the form on create, I will need to add the following code. In order the permissions code to work, we will need to add few units. We also need to provide these two methods in the form and their implementation. Now I will set the target to Android, in my case 32-bit. And I will make sure that I have selected the connected device. When we receive permission, we will start discovering Bluetooth devices. Now I'll go ahead and start adding code for the discovered devices. I have already prepared the code and I will quickly go over it. Here we will go through all of the devices and we will search for specific service. I will add the constants for the service and characteristic that we will use. I have them prepared. These are the service and the characteristic used by the HC08 to send serial data over Bluetooth. I will also need 3 variables to store my service, device and characteristic. So the code will go through all of the devices, discover the services, search for the service by GET, and if the service is discovered, assign the device to the device variable. Connect to the device and search for the characteristic. If we discover the characteristic as well, we search it also by GET. Here the 2 GETs. If all is successful, make the circle line color. And we can break the loop since we have discovered our device. The Bluetooth LE component requires also the discover services to be implemented in order for us to be able to get the service. loop through the services and simply access the characteristics in each service. To send the data, we will use packet component. Set head marker the same as in the Visuino project. Double click on the component and add 4 floating point channels for the 4 trackbars. To send the data, we will use generic filter. We will connect the packet component to the generic filter. Double click on the filter to get the on-process data. Here, if we have characteristics discovered, we will loop through all the items in the received buffer and will send them byte by byte into the characteristic. To send the values from the trackbars, I will implement a simple function. It will simply get the values of each trackbar, invert it, and then assign the calculated value to the corresponding element of the packet component. We will call this function on form create and also in the onChange event for all of the trackbars. Any of the trackbars will call the same function. To specify how often the data is being sent, I will also add a clock component. I will set a rate of 10 times per second and I will connect the clock component to clock the packet component. By default, the Bluetooth is not enabled and we will need to enable it. Now I can go and run the app. Allow the Bluetooth. And now we are connected to the robot. And we can start controlling the servos with the sliders. We have Bluetooth control for the robot. So to recap, during the session I have shown you how to install and work with Arduino shields and modules, how to program the robot with Visuino, how to receive and record data from the robot with Delphi, how to create and populate animation timeline, and how to use it
to control the robot. How to control the robot from Windows and Android Delphi applications, and how to communicate with the robot over serial, Wi-Fi and Bluetooth communication. Here I have prepared a list of resources and more information for Visuino, the Mythos software components used in the projects, where you can find the robot and assembly video tutorials for it, links for the HC08 Bluetooth LE module, the Wi-Fi shield, the sensor shield, and information how you can solder proper pin headers to the Wi-Fi shield so you can install it between the Arduino and another shield. Thank you for listening. Once again, my name is Bojan Mitov, the president of Mitov Software. My email is mitov@mitov.com, and here is the list of the Mitov software products: Video Lab, Video Processing Library; Audio Lab, Audio Processing Library; Signal Lab, Digital Signal Processing Library; Vision Lab, Computer Vision Library; Plot Lab, Data Visualization Library; Instrument Lab, Visual Instrumentation Library; Intelligence Lab, Artificial Intelligence Library; Logic Lab, Boolean Logic Library; Animation Lab, Universal Animation Library; Communication Lab, Serial and TCP Communication Library; Control Lab, Industrial Control Library; Visual Live Binding, Universal Visual Live Binding Library based on OpenWire; Mitov Runtime, a free Delphi library; OpenWire Studio, a graphical development environment for Windows; Visuino, a graphical development environment for Arduino controllers; Visuino Pro, a graphical development environment for Arduino-based industrial PLC controllers. Mitov Software also maintains a number of open source libraries, including OpenWire and iGDI+. Thank you for listening, and now it's time for questions and answers.
All right, fantastic, Boyan. Thank you for that session. Always learn quite a bit. If you want to, I think it looks like you're online. If you want to come on and we'll do the Q&A here. There you are.
Hello, everyone.
Wow, you got all sorts of stuff going on in the background there.
Yeah, the usual chaos here.
Yeah. So I have to share a story. I don't know if this group has heard it before, but I remember when you did your introduction for announcing Visuino, and you were showing it off. I'm like, oh wow, this is really cool, and you're showing off all your tools. And I hadn't actually looked at buying any of your tools previously to this or not. I mean, I should have, but no excuse for that. But you're like talking about Visuino, and I'm like, oh, that's so cool. And then you announced the price, and I think when you released it, it was like $9.99, $10, and I think you've raised the price a little bit since then, which is it was still a really good price. But in my mind, I'm like, when you said $9.99, I'm like, oh, okay, $999. That's a reasonable price because that's a really powerful tool. And then when you said, $9.99, I'm like, oh my goodness, I actually went out and bought it in a number of your other libraries right away, just because it's such a neat, powerful framework. And you have a free community edition on your libraries and stuff too for non-commercial stuff. So anyway, I'm a big fan of your stuff, and I think it's incredibly reasonably priced, and love the fact that you have a free version as well. So
Thank you.
This is not really a question, more of a statement, but I'm not sure how to pronounce your name. Said Boyan is simply a genius. That is true. I would agree. When it comes to this stuff, you really know your stuff and really appreciate it.
Thank you, guys.
I noticed you're on answers for the questions as we went along. Jamie asked about your Comport component, and that's part of your communications lab, which is on mitovsoftware.com.
Yeah, it's meetup.com, by the way.
Yes, midtoff.com. Yep, sorry, you're right.
Yes.
Of course, you should know what your website is. And then you had a link for the robot as well that you're using in there.
Yes, I put a link on the, for the robot for the Wi-Fi shield that I used from Adafruit. Also for the Bluetooth module, the HC08 Bluetooth module, and I added links for the assembly videos for the robot and everything else. Because I mean, this is nice, very affordable kit. I quite like it because, among other things, it came with servos with metal gear, which are much higher quality servos. And this kit was the first time I actually encountered servos with metal gears, because otherwise I used the old crappy plastic servos. And I was so impressed that I actually posted some video comparing and benchmarking the plastic servos versus the metal gear servos, just because I was so impressed by them. And yeah, the robot for this type of, I mean, flimsy, small, cheap robot, it performs reasonably well. I mean, for its price, it's a toy that's probably worth having. And Banggood every now and then has some good deals. I got my one exactly during one of the really good deals. So yeah, it's a very decent robot. So I put a link for the robot as well. And yeah, it always there. And of course, I put a link for the assembly videos, because the robot, as I mentioned probably, came without instructions how to assemble it. So I had to scratch my head and figure it out.
You have a lot of great videos on your website. Can you put the link in for the robot again? Someone's asking about where to find it.
Yeah, I will put it 1 second. I have it here. The robot right here. Okay. So I'm putting the link in. I'm putting it in the YouTube chat. Let's see.
Okay. Yeah, it'll show.
Yeah, that should be there. And yeah, the rest. Of course, people can watch the video, but I'll try to post some comments, and I'll have to see where to upload the presentation, the PowerPoint presentation, which also has the...
I'll get you the email for the GitHub for that.
Yes, yeah, I'll put it there.
Here's the Arduino software that Boyan used for the Arduino programming. Here, and if you go here to order, he has the free edition, which is a little limited, but does have quite a bit there. And then the standard, and I'm pretty excited about your new professional version. Has a lot more power in there for stuff. There's a number of things, because I remember playing with your the standard version, and when it was really new, and there's some things I was like, oh, you know what I'd love, and you're like, I have a professional version. I'm like, yes. So yeah, really cool. You can check that out here, and then I don't have Midtoff software anymore. Let me open that back up. You used a number of your products in their communications lab. Was the one that was doing the serial port?
I used the communication lab for the serial port, instrument lab to show the gauges, and I also used animation time lab, animation lab for the animation timeline when I was controlling the robot.
And most of your, all of your labs, I believe, you have a free community, like light version, non-commercial version. Is that right?
Well, it's not light version. It's actually a full version. So
just for non-commercial use.
The full version is available for non-commercial purposes without source code, naturally. The only restriction per se on the free version is that some of the visual components will have a small text on them that says free version, and that's the only downside of having a free version.
And so communications lab is $39 without source. Yeah. Or $200 with source. But yeah, that's a really good deal for what's in. I mean, all these are great deals. You can get, of course, the
I'm
complete set
trying.
on here too.
Yeah, I'm trying to make it affordable.
Well, I know that you put a lot of effort into these, so that's a really, really good deal, knowing how much goes into these and how powerful they are. And then I love occasionally we'll see some of the projects people work on, do some with amazing stuff with your stuff. Honestly, personally, for me, whenever I see something cool people do with Delphi, that's always really inspiring. And then I'm sure for you as well, all the amazing things that your customers do with your software, your libraries. Must be inspiring. Anyway, I didn't see the link pop up here for. Oh, you can't paste links if if you're in from Restream on the side you're in right now for Q&A. Over on the right hand side, do you see the chat window? Oh, you don't see.
Yeah, I
Send
see.
it to me.
I see.
Do you? So
Yeah,
if you paste it in here or give it to me through Skype, I'll put it in
okay.
here so everybody can
Okay.
see
Yeah,
the link.
sure. I will paste the link there as well. As I said, 1 second. As I said, I pasted it in the YouTube channel. I have not used.
I think
this,
it gets filtered from there.
Oh, really? Let me see how to paste in this thing. Where is the text box?
So try pasting it. Just paste it to me in Skype, and I'll put it in.
Okay. I don't see. I just did.
You might not have access to it, but there you go. I just put it in there. And so now it should show up for everybody. Oh, actually, I could open it up too. It's $48. It's 17% off right now on Banggood. Ships from China. You know what? I don't think I actually ever ordered this. I went to order it and then didn't order it, so I'll have to get one in. I've got so many little kits and stuff. Oh, I'm not sharing my screen. There we go.
Yeah. By the way, thank you to Jamie Bucket. Yeah. I hope I pronounced it correct. Yeah, again, I mean, sometimes if you're persistent and you keep checking, you may get better price than this one. So I was lucky right after the COVID, I mean, for good or for bad, they had very big sales and I was able to get a fairly good deal.
Mhm.
And yeah, you have to solder it and you have to assemble it, which again, some people may find it part of the fun. I personally enjoyed assembling
You do
it and
too.
making
Actually,
assembly videos.
I really do enjoy that. I put on a movie, usually one I've seen before, and then just sit down and I have my work light and soldering station and just sit there and spend a couple hours. I find it really, really relaxing and a great way to relax and enjoy that. Jamie says, now I need a robot. There you go. There's the link, Jamie. Now, one question I had. So Jamie commented, says the components add an OpenWire tab to the form. Mind blown. There's a way to use OpenWire Studio via code as well. You don't have to do it via the GUI. I mean, the GUI makes it a lot easier, but you can do it via code too.
Yes. Yeah. You for each of the pins, I mean, yeah, it's a bit a longer story, but for each of the pins, there are methods like connect, disconnect. So you basically can establish connections between pins, even during execution time, and modify what's connected to what at runtime, right? So yeah, it's fully accessible by code.
All right. Well, thank you so much, Boyan. I always appreciate you coming out and helping out with these. And I know you get this. You spend a lot of time going out to like local events and stuff and showing off this as well, which is it's great. I'm the same way. I always love getting a chance to go out and show people all this stuff because honestly, that robot there, even at the full price, That's pretty amazing that that's something, you know, that an individual can get and build and have at home and do stuff with. And, you know, it's not the big, huge industrial robots, but still pretty amazing, honestly, what you can do these days.
Yeah, and the kinematic design actually is quite interesting. I mean, when I started building it, of course, without instructions initially, I was confused what goes where. But you can see that it's actually a result of more or less open source evolutionary process. I have seen older versions of the same robot, and I have seen how their design has evolved. So it's actually quite interesting device from a mechanical cinematic point of view, even. I mean, to play with it and to experiment with it.
So Jojo's asking, says, which libraries do they need to build this? So I know the communications lab is what lets Delphi talk to the Arduino. And then the other ones would technically be optional. I mean, the timeline one is useful, but
they're technically optional. So the bare minimum you need is communication lab. Animation lab allows you to do the timeline, but again, you can create your own timeline with code. So shouldn't be that big of a deal to write a bunch of code there. For the Bluetooth control, I use the standard Delphi Bluetooth components. And then the instrument lab was purely cosmetic. You don't need it. I simply used it to have nice gauges showing me how the robot is moving. If you don't put the gauges, you do not need instrument lab. So yeah, the bare minimum is communication lab, and if you want timeline, then animation lab. That's the bare minimum.
Yep. And yeah, and you can use the free version to get started with all of those.
It's all available for free for personal use.
Yeah, so Jojo, you can get all three of them for free for personal use, and then try it out, and then decide if you want to get the. I would recommend buying them because I'm a big fan of Boyan, but and yeah, you could do it all with Community Edition as well.
Yeah, it should work with Community Edition, and the free versions are fully capable of doing everything that I showed. The only difference is that, literally the only difference is that the gauges will have a small sign on them, semi-transparent, that says free version. That's all. Everything else will work exactly the same as I showed.
All right. Fantastic. And I think, let me double check, but I think actually so someone could watch the full day stream, but I think the standalone version of this video is also live on YouTube as well. Let me double check and see. It is. Yep. So I'll put the link in here for that as well. If you want to just see the standalone version of this one, it is on the learndelphi.org YouTube channel already. It just doesn't have the Q&A portion at the end, but we'll chop this up and add it later with a link. So anyway, thank you so much, Boyan. I was just chatting with Boyan during the session because I have a number of projects. I'll show you the latest project I just got. I just got this week. This is from Addwater and Stir. It is a Altair 8080 replica. Oh, there it is. Got the little badge for it. And it's got a Arduino Do, which I'd never heard of the Arduino Do before, but it has an SD card slot on it, which might be right. Or there's an SD card reader for it. And then a bunch of switches and lights. So the Altair, it had switches and lights on it, and that was how you programmed it. Is little flip the switch, and I just it's totally not practical, but I love the aesthetic of having the blinking lights on the front of it, and just yeah. This one has a wireless module that you can add to it as well to connect to it wirelessly and get a wireless terminal for it, but that's in the little bag here. Anyway, I'm real excited about that. So Boy and I were just chatting about possibly doing like some collaborative streams or something where we can build some fun projects. He's always building all these cool stuff on his channel. He has all the fun. I want to do it too. There's the wireless module. So yeah, that's something. Stay tuned to Boyan's channel, or I'm sure you'll find us, or hopefully find us online. If you are interested, check out Boyan's YouTube channel, which you should see linked from his comments there. And he's got a lot of great assembly videos and stuff. And maybe you'll see us collaborating on some fun projects in the near future.
Sounds good.
Yep. All right. Well, thank you so much, Boyan, and thank you everybody else. This is the end of day 3. Wow. Man, I always get excited about these boot camps, and then I forget how much there is involved. And then I'm halfway through. I'm like, oh my goodness, so much to do, so much to do. So we'll see you all tomorrow morning, bright and early, for our next session Thursday. Yeah, I'm sure we'll see Boyan around at future sessions or future events. He only got the one session on this conference, but we'll see you around. If you're not registered yet, make sure you visit learndelphi.org and register for the conference so that you'll get emails with follow-ups and other things. We have some other stuff in store for everybody, so do register for that, and we'll get you some links to resources and stuff. And make sure you are subscribed to our YouTube channel, learndelphi.org YouTube channel. So if you're watching this from our Facebook page or somewhere else, make sure you do visit the learndelphi.org YouTube channel and subscribe. If you haven't downloaded Community Edition, all the stuff we've shown you so far, works with Community Edition, which is completely free for hobbyists and students. So check that out. If you are a professional developer, you'll probably want to download the 30-day trial, which has more features than Community Edition, but also it's a trial. The Community Edition is specifically licensed for non-professional developers, people that are just students and hobbyists. And you can check out PyScripter as well. I had someone earlier say that they had downloaded PyScripter after hearing about it during the boot camp, and they were really impressed. It's completely free Python IDE, really powerful, great Python IDE for doing things. It has the ability actually to connect to a remote machine. You could write your Python script. It will deploy it remotely over SSH and run it on a remote computer. So that's a great option if you want to, like, for example, run it on a Raspberry Pi or something like that. So, and with that, let me check real quick chat. It looks like that's it. So yeah, thank you to Ian, who was a host earlier today. He and I will be swapping off throughout the rest of the week, and everybody else behind the scenes, Brian and Martha and everybody else. Gosh, I can't remember. If I try and list names, I'll just miss names. But yeah, there's a lot of other people going on behind the scenes helping out. Really appreciated. And I will see you all tomorrow. Take care and happy coding. Bye, everybody.